Hello. Esteemed guests, distinguished speakers, colleagues, and participants. Good morning and a warm welcome to the National Conference on Ethnic Vegetables organized by Dr. YSR Horticultural University, College of Horticulture, Anantarajpeta. It gives me immense pleasure to address this esteemed gathering of researchers, experts, and enthusiasts who have gathered here today. As the organizing secretary of this conference, colleagues and participants, good morning and a warm welcome to the National Conference on Ethnic Vegetables organized by Dr. YSR Horticultural University, College of Horticulture, Anantarajpeta. It gives me immense pleasure to address this esteemed As the organizing secretary of this conference, I am honored to have the opportunity to host such a significant event focused on ethnic vegetables. It is with great pride and admiration that I acknowledge the visionary leadership of our Vice Chancellor, whose ideas and passion have brought forth this remarkable event. His deep understanding of the significance of ethnic vegetables and his commitment to promoting sustainable horticulture have been instrumental in conceptualizing and organizing this conference. I would like to extend my sincere gratitude to all the participants for their presence and support. I also want to express our deep appreciation to our esteemed guests, keynote speakers, experts who have generously accepted our invitation, and also the farmer as well as our sponsors who have come and who have come here to make this program a success. I would like to invite our chief guest of today's function, Honorable Vice Chancellor Dr. T. Janaki-Ram Garu, who has joined us online. I would also like to invite Dr. A. Vishnuvardhan Reddy Sir, Honorable Vice Chancellor, Angrao, and Dr. V. Padmanabha Reddy Garu, Honorable Vice Chancellor of Veterinary University, who have joined us online. Now I request our beloved Associate Dean to join us on the dais. I invite Ms. Mahalakshmi to honor him with a bouquet. I request the president of today's function, Dean of Horticulture, Dr. A. Padmathamma Madam, to kindly join us on the dais and take a seat. I invite Ms. Pallavi to honor her with a bouquet. I request the guest of honor of today's function, the registrar of Dr. YSR Horticultural University, Dr. B. Srinivasulu Sir. We would be honored if you could join us on the dais. I invite Ms. Pratima to honor him with a bouquet. I am glad to invite our guest of honors, Dean of PG Studies, Dr. YSR Horticultural University, Dr. Surya Kumari Madam, and Director of Research, Dr. L. Naram Naidu Sir, who have joined us online. Now I would like to invite Dr. K.T. Venkatramana Sir, Zonal Research Head, Principal and Head, HRS Anantarajupeta, to join us on the dais. I request Bhargavi to bring the bouquet. I invite our Associate Dean of College of Horticulture, Shinala Trophy, Dr. Vijay Padma Madam, to join us on the dais. I request Reshma to honor Madam with a book. I would like to extend my hearty welcome to all the chairmen, co-chairmen of different sessions, invited speakers, students and participants who have joined this program, both online as well as offline. Now, let us start our program with a prayer song.
Mahagणपति मनसा स्मरामि महागणपति मनसा स्मरामि महागणपति मनसा स्मरामि वसिष्ठवामदेवादिवन्दितं महागणपति Mahadevasutam Guruguhanutam Mahadevasutam Guruguhanutam Marakori Prakash Mahakavyalaki Priyam Mahakavyalakadipriyam Mushikavahanamodakapriyam Mahagणपति Manasa Smarami Mahagणपति Manasa Smarami Mahagणpati.
Now I invite you all and the guests on the dais for the lighting of the lamp. Once again, I extend my warmest welcome to all of you. Let us make the most of this conference, deepen our understanding of ethnic vegetables, and collectively work towards a more sustainable and diverse food system. Now, I welcome our Associate Dean, sir, to start the conference with his opening remarks.
Very good morning. Yes. Our chief guest of today's function, Honorable Vice Chancellor, Dr. YSR Horticulture University, Dr. T. Janikaram sir, and he is the man who is behind this initiation of this program and the planning, execution, everything. And yes, it was planned in 2022 beginning, and we have this program at Anantra's page. Yes, today we are celebrating as per this desire and of motivation and all. Next, our president of today's function, Dr. A.S. Padmavati Garu, Dean of Horticulture of our university. And Madam always supportive for all the things, whatever we request, Madam says yes. That is the power of Madam. That is the affection of our Madam towards this college. And our honorable, the most honorable Vice Chancellor, Dr. A. Vishnuvardhan Reddy sir, Acharya Anjaringa Agricultural University, and Dr. V. Padmanabha Reddy Garu, Vice Chancellor of Veterinary University Tirupati, who are could not participate physically because of preoccupied things, and we are on outside the stage. And our Dean of PG Studies, Dr. Surya Kumari Garu, and Dr. D. Srinivasulu, Registrar of our university, and Director of Research, Naran Naidu Garu, and other university officials of our university, and all the invited speakers, chairmen, co-chairmen, and jury members of different sessions, and the audience who have joined us offline and online today. Good morning and a warm welcome to the National Conference on Ethnic Vegetables. Now I am honored to stand before you as a co-chairman and the Associate Dean of the Historical College of Horticulture, Anantaraj. First and foremost, on behalf of Dr. YSR Horticulture University and the organizing committee, I extend my heartfelt gratitude to all the participants for their presence at this significant event. I would also like to express our sincere appreciation to our esteemed guests, keynote speakers, experts who have graciously accepted our invitation to share their valuable insights during this conference. The theme of this conference is ethnic vegetables, holds a special place in our hearts and in our heritage. They are not only a vital source of nutrition, but also connects us to our cultural roots. In modern times, as we progress, it is a crucial and acknowledge and appreciate the value of these vegetables, not just in terms of their cultural significance, but also their potential in addressing food security and promoting healthy diets. This conference is scheduled for today and tomorrow, and it is a platform for sharing knowledge, insights, and advancement in cultivation, conservation, utilization of these ethnic vegetables. It aims to foster discussions on sustainable practices, genetic diversity, nutritional value, and the market potential of these unique and culturally significant crops. It is our collective responsibility to preserve and promote these unique genetic resources and not only carry immense nutritional and medicinal values, but also holds the potential to address the challenges of food security, sustainability, and climate change. This conference serves as a platform to foster dialogue, exchange ideas, and explore innovative approaches to conserve, utilize, and popularize these highly valuable ethnic vegetables. For the next 2 days, we will have the opportunity to delve into various aspects of vegetables, including traditional traditions associated with these unique crops. We have curated a diverse program comprising keynote lectures, technical sessions with discussions and poster presentations and discussions to share, ensure and share comprehensive exploration of this subject matter. I encourage all the participants to actively engage in fruitful discussions, share their experiences and research findings, and forge collaborations that can pave the way for sustainable future ethnic vegetables. Together, let us contribute to preserve our agricultural heritage, safeguard this health and the well-being of our communities, and promote a more resilient and diverse food system in the country. Once again, I extend my heartfelt gratitude to the keynote speakers like Dr. Ravindra Joshi, a former site coordinator, World Vegetable Center, Solomon Islands, Taiwan, and the invited speakers like Dr. Thomas from IARA, and Dr. Agustina Gerard, project coordinator from Kasaragod, Dr. Rakesh Kumar Pandey is IIVR Varanasi, Dr. Uma from LBPCR, Dr. Usha Kumari from College of Horticulture, Venkatramanagudi, Dr. M. Kavita, Associate Professor in Vegetable Science, SCRF Coimbatore, Bala Kumban from HRS, Jadapuri site, Dindigul, Tamil Nadu, for readily accepting our invitation as a chairman and co-chairman. And also Dr. Sanjeev Kumar from Jammu and Kashmir, Dr. N. Padmavati from West Virginia University, USA, and Dr. V. Sriram from IHR Bangalore, Dr. V. Sridhar from IHR Bangalore, and Dr. M. Madhavi from College of Horticulture, Venkatramanagudi, Dr. S.S. Vijay Padma, Associate Dean, College of Horticulture, Chenlatarapi, Dr. K.T. Venkatraman, Journal Research Head, Rajasima Zone, HR Sanantrapet, Dr. P. Sudhakar, Dean of Agriculture and Group, Dr. Surya Kumari, Dean PGS, Dr. SRHU, Dr. K. Swarajya Lakshmi, Professor and Head Post Harvest Management, College of Horticulture and Transport, and Dr. E. Karunasri, who is the Director of Extension and at KVK Venkatramanagudi. I extend my heartfelt gratitude to sponsors and financial assistance received from NABARD, APEDA, TTD Tirupati, Union Bank of India, Kodur, Indian Scientific Tirupati, Cross Scientific Tirupati, Rajasima Horticulture Nursery, Kodur, Durga Horticulture Nursery from Kodur, towards their generous sponsorship in conducting of this program. I also would like to thank all the participants, sponsors, organizers who have worked tirelessly to make this conference a reality. Let us make the most of this opportunity to learn, network, and collectively contribute in the conservation of these ethnic vegetables. Thank you, and I wish you all the stimulating and enriching conference ahead. Thank you once again. Thank you.
Thank you very much, sir, for such a warm welcome. Now, let us invite Dr. Joshi, sir, to give the keynote address. I would like to introduce a few words about Dr. Ravindra Chandra Joshi. Dr. Joshi is currently serving as Senior IPM Consultant, Philippine Rice Research Institute, Department of Agriculture. He has more than 25 years of rich experience in research, teaching, and extension in sustainable agriculture across Asia, Africa, Europe, and in Caribbean. Dr. Joshi had his earlier education in India. He did his BSc in 1980 from the Andhra Pradesh Agricultural University, Hyderabad, and MSc he completed from Tamil Nadu Agricultural University, Madurai campus. Later, he worked in entomology at International Rice Research Institute, Philippines. He obtained his entomology PhD from the University of Philippines at Buenos, Philippines. He is considered as one of the most knowledgeable person on all the rice insect pests, and also he is a specialist in vegetables. In fact, his expertise on the invasive apple snail is recognized internationally and is evidenced by his being consulted by other national programs in Asia, Africa, Europe, and Pacific Islands. So let the keynote address being delivered by Dr. Ravindra Chandra Joshi.
సాయంత్రం జాకి ఇంకా కనెక్ట్ లో ఉంది అందుకే వినపడలేదు జాకి కనెక్ట్ లో ఉంది జాకి కనెక్ట్ ఉంటే రిసీవ్ చేసుకోలేదు
I now welcome our guest of honor, Honorable Registrar of Dr. YSR Horticultural University to address the gathering.
Thank you, Dr. Sadharani. Good morning to all of you. It gives me immense pleasure to address on this wonderful occasion of National Conference on Ethnic Vegetables, which is being organized at Dr. YSR Horticulture University College of Horticulture, Anantarajpeta. At the outset, I would like to extend my heartfelt thanks to our Honorable Vice Chancellor, Dr. T. Janakaram Garu, who is the brainchild of this conference. So it is a really a unique conference that is being organized by Dr. YSR Horticultural University on one of the important topic that is on conference on ethnic vegetables. I'm also thankful to the Associate Dean, College of Horticulture, Anantarajpeta, Dr. Gopal Garu, and all the organizing committee members for inviting me for this national conference for 2 days, today and tomorrow. So on this occasion, I would like to extend my thanks to all the members and all the speakers, invited speakers, chairman, co-chairman, faculty members, and all the university officers, particularly the guests of honor from Acharya N.G. Ranga Agricultural University, Honorable Vice Chancellor, Dr. A. Vishnuvardhan Reddy Garu, and also the Honorable Vice Chancellor, SP Veterinary University, Dr. V. Padmanabha Reddy Garu, and the Senior IPM Consultant from Philippines Rice Research Institute, Dr. Ravindra Chandra Joshi, and all the university officers, faculty members and students, and all the participants. I extend once again my wishes for the successful conduct of this national conference on ethnic vegetables. I stand before you today with great pleasure and honor as we gather here at Dr. YSR Horticultural University, College of Horticulture, Anantarajpeta, to inaugurate the national conference on ethnic vegetables. So this conference, which is being held on 27th and 28th of this month, marks a significant milestone in our ongoing efforts to promote and celebrate the rich diversity of ethnic vegetables in our country. First and foremost, I would like to extend my heartfelt gratitude to all the participants who have joined us from different corners of our nation to be part of this great event, which is being organized here. Dear participants, your presence is a testament to the collective commitment we share in recognizing and harnessing the potential of ethnic vegetables that are our rich diversity, which is witnessed here in all the states of our country. It is through events like these that we can collectively foster a deeper understanding and appreciation of our cultural and culinary heritage. So the idea of this conference is to preserve diversity and nurture sustainability, which encapsulates our mission to conserve and promote the unique array of ethnic vegetables that have been cultivated and consumed by our ancestors of generations together. These vegetables, deeply rooted in our traditions, and have not only provided sustenance, but have also played a pivotal role in maintaining our health and well-being. Dear friends, as we embark on this journey together, let us remember the invaluable role that ethnic vegetables play in our day-to-day life. They are not just ingredients in our meals, but bear the essence of our cultural heritage, connecting us to our roots and traditions. By recognizing their importance and working towards their conservation and promotion, we can contribute to a healthier and more sustainable future. So through this conference, I think we can aim to explore the scientific and practical aspects of ethnic vegetable cultivation and their production, post-harvest management, marketing, utilization, and their best way of utilization by the human beings. Friends, our esteemed speakers and experts will share their knowledge and research findings for this conference with their great experiences and shedding the light on the innovative techniques and best practices that can help us to enhance the productivity and profitability of these ethnic vegetables. Furthermore, this gathering serves as a platform for fruitful discussions, interactions, and collaborations among researchers, academicians, industry professionals, and farmers. So it is through such exchanges we can foster a robust network of individuals passionate about growing of ethnic vegetables and paving the way for future collaborations and advancement in this field. I would like to express my sincere appreciation to the organizing committee led by our dedicated faculty members for their meticulous planning and execution. Their hard work and commitment really have ensured that we have a comprehensive and engaging program for all these 2 days. I encourage all the participants to actively participate, clear their doubts, and engage in meaningful discussions and conversations to make this moment or event most successful. I am confident thus that this conference will serve as a catalyst for new research endeavors, innovating farmer practices and sustainable business models in the realm of ethnic vegetables. Together, let us work towards the future where these invaluable treasures are cherished, protected, and celebrated. Once again, I extend my warmest welcome to all of you, particularly to all the participants of this National Conference on Ethnic Vegetables. So may this conference be a platform for insightful discussions, valuable connections, and transformative ideas that will be shape the future ethnic vegetable cultivation in our country. So I wish this National Conference on Ethnic Vegetables will be a great success in the next coming 2 days. Thank you, one and all.
Thank you very much, sir, for such a warm message and setting the outset of the program. I now invite Dr. K.T. Ramana, sir, Zonal Research Head, Principal Scientist and Head Horticulture Research Station, Anantarajipet, to address the gathering.
Good morning to all. Today is we are conducting a national conference on ethnic vegetables, which is a very rare aspect, in fact, to say, subjective. After a long gap, I think the college, yeah, I congratulate the associate dean and as well as the faculty, students. After a long gap, this initiation is taken by our as staff, college staff, for the associate dean, and it is really a good step towards knowledge sharing. So on this occasion, I actually worked on many international groups and of course graduated in agriculture. Never worked on this. So, yeah, but I attended several conferences of vegetables also. So this ethnic vegetable part is really a new topic, upcoming topic, in fact to say. So we have to preserve. There are a lot of vegetables and different wide variations in brinjal or tomato, whatever it is. So it is necessary to preserve them all. And this conference, I think, will give all informations because there are presenters across the country and also abroad. Also, some presenters are there. So on this occasion, I once again congratulate our associate dean and university, and as well as staff, faculty, and the students of this college. And I thank for giving this opportunity to the Madam Associate Dean and also other organizations. Thank you.
Thank you very much, sir. Now, I would like to invite Dr. Vijay Padma Madam, Associate Dean, College of Horticulture, Chinnala Trophy, Rajasthan. Respected dignitaries, and particularly the organizers, College of Horticulture, Anantarajpeta, Dr. YSR Horticulture University. So I thank for giving me this opportunity to share my views regarding ethnic vegetables. So ethnic vegetables are those vegetables which are grown in few pockets of our country, which are meeting the nutritional requirements of a certain group of people, where they are not reachable to many people in the other sense, because we are all accustomed to have commercial fruits, commercial vegetables, and we are fascinating towards commercial flowers, post-harvest technology of already established many horticulture crops. So in this context, this is the right time where College of Horticulture Anantarajpeta has come in to the front to conduct a seminar, a conference on ethnic vegetables, which is very, very important in the present scenario, what I feel, because they are rich sources of, as the international speaker has mentioned, they are rich sources of many nutrients, minerals, and vitamins. In personal, I have a lot of experience when I worked at Horticulture Research Station, Pandil Mamidi, which is located in high altitude zone, where I was personally involved in collection of certain medicinal and ethnic crops and submitted to the NBPGR New Delhi. So in that time, I could be able to get certain information on few crops I can share with you, like if I have time of few seconds. See, for example, we have so many amaranthus species, but we know only 5 species of amaranthus we could able to see right now in our habitats. So in that we have 3 species which are only ethnic. we'll go with only Amaranthus viridis or red Amaranthus. It's not like that. The other three species are meeting the nutrient requirements of many people in the tribal zone. So that we can see that we can tap that species or crop that can be brought to the outside of that particular area that can be studied for diversity, and then we can make it to the public for nutrient enrichment. And not only that Amaranthus, we have multi-nutrient species that you know very well, Checkermoney. And then Solanum nigrum, which we call as nightshade. And it is almost a common leafy vegetable in certain areas. You might be knowing in Tamil Nadu and Karnataka, it is a regular leafy vegetable, but it is under the traditional vegetable only. It has lot of importance as nutritious leafy vegetables and also the medicinal plant, and also it has commercial importance. So likewise, if you go on listing out the different crops under ethnic group of vegetables, there are so many. So I really congratulate sir, our associate dean sir, and also the authorities of the university for conducting this very good conference on this particular ethnic group of vegetables, so that many of the papers, I think we can expect much of the information in these 2 days conference, so that we can go ahead or go forward in this line of group of vegetables. And I thank the organizers for giving me this opportunity to share my views with all of you. Thank you. Thank you very much, madam, for sharing your experiences and giving your views on the topic. I now welcome the guest of honor, Dean of PG Studies, Dr. S. Suryakumari, madam, to address the gathering.
Respected Honorable Vice Chancellor, sir, dignitaries on the dais, off the dais, and all the participants. Good morning. Thank you for the invitation and opportunity provided to me to join and address online for this national conference on the ethnic vegetables. Vegetables, we know, today have been an integral part of human life. During worship, am I audible? During worship, spirituality, and all cultural events. Some old taboos or the rituals from Vedic ages in our civilization tell us how healthy and happy we are living with these vegetables. And we have this tradition of offering and consuming these ethnic vegetables like ash gourd, pumpkin, brinjal, bottle gourd in all our spiritual and cultural ceremonies in the Indian subcontinent, which signify and play the vital role for conservation of these traditional vegetables. The indigenous and the minor ethnic vegetables, which are known very important nutraceutical and medicinal foods, play a significant role, as mentioned, in addressing the malnutritional problems and maintaining biodiversity and ensuring the farm income. In many parts of our country, locally adjusted, the locally available land races, we know, are known as farmers' varieties, and they still contribute significantly to the sustainable food production, household nutrition, and increased incomes. Further, these indigenous vegetable species also are very well known to be adapted to this adverse climatic conditions and pests and diseases. Therefore, these can be a very good source of genes for our genetic improvement. Nurturing of these genetic assets really play a very crucial role for achieving the Sustainable Development Goals of 2023 set by United Nations. So at this juncture, in the start of this nutritional security revolution, I hope this seminar, which is organized at the right juncture on these ethnic vegetables, will give a big push to the production and consumption of traditional varieties and help further for the spread of this scientific knowledge in Indian context, wherever this increasing population and reducing cultivable area is posing impending threat to food and nutritional security. I wish you all a very productive and successful conference, and thank you.
Thank you very much, madam, for sharing your valuable insights with us. Now, I invite the president of today's function, Dr. A.S. Padmavatamma Garu, Dean of Horticulture, Dr. YSR Horticulture University, to share her views.
Chief guest of today's function, Dr. T. Janikram Garu, Honorable Vice Chancellor of Dr. YSR Horticulture University. Guests of honor, Honorable Vice Chancellor, Dr. A. Vishwanath Reddy Garu, Acharya Engineering Agriculture University. Honorable Vice Chancellor, Sri Venkateshwara Veterinary University, Dr. V. Padmanabh Reddy Garu, Director of Research, Dr. L. Narayana Naidu Garu, Dr. YSR HU, Registrar, Dr. B. Srinivasa Garu, Dean of PG Studies, Dr. Surya Kumar Garu, and Dr. S.S. Vijay Padma, Associate Dean, College of Horticulture, Chendrapati, and other invited speakers, chairman, co-chairman, faculty members, and students who have joined us, both online and offline. Good morning and very hearty welcome to the National Conference on Ethnic Vegetables. I am privileged to give presidential remarks on this occasion of National Conference on Ethnic Vegetables. So you all must be knowing that India ranked second in vegetable production in the world, and India produced 204.61 million metric tons of vegetables during 21-22 from an area of 11.28 million hectares. As a leading producer of low-cost vegetables, the country has enormous export market. Global diversity in vegetable crops is estimated to be about 400 species, with about 80 species of major and minor vegetables reported to have originated in India. Ethnic vegetables are vegetables which are traditionally in use, grown in different parts of the country, and have been exported to many countries like UK, Australia, New Zealand, and many more to serve the Indian community abroad. Ethnic plant species provide a variety of products like food, medicines, and raw materials. They are also important source of renewable energy, and they have enormous potential to contribute to location-specific food production, as they are well adapted to the existing and adverse climatic conditions, and generally are free from pests and disease. And ethnic vegetables play an important role in alleviating hunger, malnutrition, and improving health, and thereby making a difference in livelihoods. However, traditional knowledge about these important ethnic plant species have decreased in the younger generation influenced by urbanization. So the Indian vegetable sector is facing constraints such as low crop productivity, limited irrigation facilities, and underdeveloped infrastructure support like cold storage, markets, transportation, etc. There are huge post-harvest and handling losses resulting in low productivity per unit area and high cost production. However, on the other hand, India's growing seasons, diverse soil and climatic conditions comprising several agroecological regions provide ample opportunity to capitalize on our strengths and to grow a variety of indigenous vegetables. That efforts are needed in the direction to capitalize our strengths and to remove limitations to meet the goal of moving towards sustainable ethnic vegetable growth in India. Science and technology-led production of ethnic vegetables will strengthen the rural economy, generate employment, ascertain livelihood, and improve nutritional security. The major challenge which lies ahead is to develop technologies that enhance quality and productivity of ethnic vegetables under reducing land, declining natural resources, and productivity of ethnic vegetables under reducing land, and increasing biotic and abiotic stresses. Producing ethnic vegetables to fulfill the increased demand in changed climatic conditions is a big challenge for scientists and growers in terms of how vegetable system adapt to possible impact of climate change. Hence, there is need for the inclusive, integrated, and systematic approach to address the sustainable growth and development in the vegetable sector, particularly ethnic vegetables, which will impact rapidly towards balanced food and environmental systems. So Dr. Ravindra Joshi sir has clearly mentioned in his keynote address from Philippines about the importance of ethnic vegetables, both nutrition point of view and also sustainability and food diversity. how this conference is important to bring awareness and popularization among the scientists regarding these vegetables. Thank you, sir. He has also mentioned. And he has also mentioned worldwide, some of the ethnic festivals which are going worldwide and how they are important with the point of in view of their importance with regard to nutrition security as they are rich in vitamins and minerals. So mention also, so thank you very much, sir. And mention was also made by Dr. Dr. B. Srinivasa Garu, Dr. K.T. Ramana Garu, Dr. S.S. Siddhartha Garu, who has worked with vegetables and who has explained her personal experiences, and also Dr. Surya Kumar, who have given clearly the importance of these festivals and how this conference is important. So I hope this conference on ethnic festivals will create a platform for the exchange of ideas and thoughts among the scientific fraternity and students, and the recommendations that emerge out of the today's deliberations and discussions will be highly useful to all the stakeholders who have been associated with these ethnic festivals. I sincerely thank our Vice Chancellor, Sir Dr. T. Janakiram Garu, and Chief Guest of today's conference, with whose encouragement and inspiration this conference is being organized. I congratulate the organizers and team involved for the conduct of this program through meticulous planning and execution. And thank you very much for giving me this opportunity.
Thank you very much, madam, for your valuable insights. You have told that how these ethnic vegetables are going to influence the rural economy, rural nutrition, and their impact on different stakeholders. Thank you very much once again, madam. Now, let us listen to the keynote address by our Honorable Vice Chancellor, Dr. T. Janakiram sir, who is joining us online.
Sir,
Good afternoon, everyone. Extremely happy to be part of this very important national conference on ethnic vegetables in hybrid mode, organized by Dr. YSR Horticultural University. At the outset, I am really happy and thank Dr. Ravindra C. Joshi Garu, who has readily agreed to give his keynote address. And he is the former site coordinator who has rich experience in World Vegetable Center, that is Solomon Islands. And also he worked for Ministry of Agriculture and Livestock, Solomon Islands. And we are also happy for the participation of Dr. A. Vishnuvardhan Reddy Garu, the Honorable Vice Chancellor, ANG Ranga University, Dr. V. Padmanabha Reddy Garu, Vice Chancellor, Sri Venkateshwara University, Veterinary University, Tirupati. And I can also see some of the able experts and stalwarts in the field of horticulture and the vegetables. Dr. B.S., the head of Vegetable Sciences, IRI. Dr. A. Gerard, who is the PC, PALMS, ICR, CPCRI. And Dr. Rakesh Pandeji, from IIVR and other colleagues from ICR organizations, Dr. Sriram, Dr. V. Sridhar, and many of the experts from various universities, and my own colleagues, Dr. V. Padmavatama Garu, Dean Horticulture, Dr. B. Srinivasulu Garu, Registrar, and the key organizer of this conference, Dr. K. Gopal, Associate Dean, College of Horticulture, Anantrajpet, and all my university officers, zonal heads of the Dr. YSR Horticulture University, and all the heads of research stations, heads of KVKs, and all the esteemed participants from various universities, and even I can see one of the scientists, Dr. T.L. Bhutia from Northeastern region, and all the students who are also participating in this national conference. Just for the information of the participants, Dr. YSR Horticulture University has initiated two of the prestigious network projects just 2 years back. This is one of the such initiatives. And recently, one of the initiatives taken by this university is on network project on Moringa. This is a inter-university collaboration with the University of Bagalkot and also Tamil Nadu Agriculture University, Periyakulam campus. And our horticulture research station at Darsi will be dedicated to work on this prestigious project. And secondly, another network project, by realizing the importance of ethnic vegetables, we also shortly launching this network project on ethnic vegetables with other institutions and universities across the country. As we know that the ethnic vegetables, particularly they are the traditional vegetables, and they hold very significant local importance in terms of their utilization for their local preparation of the dishes, their nutritional value, medicinal value, and integration into the social system. As we know, India possesses numerous native foods that bear significant, even the cultural importance within the regional and ethnic populations. And we also know that in accordance with the recent directive from the Food and Agriculture Organization regarding the establishment of a global hub on indigenous food systems, this signifies the importance of this ethnic foods in our human system. And this potential of indigenous foods surely enhance the biodiversity and also improve the food security, which has garnered the global recognition. Therefore, it is very much imperative to conduct through research and also documentation of the beneficial characteristics of the wild ethnic foods to establish a connect between the scientific evidence and generation of much awaited evidence of the indigenous vegetables which are grown and popular among the indigenous communities. The Indian subcontinent also recognized as possessing a wealth of rich, diverse genetic resources. Out of approximately 250,000 species of angiosperms worldwide, approximately 3,000 are recognized as viable food sources. However, only 200 of these species have undergone the process of domestication. The global diversity of vegetable crops is approximated to be of 400 species, out of which 80 species are major and minor vegetables which are believed to have originated in India. The Indian subcontinent has also served as a significant hub for approximately 2,500 plant species that are utilized in indigenous treatment and food sources. In this context also, Dr. YSR Horticulture University successfully collected and documented the indigenous vegetable crops, particularly grown in Andhra Pradesh. And as much as more than 100 vegetables are documented. To name few of the examples from the state of Andhra Pradesh, particularly these vegetables are known for their local significance, utilization, and also grown by the tribal population in some of the areas like Pandirmabidi and some of the agency areas. For example, Dommeru and Pennada, these are the two brinjal varieties which are very popular among some of the areas like near Bhimbaram in West Godavari district. And we have one of the Jatlu, which is a variety, slender long variety of brinjal, which is also very popular. Apart from this, another example I would like to quote is Enugu Benda, that is the lady's finger, bendi, which is locally grown and also known to be resistant to the yellow bean mosaic virus disease. And of course, in this background, this conference definitely will create good discussion and deliberations so that we can come out with a good plan of action to conserve these ethnic vegetables and strengthening of research on these vegetables. And particularly in the light of the climate change, also the indigenous vegetables become very important because, you know, today we observe many erratics in the climate, whether it is heavy rains and unseasonal rains and high temperatures, which are the major challenges. In that background, I think these ethnic vegetables definitely are going to play an important role, particularly when the extreme temperatures, some of the vegetables like this cluster bean, etc., are known to sustain these higher temperatures, and also one of the variety Thar Sheetal, a variety of the long melon, Thar Karni. These are some of the important varieties. So utilizing these indigenous locally available germplasm also, we can bring improvement in the varietal development. Of course, let's also some of the vegetables are very important. Even for that matter, these indigenous vegetables are resistant to the drought, even the soil salinity, and under even the floods. And some of these research is also addressed at various organizations like Indian Institute of Vegetable Research, IRI, and many state agriculture universities. And particularly, what kind of strategies for the future of these ethnic vegetables, their research and development. I think we need to strengthen the collection, conservation, evaluation, and maintenance are the important. Even the NBPGR has played a significant role in this aspect. And I'm also happy to mention the regional station NBPGR Hyderabad, in collaboration with Dr. YSR Horticulture University, conducted an awareness program and organized an exhibition of these ethnic vegetables in tribal areas. And we need to have this research and develop innovative sustainable technologies for the primary production and also this processing of these ethnic vegetables. Then third point is to replace absolute capital to improve efficiency in land and also water use, especially in tribal areas. And another point is that these programs to be supported for the implementation and bringing awareness and supporting for providing inputs for all the programs and increase their coverage, especially in tribal areas and rural areas. And reduce this greenhouse gases emissions along the entire food and agriculture and horticulture value chains. Ethnic vegetables are also need to be popularized among the home gardens, terrace gardens, so that this can be fully utilized by the population for their health and nutrition. And another very important strategy that also was discussed recently to make these ethnic vegetables growing in a cluster form and build market and logistical infrastructure to reduce the shelf life losses and also to improve the value chain efficiency for ethnic vegetables. Another important point is the reinforcement of the institutions, including those promoting preservation, cultivation, and propagation of ethnic vegetables. Since many experts and experienced horticulturists, particularly working on vegetables, are also participating from the various institutions and universities. I think this is one of the aspects need to be given top priority, and also identify the researchable issues. I think a national network project is also to be initiated on this aspect. And I also request from the particularly the universities that the researchable issues identified in ethnic vegetables can also be given as PG research programs. With this few remarks, I once again congratulate all the organizers and the participants, and definitely I have confidence whatever the presentations, the discussions happens during these 2 days of this national conference on ethnic vegetables will bring definitely a roadmap, and also we can bring some actionable points at the end of the conference. Once again, I thank each one of you. Thank you very much. Namaskar.
Thank you very much, sir, for your valuable insights regarding this conference. I now invite all the dignitaries onto the dais. Is the book of abstracts as well as the song name. Online. I request our Honorable Vice Chancellor, sir, to release the book of abstracts and song name.
Thank you very much. Congratulations.
Oh, sir, maybe sound it better.
Sir, I request you to please release the book. Please say release the.
Yeah, please, I'm happy to release the book of abstracts and also the souvenir. Congratulations.
Thank you very much. Sir. Thank you very much. Thank you very much. Sir, now I request you to release the song name.
Yeah, please go ahead.
Thank you, sir. Thank you very much.
సార్ సార్ అక్కడ స్విచ్ చేస్తాను ఏం ఉండాలి
గుడ్ ఆఫ్టర్నూన్ సుబ్రహ్మణ్యం పంపిస్తారా ఓకే థ్యాంక్ యూ.
Today, one of the farmers who has done a great service to the nation by conserving the ethnic vegetables. He has actually started conserving these vegetables from 2010 onwards, and he has conserved nearly 600 and above ethnic vegetables. And I invite upon stage Mr. Dhananjay Naidu Garu, who is from Chittoor district. He has really done a great service to the nation by conserving tomato, 65 varieties of tomato, onion, 73 varieties, cucumber, 14 varieties, melon, 20 varieties, brinjal, 70, beans, 35, chilies, 40, and the lab beans, 45, leafy vegetables, 70, nearly 20 varieties of radish, 32 varieties of okra, and many wild leafy vegetables. So he has done a great service to the nation by going for this conservation of these genetic resources, which are deteriorating by the day. I request our university officers, our registrar sir, to felicitate the farmer and present him with a small memento. N. Ravindra Kumar Garu, who is the bank manager of Union Bank of India, who has been quite generous in his sponsorship. We would like to felicitate as a token of appreciation. Please join us on the dais. Thank you very much, sir, for your generous contribution. I request our Dean of Horticulture, Dr. A.S. Padmavathamma Garu, to felicitate the basket. I now request my colleague, Dr. M. Sivaprasad sir, to deliver the vote of thanks.
Good morning, all. Thank you is such a prayer that cannot be seen or touched. On behalf of Dr. Vaisar Horticulture University, College of Horticulture Anantarajpeta, and the entire fraternity here together on my own behalf, I feel honored and privileged to propose vote of thanks on this special occasion. First of all, let me start by giving glory to Almighty God for this fabulous inaugural ceremony of National Conference on Ethnic Festivals. I take pleasure to express my earnest gratitude towards our Honorable Vice Chancellor and Chief Guest of the inaugural function, Dr. T. Janakiram Garu, for his very idea of conceptualization, the reason to organize this conference. Words are not enough to thank his constant guidance and support to shape this conference. Thank you, sir, for gracing the occasion and giving your valuable address to the delegates. My gratitude is towards the former site director, coordinator, World Vegetable Center, Solomon Islands, Dr. Ravindra Chandra Joshi Garu, for having readily accepting our invitation for delivering the keynote address and stressing the need of ethnic vegetables for addressing hidden hunger of pandemic era, post-pandemic era. I extend my sincere gratitude to the guest of honor for this National Conference on Ethnic Vegetables, Honorable Vice Chancellor Dr. A. Vishnuvardhan Reddy Garu, Acharya Engineering Agriculture University, Guntur, for gracing the occasion. We're also thankful to Honorable Vice Chancellor Dr. V. Padmanabha Reddy Garu, Sri Venkateswara Veterinary University, Tirupati, to be the chief guest for this national conference. My special acknowledgements to the Dean of Horticulture, Dr. Vaisar H.U., and President of today's inaugural ceremony, Dr. A.S. Padmavatama Garu, for her constant support and guidance. We are grateful and much obliged to the Registrar, Dr. Vaisar Horticulture University, Venkatramana, Dr. B. Srinivasalu, sir, for his gracious presence and valuable address to invigorate and rejuvenate the delegates here. Thank you, sir, for your valuable presence. I'm so grateful to the Director of Research, Dr. Vaisar Horticulture University, Dr. L. Naraman Garu, for gracing the occasion and for his valuable inputs. I extend my thanks to the Dean of PG Studies, Dr. Vaisar H.U., Dr. S. Surikumari Garu, for being the guest of honor and for constant support and valuable insight into the ethnic vegetables. We extend immense thanks to all the university officers for their continuous support and inputs. I'm highly grateful to Dr. K.T. Venkatramana Garu for his presence, conveying best wishes. I extend my gratitude to Dr. S.S. Vijay Padma, Associate Dean at College of Horticulture and Chinlatrapi, for her presence and sharing experiences with ethnic vegetables. We would like to thank the Associate Deans, College of Horticulture, Venkatramana, Dr. M. Madhuri Garu, Associate Dean, Parvatipuram, Dr. B. Prasanna Garu, for their gracing the occasion. I express my gratitude to all the chairmen, Dr. R.V.S. Reddy Garu, ex-Director of Research, Dr. Vaisar H.U., Dr. P. Sudhakar, Dean of Agriculture, Acharya Engineering Agriculture University, Dr. K.T. Venkatramana Garu, Principal Scientist and Zonal Research Head, Rayalaseema Zone, and Dr. Sri Ram, Principal Scientist, Plant Pathology, IHR Bangalore. I am also grateful to the co-chairmen, Dr. M. Madhavi, Professor and Associate Dean, Dr. K. Sarajalakshmi, Professor and Head, Dr. V. Sridhar, Principal Scientist, IHR Bangalore, and I also extend my deep sense of appreciation to all the rapporteurs, moderators of all the technical sessions. I extend my acknowledgements to Dr. B. Augustine Gerard, Project Coordinator, ICR, CPCRA Code, Kasargod, Dr. Suma, Scientist, NBPGR, Thrissur, Kerala, Dr. Sanjeev Kumar, Associate Professor, Division of Vegetable Science, Sher Kashmir University of Agriculture Science Technology, Jammu Kashmir, Dr. Rakesh Kumar Dubey, Principal Scientist, IIBR, Varanasi, Dr. Usha Kumari, Assistant Professor, COH, VR Gudam, Dr. B.S. Tomar, Professor and Head, IRI New Delhi, Dr. M. Kavita, Associate Professor TNU Coimbatore, Dr. R. Balakumbahan, Associate Professor and Head HRS Dindigal, Dr. V. Sridhar, Principal Scientist IHR Bangalore, Dr. C.H. Ruth, Professor Plant Pathology, COH ARPET, Dr. E. Karunashri, Director of Extension, Dr. YSRHU, Dr. Padma Nimmakaila, Professor Plant Breeding and Genetics, West Virginia State University, for taking out their precious time and for having accepted our invitation to deliver a guest lecture. We would like to thank, and it won't be enough, for the driving force behind every minuscule detail, persistent driving force with constant encouragement, correction, guidance. That is our Associate Dean, Dr. K. Gopal Garu. Thank you, sir, for being our mentor in every aspect. So this has been such a blessing to have wonderful team of steering committee of professors, dedicated colleagues, motivated and teaching faculty who had spent day in and day out for organizing this conference. I acknowledge their contribution, every bit of it. I have to give every credit to the research scholars. It couldn't have been done without the versatile and diligent efforts of them. I highly appreciate and acknowledge their efforts. I also would like to extend my deep appreciation for our former Associate Dean, beloved Associate Dean, Dr. M. Ramakrishna Garu, for his gracious presence over here. And I would like to, I also would like to express my deep sense of gratitude for Dr. J. Mithila from North Carolina University, USA, for having participated in the conference. So we are hugely indebted to each and every staff member whose contribution directly or indirectly involved making this conference one of its kind and first of its kind in the university. I would like to thank all the delegates who are attending virtually as well as present over here to share our research that has been worked. I would like to thank all the electronic and print media for attending festivals, for creating awareness on these vegetables. We are very much thankful to our sponsoring agencies, NABARD, APEDA, TTD, and Union Bank of India, Bros Scientific, Indian Scientific Company. It would have been impossible to organize without their support. I thank all the zonal research heads, associate deans, heads of the research stations, KVK heads for their participation. I'm extremely thankful to the progressive farmer, Sri Dhananjaya Naidu Garu from Chittor, so who has shouldered the responsibility of conserving the national treasure of ethnic vegetables. So thank you, sir. We made this conference a day. Thank you, one and all, for your gracious presence. Thank you.
Thank you very much, sir, for the vote of thanks. Now, we will resume our technical sessions after the high tea. That is, we'll break for 15 minutes and we'll have the, we will start the technical sessions. All the three themes will be started simultaneously, theme 1, 2, and 3 in 3 different halls. So all the participants, please assemble in the proper lecture halls where this are being organized. And now, before we close the inaugural session, I would like to end it with the national anthem. So please, I request all of you to stand. जय भारत भाग्य विधाता जय जय हे जय हे जय 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 हे in 15 minutes in the lecture halls. First have your tea which has been arranged outside. The links have been provided in the schedule.
Zoom link Distance scholastics. Reflection ఉండాలి కదా. Start video అవ్వట్లేదు. ఉంది సార్.
అందులో పిక్చర్స్
Start video అని పెట్టింది. Start video అంటే
సిస్టమ్
లేదు ఈ టేబుల్ ఇక్కడ ఇష్టం సార్
అది ఎమ్మె Good afternoon, all of you. Am I audible? Ma'am, sir, am I audible?
You are audible, you are audible.
Thank you, sir. Good afternoon and a warm welcome to everyone who are attending the session. I am Dr. M. Jayaprada, Associate Professor, Department of Genetics and Plant Breeding at Dr. YSR Horticulture University, College of Horticulture, Anantarajpeta. As a moderator to the session, I welcome to the highly anticipated conference session. I'm delighted to have each and every one of you here ready to engage in insightful discussions, share groundbreaking ideas, and foster connections within our vibrant community. The title of the theme here is Conservation, Genetic Diversity, and Crop Improvement in Ethnic Vegetables. The theme mainly concentrates more on studies, assessing and documenting the existing genetic diversity of ethnic vegetables, establishing conservation strategies for ethnic vegetable genetic resources, characterizing and evaluating the important traits of ethnic vegetables, conducting the breeding programs for developing and improving ethnic vegetable varieties. Before starting this session, I would like to read out the instructions for oral and poster presentations. Participants should complete their PowerPoint presentations within 5 minutes, followed by discussion for 2 minutes. The negative marks will be allotted if the presenter exceeds more than 1 minute. The participants will be evaluated for time management and their presentations, in addition to quality of their presentation, answers to the queries, for the award of best oral presentation. For poster presentation, participants should complete their PowerPoint presentation within 3 minutes, followed by discussion for 2 minutes. A committee of experts will evaluate the presentation for selecting the best poster presentation award also. I wish the participants a very fruitful and productive meeting, and I am looking forward to hear the outcome and constructive conclusions of the meeting. Now, it's my privilege to introduce the chairman of the session, Dr. B. Srinivasalu Garu, Registrar, Dr. YSR Horticulture University, Venkatramanagudem. Dr. B. Srinivasalu has 25 years of rich experience and service in the university in all the 3 wings, teaching, research, and extension. He started his career as a horticulture officer, directly serving to the farming community for more than 5.5 years. He is instrumental in introducing the drip irrigation, tissue culture banana and papaya, the red lady introduced variety, and implementing the area expansion programs for fruit crops in Kadapa district of Andhra Pradesh. Later, he joined in Acharya N.G. Ranga Agricultural University as a scientist at Coconut Research Station, Ambajipeta, East Godavari district, and contributed in developing the 3 coconut varieties, Gautami Ganga, Kalpa Pratibha, and Kera Bhaskar. He handled externally funded projects as a principal investigator and developed coconut-based cropping systems, Model 1, for coastal agro ecosystems of Andhra Pradesh. He worked in DAT centers for 4 years and conducted several field-level demonstrations, exhibitions, and farmer training programs. And for that, he received the Best Extension Scientist Award 2007 from the university. As a researcher, he is having a vast technical knowledge on various horticultural crops like mango, banana, papaya, pomegranate, custard apple, amla, bear, coconut, turmeric, and tamarind. He developed a new tamarind variety, Tetu Amalika, and the red tamarind variety, Ananta Rudhira, at national level, released in 2018, which is getting more popularity year by year. During his tenure at ARS Anantapuramu, he grabbed the best AICRP Center on Arid Zone Fruit Crops during 2019. As an academician, he guided the 2 PhD students and 5 MSc students, and served as a member, Academic Council, Board of Faculty for UG and PG in Dr. YSR Horticulture University. Published more than 49 research articles, 146 popular articles, 44 radio talks, and 26 TV programs for the benefit of the scientific community as well as the farming community. further added to his golden crown. A few more feathers are like Raitu Nestam Award during 2016 and a Distinguished Scientist Award during 2017. I feel honored to invite Dr. B. Srinivasul Garu. We welcome you, sir, to chair the session. And now it's my pleasure to invite Dr. M. Madhavi, Associate Dean, College of Horticulture, Venkatramanagudem, as a co-chairman to the session. She has worked in AACRP on tropical fruits at Citrus Research Station, Tirupati, Andhra Pradesh. She is presently holding the Associate Dean and Professor and Head position in the Department of Fruit Science, College of Horticulture, Venkatramanagudem. Dr. Madhavi has a research experience on citrus crops for more than 10 years and teaching experience of 17 years in the university and guided 10 MSc and 3 PhD students as a major advisor and as a member 10 more students. She has 35 research publications, 15 popular articles and 2 book chapters in the reputed journals and the books. She is a life member of Indian Society of Citriculture, Society for Promotion of Horticulture, Trends in Biosciences and Advances in Life Sciences. I welcome you, ma'am, to the session, and I would like to introduce again the rapporteurs of the session, Dr. B. Harivaraprasad, Assistant Professor, Dr. G. Lakshmi Devi, Assistant Professor, to the session. Now, I hand over the session to the chairman, Dr. B. Srinivasul Garu. Welcome you, sir.
Thank you, Dr. Jayaprada, the moderator for the technical session 1 of the National Conference on Ethnic Vegetables. Thank you for your nice words about me. As the chairman, I welcome Dr. Madhavi, Associate Dean from College of Horticulture, Venkatramanagudem. She will act as co-chairman. And Dr. Harivara Prasad and Dr. G. Lakshmi Devi will act as rapporteurs. So once again, I extend a warm welcome to all the scientific community who are participating in this conference, both in online and offline mode. As a chairman, it's my pleasure to welcome you all to this technical session 1, which Dr. Jayaprada has already told. The main theme of the presentation is on conservation, genetic diversity, and crop improvement in ethnic vegetables. I think this session will definitely will enrich the knowledge on the ethnic vegetables, on the latest technical know-how, both on the production and protection technologies. I think together we can have and we will definitely explore the innovative solutions and examine the cutting edge research and unlock the new possibilities that will shape the future line of work, particularly with regard to the ethnic vegetables. So with these few introductory words, I now welcome the speakers to be ready for their presentations. I think in the technical session 1, yes. Yes, yes, yes. Yes. There are 3 invited lectures. And the first one is by Dr. B. Augustine Gerard, the project coordinator, AICRP and POMS, ICR, CPCRI Kasaragod. The topic is on ethnic and underexploited vegetable genetic resources of Andaman and Nicobar Islands. So before I request you for your presentation, just I'll briefly, read out your biodata with your kind permission.
Dr. Bosco Augustine Gerard has over 25 years of research experience on improvement of plantation crops, root crops, tuber crops, flower crops, and vegetable crops with over nearly 200 publications. He has contributed immensely in development of 15 coconut varieties, which included 2 dwarf cross with tall hybrids. And he has been served as coconut expert to government of Fiji for 1 year through ITEC, that is Indian Technical and Economic Cooperation, Ministry of External Affairs, Government of India, wherein he has contributed in developing a coconut policy for the government of Fiji. He has served as head of the Division of Horticulture and Forestry at ICR, CIRI, Central Island Agriculture Research Institute, Port Blair, and presently he is serving as project coordinator farms, AICRP on farms ICR CPCRI Kasargod. So with these few, the words about Dr. Augustine Gerard, I request you, sir, to kindly go ahead with your presentation. Please, sir.
Thank you, sir. Thank you. So is the presentation visible?
Yes, sir. Yes, sir. I think, is it in full slide mode, sir?
It is full slide mode.
Yes, sir. Please, sir. Please go ahead.
Okay.
Make it full screen.
It is full screen already.
Right. It is in full screen. Okay.
Yes, sir. Sir, make it presentation mode, sir.
Already in the
Okay.
presentation mode only.
We could see only the
Okay, sir. Yes, sir.
right, sir. Right, sir. You can proceed, sir. Proceed.
Okay. So very good afternoon to all of you, respected chairman and co-chairman and the organizers. First of all, I would like to thank the organizers for inviting me to make a presentation on the ethnic and underexploited vegetable genetic resources of Andaman Nicobar Islands, where I have earlier served as the head of the Division of Horticulture and Forestry, during which we could document a lot of ethnic vegetables in the island territory. So before going into the details of the ethnicity of vegetable diversity in the islands, I would like to briefly tell about the history of Andaman Nicobar Islands. The islands are known for it was inhabited by the people for several thousand years, and the history is only about 800 BC to onwards. Only the historical documents are available. During 1014, it was ruled by Chola dynasty for a brief period, followed by Marathas in the 17th century, and followed by the Danish and British people. And then during 1956, this territory was made as a union territory of India. And you can see the location. This is in the Bay of Bengal, nearly about 1,200 kilometers from the mainland. And these are all the main group of island. You can see this is the South Andaman.
Sir, slides are not moving, sir. Slides. Can you please?
Okay, well, I'll once again share it.
Yes, yes.
ಅನಿಸ್ತಾ ಇದೆ ನಂಗೆ ಮನೇಲಿ ಇದಿದೆ ನಮ್ದು ಇನ್ನೊಂದು 1/2 hour ಅಂತ ಆಗುತ್ತಲ್ಲ.
The problem is here.
Is it okay now?
So you can first screen is slide is visible now.
Now this is second slide.
It is not visible, sir.
Sir, change to PowerPoint mode, sir. First
I can-
change to PowerPoint mode.
Yeah, it is in PowerPoint slide mode only.
Sir.
Now,
But,
And it's not really balanced, not only industrial and processing but also the pharmaceutical also. And we have the rate of today also, some rural area company, they depend on and they actually have
Voice,
and they also
speakers,
that's online marginal farmers. And the other time, say vegetation like except sanctions and all, they can be taken as used as livestock feed. And they are also coming in for industrial purposes. They can also feed like in value because rural mostly are attracted towards junk foods. So with the potato and other crops, so that can be done with these crops also. Then they also have only so stay a major part of daily life, accounting for more 50% of
now is it moving?
and they also have economic potential and will be financially
sir, we could able to see only the first slide.
No, now I think second slide. Actually, it is moving here. It is moving properly.
Okay. Then there is
share.
share this also. Share this all. Sir, you can share the presentation so that we can operate from here.
Yeah, okay. You tell the email ID.
No. ఇంతకుముందు మూవ్ అయినట్టుంది మేబీ
Sir, మీరు అనౌన్స్ చేశారు. Meanwhile, the second.
No,
so potato is actually the most important crop and that is important crop. Even these crops also supplement majority of the dietary requirements of even my topic is not of these crops, but we have multiple river crops totally the importance of thunder mining such that but at the moment river crops are actually cheaper food and income of small and marginal farmers. So mostly they are considered because they are like people have the attitude, small people have the attitude. So mostly small and marginal farmers with less land for and good soil conditions.
Hello.
Hello.
Meanwhile, the second.
Hello. So if there is some problem, I think you can come out and rejoin, sir, so that we can get the.
Okay. I will just leave the meeting, then again I will join.
Yes, sir. So that it will be okay.
Meanwhile,
I think meanwhile, because of lack of time, I request the second presenter to be ready with his presentation. Dr. A. Summa,
Yes, sir, I'm ready.
scientist from ICR, NBPGR, Thrissur, Kerala.
Sir, am I audible, sir?
Yes. Hello,
Yes, sir.
madam, am I audible?
Yes, sir, yeah.
Please. Yes, madam. Before you start presentation, I will just briefly read out your biodata. Dr. Suma is currently serving as scientist senior scale at ICR NVPGR Regional Research Station, Thrissur, Kerala. Her area of research is plant genetic resource management activities of tropical vegetables and tubers, including exploration, collection, characterization, evaluation, conservation, exchange, and maintenance of germplasm. And she is successful in pre-breeding of okra and development of amphidiploids under screening and evaluation against okra YVMV disease. She has handled 7 projects as PI and co-PI. She achieved Young Women Scientist Award 2019 for her outstanding contribution to PGR management program of cucumbers in the National Conference on Trends in Higher Education, Taxonomy, Agriculture, Biotechnology, and Toxicology by Dr. B. Vasantaraj David Foundation, Chennai. Thank you, madam. I think we can now start presenting your topic.
Can I share the screen, sir?
Yes, madam, please. Madam, please make it full screen.
Yeah, sir. Is it full screen, sir, now?
Yes.
Now, am I audible properly, sir?
Yes, madam.
Okay. Thank you, sir.
Please.
The respected chairman, rapporteurs, the organizing team, and faculty members, my senior delegates, and my dear colleagues. Thank you, sir, for the kind words, and thank you to the organizing team for giving me this opportunity to give a lecture on this potential underexploited vegetables of Western Ghats. And myself, Dr. Suma, scientist at the NVPGR Regional Station, Thrissur. Now, we have different diet recommendations by FAO, World Health Organization, expert consultation on diet, nutrition, and the prevention of chronic diseases, which recommends that a human being he should consume an average of 400 grams fruits and vegetables per day. And we have our National Institute of Nutrition guidelines. Based on this, average daily consumption should be at least 300 grams of vegetables by human beings per day. This vegetable availability is affordable to the people? We have the conventional pathways concentrating in research on few crops which fail to succeed in getting this 300 grams per capita availability of vegetable intake. So a paradigm shift is needed for the species diversification, so that infusing new species to your backyard and the kitchen gardens, and also introducing species with multiple parts which can be used as vegetables. And we have to have an improvement in our perception that we have to stress more on the nutritional value than keeping on the false prejudice of having a status vegetables which is linked to the high price vegetables. So there is a scope for diversification of vegetable basket in this context of climate change, which can remove this nutritional deficiency or the hidden hunger. With this small introduction, let me come to the topic of potential crops, which is defined by the ACRP on potential crops vegetable project, which is running at NVPGR. These are the crops for the future, which constitute those plant species that occur as life support species in extreme environmental conditions, having appropriate genetic makeup, and which they possess promising nutritional or industrial utility for a variety of purposes. We are using different terminologies like underutilized crops, underexploited crops, potential crops. We are interchangeably using it, and also ethnic crops. Ethnicity is connected with or relating to different racial or cultural groups of people, and which are related to ethnobotanical knowledge and associated closely with the tribal community which are consumed, which consume them, which define the ethnicity of the vegetables. Now, coming to the concept of underutilized food plants, which is cultivated in a less acreage and less attention being paid to the crop improvement aspect, and always linked with the cultural heritage of the locality, and it is cultivated mostly for the own consumption. And this popularity also differs from crop to crop and even with the locality to locality. And they are generally hardy in nature, and they grow and produce good yields even under adverse agroclimatic conditions. India
one of the 8 centers of origin of cultivated plants with 172 domesticated species, have 4 mega biodiversity hotspots: the Western Ghats, the Himalayas, Indo-Burma region, and the Sundarland, enriched with a total of more than 47,000 plant species, comprising more than nearly 18,000 species of angiosperms. Western Ghats, a gene-rich region, is a chain of low to high hills lying parallel to the Arabian Sea. We call it a Sahya Parvatam in Kerala, and in northern Maharashtra, it is called by the name Sahyadri. Traverses the different states of like Kerala, Tamil Nadu, Karnataka, Maharashtra, and few parts of Gujarat. It is characterized by unique agroecological habitats, predominantly high rainfall and high humid conditions, and also a mild winter. And the most important thing is the high biological diversity and endemism due to the presence of several unique microclimates offered by the high ranges, midlands, and the west coast. Coming to the potential crops of Western Ghats, there are more number of vegetables indigenous to Western Ghats, and beyond the commercial vegetable crops like bitter gourd, brinjal, ashwood, snake gourd, we have conducted a study in 2020, and we have come out with an enumerated number of vegetables indigenous to Western Ghats. This was even strengthened by a study conducted by Pradeep et al. In NDPT Thrissur itself. He reported that in Kerala itself, there are 86 crops used as vegetables, including 68 tall vegetables and 18 tuber vegetables. That itself confirms the biodiversity nature of the Western Ghats. Among them, less cultivated, wild gathered multipurpose are the vegetable crops that come under the potential crops or the crops of the future. The most important ones are given here. Classification of this under exploited can be based on the botanical family or genus, or either based on their morphology of the useful parts like tubers, leaves, and fruits, or based on the end use, whether they are used as salad or pickling or chutney, or the flavoring or the major part used as a vegetable, or based on the adaptive regions. Considering all these ideas, we have taken the classification as free vegetables, common vegetables, wild gathered, and cultivated only for own use. Coming to the potential tree vegetables, these are only a few which are due to the time constraint. I have listed only few. Artocarpus communis, which is a breadfruit; moringa, that's a drumstick; Sesbania grandiflora, which is agati chirai; or the Murraya coenji, that is a curry leaf; and Avaroya bilimbi, the bilimbi plant; Fluctuaceae enormis. These are some of the tree vegetables used in this region. Coming to the cultivated but also as a home garden vegetable, there is oriental pickling melon. A vast diversity of this oriental pickling melon available in the Western Ghats, and Chekumanis, which is a Sauropus anthrogynus, Malabar spinach, and also similar to oriental pickling melon, we have different Amaranthus tricolor diversity in this region, and others are the Hibiscus cannabinus, Hibiscus subdarifa, and lastly the yardlong bean, another most important crop of this region. Coming to the wild gathered vegetables, we have the Senna tora or the Cassia tora, we have the Thalinum, we have the Alternanthera sessilis under the Amarantaceae family, common purslane, desert horse purslane, or the Trianthema portulacastrum, Indian pennywort, which is a Centrala asiatica, also as a medicinal plant, Punarnava, that is the Boravia diffusa, Diplexium esculendum, which is a fern. They are remotely used in some tribal hamlets in this region. This table gives some of the less or wild gathered vegetables which are used by the people of this Western Ghats region. There are some vegetables which are mainly cultivated in home gardens for own use, which include this potato yam. The aerial portion is used as a vegetable. Then the jack bean, sword bean, velvet bean, then Burmese coriander as a spice, or the tastemakers, or the clove bean, and the black nightshade, the Solanum nigrum, very important leafy vegetable of Tamil Nadu and Karnataka. Coming to some of the wild and weedy species, we have Moringa congenensis. Other than the Moringa, our drumstick, Solanum torum is a very important vegetable of Tamil Nadu, and also now it is getting popularized in the. It is a popular vegetable of the western, rain shadow areas of Western Ghats area, and also Celosia argentea and Tragia involucrata, having a itching property when we are touching on this plant, but it's a very tasty leafy vegetable. And apart from this, the vegetables of Western Ghats region are unique for its species diversity, parts use, genetic diversity with specific land races for specific uses. There are immense number of land races with different uses, importantly shelf life, and also suitable for the low input homestead cultivation and medicinal properties. Coming to some of the like okra, there is different land races like Maravenda, Akashavenda, that is based on their use or the region from where they are cultivating. Anakomban, you can see the third one, which is similar, the morphology is like the tusk of the elephant. That's why it is called Anakomban. Anakomban is the tusk of the elephant. Like that, we have several land races, named land races, which is attributed to its quality or the particular region where it's coming from. Brinjal, amaranthus also we have, elephant foot yam, ash goat, taro, we have more than 25 kinds of land races, which we are using both as tubers as well as the vegetables. We have different land races in melon, cucumber, pumpkin, snake goat, bitter goat, greater yam, lesser yam, Chinese potato, and lab bean. This is one picture showing the land race diversity in vegetables like mullan valleri. You can see the cooking is diverse due to the presence of the tubercles on the skin. It is called the mullan. Mullan means that spiny nature of the fruit, but it is whenever we harvest it, it is easily shed off. Urali matanya is a cucurbita mosquita. It is land race. Urali is a particular tribal hamlet of Idukki district of Kerala. This is the Anakomban Venda, which I have already told you. See the interesting Rudraksha Hagali of wild bitter gourd. It's a land race of Karnataka. And we have different other land races, Kanivalari, Neikumblam. This is also ash gourd, which is a medicinal purpose ash gourd. And the yardlog been very long, Carbondal fire, and Nitipava, a wild bitter gourd, land race of Tamil Nadu. And these are some of other land races in taro. And you can see the mekikai, or that is a small melon which we have, which is very interesting material for us, which is collected from Koppal of Karnataka region, and it was a tasty vegetable, and we have consumed the recipe, that dish out of made out of this particular vegetable. And Arkilguda white is a land race from cucumber, then amaranthus and other yardlong bean, we have different land races. Coming to the species diversity, we are confining only to the very few species which are cultivated as vegetables. See the Momodica species with, other than the Momodica carentia, we have Sahyadrika, which is the mountain spine goat, Cochin sinensis, that is sweet goat, the Momodica subangulata subspecies, which is a teasel goat. These both Cochin sinensis and teasel goat, these are the vegetables of the eastern India, but have been introduced to this region and now being popularized in this region. Momodica carentia is a very important edible, wild edible vegetable, and Momodica dioica is a very tasty vegetable, and Momodica singularia or the Adalaka is very popular in this not in the normal Western Ghats region, but in the rain shadow areas or the Palghat gap, where that much humid condition of the rains are not available. Similar to that, amaranthus also species diversity is there. Other than this tricolor, we have dubious, we have tricolor varieties with small leaves, and amaranthus graces and subspecies Pelingianus, which we have observed, which is a very important vegetable of this high hills of Idukki district, Munnar and Marayur region. And Amaranthus viridis, we treat it as a wild vegetable, and Amaranthus spinosus, Amaranthus vitum, all these contribute to the nutritional efficiency. Some of the crops, whether other than the major parts which we can use of the vegetable, include the banana, where pseudostem and male inflorescence can be used, like Colocasia petiole is used, and the drumstick leaves and flowers are used. Like so many other crops are there where the other parts are used as the vegetable, and curry leaf we are interchangeably used as a spice or a vegetable crop. Even the capsicum frutescens, the bird eye chili, it is not a native vegetable of our this region, but it is an essential component of all kitchen gardens, which is fetching premium price in vegetable markets of Kerala, and it's an ingredient in every ethnic cuisine. And leaves are also cooked as vegetables in the by the Wayanad tribals. These are some of the alternate use of other cultivated crops, like Sandosoma sagitifolius, Colocasia gigantea. These are tuber crops, but the other parts are used as vegetables. Coming to some of the exploration collection part of this underexploited vegetable, we need to have an inventory of our underutilized species and documentation of the ITK related to the plant. and assemblage of the diversity from the backends is very important. We do not have a checklist of landrace diversity, proper checklist, and we have to identify the potential tracks for the exploration and collection. And the issue of this collecting the tree vegetable is that they are highly heterozygous and cross-pollinated. And the bulk size of some of the bulk size of propagules of some of these vegetables is also posing a difficulty during the collection, exploration collection of this germplasm. Coming to the characterization, some of the issues are we do not have the proper descriptors, as there are many underutilized vegetables in different families, and we don't have the released varieties of checks available in many species. And we have for tree vegetables there is space constraint, and these collections, as we know, they are scattered across many centers. So for utilizing these genetic resources, one of the major idea is to conservation through use. We can use it through conservation so that we can achieve the widening the utility base, and we can also go for the seed exchange mela, food festivals, school nutritional gardens to improve the utilization of these vegetables. Still, conservation issues like the management approach are different. Special protection and reservation for ex situ and in situ, because whenever we are collecting from the remote areas, they usually propagate and produce seeds in that particular habitat. That problem we are facing. So we can go for the on-farm conservation or in situ conservation models, so that it can be properly conserved in its habitat itself. And gene pool conservatory in community lands is also another idea that we can go. Other conservation approaches we can have on-farm through custodian farmer conservators. Those who are interested in conserving these land races, we can identify them, they can conserve them, and we can have model biodiversity plots also. Agrobiodiversity gardens can be set up, even school gardens, as we know that our young children, no way, they don't have any idea of this wild and weedy vegetables of our region. So we can have in school gardens itself, we can have a small garden of this wild vegetables. And finally, these conservators also can have the recognition, so that they will have more and more interest in conserving these genetic resources. I said NBPG Thrissur, we have a very strong base on the on-farm conservation of crops. We have more than 100 farmers, custodian farmers list database who are conserving the different land races of crops, not only in vegetables, tubers, even fruits and other economically important crops, which they are conserving in their habitat. So that database we have, and we have communicated it to our main center ICR entity in New Delhi. And I have come across some of the case studies done by Arinathan et al. In 2017, Yashodharan in 2007, that they have studies conducted at different tribes of Kerala and other regions, and come out with a list of species which they are used by the different tribal. Even that from that study conducted by the MSSR Research Foundation in Wayanad, they pointed out that Paniya tribe is a tribe of Western Wayanad region. They have 72 species, followed by the Katamaika, another tribal population. They are utilizing 35 species of this tribal vegetables. And Marachira is having a restricted habitat in the evergreen bushes, consumed only by the Katamaika community of the Wayanad district. And another part, one of the good work was done by Dattara and Ubade in 2016, who have documented the 142 species of wild edible plants of northern region of Western Ghats. And some other studies are also there. Thomas et al. In 2012, Nesta and Bhardi in 2017, Gautami et al. Who was conducted in the leafy vegetables in different districts of Karnataka, and Adlin lately in 2018 conducted studies in the Kani community of a particular settlement, having 48 settlements in the deep jungles of Kanyakumari district of Tamil Nadu, and came out with a list of 22 species of edible leaves being used for their use. Whenever we are conducting studies on the underutilized vegetable, local markets are one of the chief sources of wild edible. We can get more ideas what they are selling in their local markets. Coming to final slide of my study, my presentation, we have to promote the research on this underutilized vegetables, which opens a venue for the nutritional security, and studies on distribution and diversity. Germplasm buildup should be there. ascertaining the nutritional value and bioavailability, and processing and marketing. And here comes the role of SAUs and ICR institutes. And also, most importantly, state biodiversity board should play a very pivotal role in this management of this underutilized species. Here in Kerala, State Biodiversity Board has a very good initiative they've taken in the last year, 2022, with sanctioning more than some 10 projects to different researchers for conducting the study, particularly for this underutilized species across the state. So like that, we can have the biodiversity management committees, we can approach them. There are biodiversity registers are there. So by that, we can have more idea about this wild edibles of this region. So we know that genetic erosion is in a faster pace due to the fragmentation of land holdings, deforestation, unsustainable harvest from the wild, changes its land use pattern and other reasons. So it is a time to act. So with this, I acknowledge my director, ICR NGPGR, and the head, Germplasm Evaluation Division. My thanks are also due to Dr. Joseph John K., who's ex-officer in charge, principal scientist, who was a mentor for me, guru, and also he who seeded the interest of seeded my interest in this vegetables and also the magical world of this plant. I also extend my gratitude to other scientists in this regional stations. And these are some of the useful references you can go for this study in underutilized crops. With this, I thank you all for giving me this opportunity. Thank you once again.
Thank you, Dr. Suma, for your nice presentation. I think the topic is now open for discussion. 1 or 2 questions, if any, from the participants. Any questions from the participant side? I think if there are no questions, I think we can move on to the first presenter. Dr. Agustin, sir.
Yes. Sir, I am here with that.
Size file. So we should have him next. The file size is very large, sir.
So because of the large size of your this presentation, I think it will take some more time.
Okay.
I think we'll come back, sir, after the third presentation.
Right.
All right.
Okay.
Oral presentation.
Maybe you'll earlier. Third. I think I now request Dr. Sanjeev Kumar, Associate Professor from Division of Vegetable Science, SKUAST Jammu and Kashmir. Sir, are you ready? Dr. Sanjeev Kumar. Hello. Sir, am I audible? Dr. Sanjeev Kumar, sir? I think he's not present in online. I think we can move on to the oral presentations. There are 18 presentations. I think I request all the presenters to be, I think we confined to your time allotment so that we can complete the session within time. First presentation is by Dr. Naresh Ponnam, Scientist, Division of Vegetable Science from ICR IAHR, Bangalore. Dr. Naresh Ponnam.
Sir, yes, sir, I'm ready. Is it visible, sir?
Yes.
My screen is visible?
Yes, it is visible.
So, good afternoon, everyone. Shall I start, sir?
Yes, it is visible. I think you can proceed.
Slides are moving, sir. Okay, sir.
Yes, slides are moving.
Okay, sir. Good afternoon,
You
everyone.
can start presenting, sir. Yes.
So, good afternoon, everyone. The topic of my presentation is breeding leafy amaranthus for white rust resistance. Amaranthus, as you know, it really doesn't require any introduction because it's rich in nutrients, which is associated and ethnically associated with all the traditions and all the kitchen gardens. It's grown in every Indian kitchen garden. It's because of its rapid growth, and it's for commercial cultivation, it's C4 photosynthetic crop, especially adapts to all the harsh climates of the harsh climates and harsh soils also. So with this background, and we can see the nutrient content is rich in iron, zinc, phosphorus, potassium, and also the colored amaranthus are rich in betalains, which are more having antioxidant and anti-cancer properties. Though we know it's highly rich in nutrients, but still it is stigmatized as an orphan crop because there is no much work has been carried out in amaranthus. The amaranthus is main crop for the Asia and African countries. That is the reason why still it is listed in the orphan crops, though it's high nutrition rich. So if you see some of the studies recently studied in Eastern India, the association of amaranthus is around 0.75 to 1.7 kg per family eats this amaranthus per weekly consumption. You can see how much likeliness of amaranthus, which is mainly grown in kitchen garden. That is the reason why it supplies nutrients to the family. In Eastern India, our main focus on Eastern India, the major amaranthus, like different colors and local species are more preferred. And white rust caused by the albugo-blitty, that is a major fungal disease which causes major threat to the amaranthus crop, and it forms the pustules, and sometimes gives 100% yield losses, and also it loses the market value. So white rust resistance is very important because though chemicals are available, we cannot recommend the chemicals because the waiting period is very less and crop grows very fast. That is the reason why chemical control is not advisable and resistance is the main option. So with this objective, we wanted to develop high yielding locally preferred varieties with high level of resistance to the white rust. So what we done to achieve this one is that we mainly first concentrate on the germplasm exploration and collection. So we went for exploration to the eastern and northeastern part of India. We collected a lot of germplasm, and through secondary sources from the NBPGR, we collected some more accessions, and total around 285 accessions were collected, purified, and they are being conserved at Central Horticulture Experimentation, Bhubaneswar. So we have one of the largest in India, like after NBPGR. NBPGR has around 4,000 to 5,000 accessions. Then NBRA Lucknow have around 400 accessions. Then comes to the our center, we are having approximately 300 accessions. So we have 285 accessions, which comprises of all these species like Amaranthus tricolor, Blitum, Dubious, Spinosus, and Hypochondrus, all are locally collected. And from there, 54 accessions we identified as the best on the horticulture traits, because in Amaranthus, apart from the yield and foliage yield, horticulture traits are more important. The attractiveness and foliage color is more important. So 54 accessions were identified, and these 54 accessions were still forwarded through pure line selection, like individual plant selection and selfing. During individual plant selection, we mainly concentrate on horticulture trait, then white rust resistance. So 54 advanced breeding lines were developed, and these 54 advanced breeding lines were evaluated for white rust resistance, then shortlisted some 18 advanced breeding lines that again challenge inoculated for white rust resistance. Then finally, we selected 5 advanced breeding lines, which are in different market segments suitable for Eastern India. You can see this is the white rust screening under natural epiphytic conditions. So we maintain a susceptible check at every treatment so that the inoculum load will be very high in the field. So this is how we screened. This is the disease severity scale used for the scoring of the Amaranthus advanced breeding lines 0 to 4. So this is the disease severity scale used, and then we calculate the disease severity percentage. So 54 advanced breeding lines were screened under natural epiphytic conditions. So here 38 advanced breeding lines were found to be highly resistant for the rust, because this happened because from the beginning our main criteria was white rust resistance. So those during the selections we selected in such a way with low white rust incidence. That is the reason why we got good number of advanced breeding lines having resistance to the white rust. So out of 54, these are the 54 advanced breeding lines, and then 38 were found highly resistant to the white rust. From there, 18 advanced breeding lines were selected, which are having good horticulture traits. Then they were artificially challenge inoculated for the white rice resistance through albuginability. So we artificially challenged inoculator and we found that 11 advanced breeding lines are highly white rice resistance and they are having good horticulture traits. So in that 11, 5 lines were having good horticulture traits. One is IHRB AM8, next 45, 65, 276 and 286. These were having good level of white rice resistance and good horticultural traits. So you can see the white rice screening resistance. This is the Blitum. 8 and 258 are the Blitum background having white rust resistance. This is a susceptible check. You can see the severity of the white rust. So these are the different white rust screening, artificial challenge inoculator screening. After that, identified white resistance lines. So these are the characteristics of advanced breeding lines. They have very good attractive color, ranging from light green to even white stem color to the pink stem color, and the leaf color also ranges from light green to dark purple, even green with purple local types. So you can see this is the Amaranthus blitum, very soft textured. This we released recently as Arka Nilachal Ruchita from our institute, which is having white resistance and good foliage yield. This is Arka Nilachal Ruchita, another white resistance line, which is having very local preference in the Odisha and Eastern India because they have a habit of, because it's highly associated with the tribal people. So this, it is having a green color with purple blotch. This is Virichita, we released having white resistance. This is another line which is having very attractive color, pinkish color, high betaline content. So this is, we released as the Arka Nilachal Bainishi. Bainishi means the flute of the Lord Jagannath. So such a beautiful line. This is having good white resistance and good cooking quality. This is again another line having in the segment of the purple, pinkish purplish color. And another is in the dubious. Dubious normally throughout India, people may not like this taste, but in the Odisha, this dubious, Amaranthus dubious having good liking by the tribal consumers. And also even in Tamil Nadu also this have good consumer preference. And Tamil Nadu has released one line Co1 in the dubious background. So these advanced lines has been evaluated for 3 years for the foliage yield. Though foliage yield doesn't matter in Amaranthus because Amaranthus normally pulling, which freshness, it's sold in the market as in the bundles. The price decided by only the quality horticulture traits. But they're having good foliage yield, and all the 5 are showing good foliage yield throughout the 3 years. Then we screen for them for the nutrient contents like nitrogen, phosphorus, calcium, sulfur, iron, manganese, and zinc. These nutrients contents were evaluated, and all the lines were having the good amount of the nutrients. And further, we evaluated antioxidant capacity and anti-nutrition properties. Oxalates and nitrates are anti-nutrition properties. They should be in limited range. Otherwise, it will form the stones. It will be like kidney stones formation will be very high. That is the reason why the genotype should have, or variety should have low oxalate and nitrates content. So our lines showing in the edible range. It's not that they are having low oxalates and low nitrates, but it's in the edible range. So these are the lines we selected with having white resistance and good attractive colors and good yield. So 8, 45, 65, 276, and 286. One in Amaranthus blitum background, another in Amaranthus dubious background. Then these 5 advanced lines were DNA fingerprinted, and now 3 lines were already released from the institute as the varieties, and the seed being made available to the farmers. So these will be DNA fingerprinted also. And so finally, we identified best lines and released for the farmers. So with this, I thank you. Thank you very much. These are the lines which we developed and released from the institute level. Thank you very much.
Okay, thank you, Dr. Naresh, for your nice presentation. I think very good results have been obtained. I think all the 5 breeding lines are possessing very good qualities of both leaf and other stem characters. I think of all these 5, which one do you, more preferable one?
among all these 5 lines?
Sir, 3 lanes we already released, sir. One is in Blitum background. This is mainly South
Okay.
Indian lichen. And 2
Yes,
in
yes.
local type. 3 lines already we released, sir. These are having good market preference now. So out of 3,
Okay.
out of 5, 3
Yes.
released, sir. 2 we are registering with the NPPGR, sir.
Okay. But there is a great demand for this tricolor one and compared
Yes,
to
sir.
the normal green color.
Yes, sir. There is Eastern India. There is a huge demand, sir. This
I
color
think it differs
they like
from
locals.
region to region. Okay.
Region to region, sir. So Blitum normally goes in South India, sir. But in Eastern India,
Yes.
this purple blotch one and pinkish one has more demands. So
Okay.
we
Okay,
already
good.
from 285 we came to 5 and 5 to 3, sir. So we like more local preference only we took in main criteria.
Okay. Thank you. Thank you for your good presentation. I think there is one question for you.
Sir.
Naveen?
Sir.
Naresh.
Ma'am.
Naresh, what is the procedure followed in artificial inoculation of white rust pathogen?
Madam, like this is obligate pathogen. We maintain the pathogen and the
Yes.
purple plants, and then the sporangia has been collected, and 10 to the power of 5 sporangia has been like per ml has been sprayed and then covered with the polythene bags. So within 5 to 6 days, we'll get the pustules.
The pathogenicity is proved or not that it's
Yeah,
obligate
pathogenicity.
pathogen.
This is pathogenicity proved, madam. You can see the even this controls we will be using for the controls, ma'am. Here you can see the pustules, the development of the pathogen. So at the same time, it has been sprayed, and the resistance one showing good level of resistance and susceptible almost 4 grade.
Okay, Naresh.
Okay. Thank you.
Okay.
Thank you, Dr. Naresh.
Thank you, ma'am.
I think yes, yes. Yes, Dr. Augustine, I think we
Yes,
can move on to now.
Let
Dr.
me
Augustine
share.
Gerard. Yes, sir. Yes, sir. Please, sir.
Whether the file could be downloaded there?
Yes, sir. Yes, sir. I think it took some time.
Okay. Because of the file size, maybe the slides are not.
File size, yes, yes. Yes, sir. Yes. ఇందులో పేస్ట్ చేస్తాము ఇందులో పెన్ డ్రైవ్ ఇక్కడ ఇది సెలెక్షన్ ఇక్కడ కింద కొంచెం మాట్లాడచ్చు Yes.
ఒకసారి బిందు చూడు కనిపిస్తుంది కనిపిస్తుంది కనిపిస్తుంది.
Is it okay now?
Share what I don't share was things. They share you have posted, share and share the
Sharing this one.
sharing what in the side. Akala.
Shall I try once again from here?
Drama చేస్తాను. People are America.
On Bluetooth connected something sound correct.
Excellent.
Yes, sir. Now the slide is visible.
Actually, we can operate it. Okay. No? Sir, I think you can start now, sir.
Yes,
Am
sir,
I
yes,
audible,
sir?
sir?
Yes,
Yes, sir, please, sir. Yes, sir. Which I think I can go to the next slide.
Yeah, next slide you can. So, as I told earlier, before going into the ethnicity of the place, so this historically the island was under the control of Chola dynasty during the 11th century and later by Marathas in 17th century. And later during the 18th and 19th century, it was under the Danish settlers, that is Denmark, and also exchanged with the British India. And then finally it has become a union territory of India during 1956. You can see the area in which that South Andaman, Middle Andaman, North and Middle Andaman, and the Nicobar group. The islands are divided by the 10-degree channel. Next. So this island chain consists of 572 islands, and only 38 islands are inhabited and 8 islands under the settlements. And more than 50% of the population are directly or indirectly dependent on the agriculture and allied activities. The island receives about 3,000 millimeter rainfall annually, and the temperature varies from 18 to 32 degrees. That is perfectly the tropical climate. Next. So this is the physiography of the island. You can see the sea and the coastal valley and the mountain thing and hilly upland and also the natural forest. So here the excess moisture is available between the April end to November, whereas the other period is the moisture deficit region. Next. You can skip the slides or next slides. So these are all the typical landscapes in the island. You can see the vegetable fields, rice field, and also the coastal area. Next. These are all the coconut plantations and also the coastal region. Next. Next. Coming to the hotspot rich, the island harbor about 2,500 angiosperms, which are endemic, about 200 are endemic, and more than 150 species of fruits and vegetables are reported here. And you can see the diversity of medicinal plants, pulses, cereals, orchids, ferns, and also the fauna, 215 species of butterfly and other bird, the animals and insects. Next. Coming to the horticulture diversity, you can see in mango itself, we have about 5 species, including indica. That is Mangifera griffithii, Mangifera andamanica, Mangifera nicobarica, and Camptosperma. These are all used by the tribes and also used by the breeders. And in banana, we have the Musa indianensis, Paramjithiana, and Acuminata and Bulbiciana. Pure Bulbiciana and Acuminata is also available. They are used as vegetables as well as for the other purposes like leaf and the consumption of flowers as vegetables like that. Besides, we have a number of crop relatives in several crops, including the tuber crops and the plantain. Next.
So
these are the tribal populations, that is the Great Tamanis, Trompans, Nicobaris, Jaravas, Sentinels, and Wongis. These are all the aboriginal tribes of the island. So these, besides this aboriginal tribal population, the mainland settlers are from the West Bengal and the northern India, Tamil Nadu, Andhra Pradesh, and Kerala. And these people holds the knowledge of ethnobotany information about the plants and animals from the island. Next. So coming to the conventional food systems of the tribes of Andaman and Nicobar, whatever the aboriginal tribes I explained, that 6 tribes, they lived here for more than 60,000 years, starting from the evolution, and they lived only with the tubers, herbs, coconut, pandanus, wild banana, and endemic fruits and vegetables till date. Till date, only one particular tribe, that is Sentinelese, they still live on this wild vegetables and fruits available in those places, whereas the rice, wheat, and other materials were later introduced in these islands, and still the original ethnic vegetables and fruits are available and used by these tribes. Next. Next. These are the introduced vegetables cultivated in different part of the islands. Next. These are the different regions which are South Andaman, Little Andaman, and other areas in which the vegetables are grown. You can see the minimal area of vegetables. Next. So out of this around 4,000 to 5,000 hectare of area which are under the vegetable cultivation, lot of leafy vegetables and other ethnic vegetables are being grown. And you can see this is a brief list of popularly available leafy vegetables in those places. The other vegetables like whatever species I have mentioned here, like Alternathra, Basella, Centrella asiatica, these are all available elsewhere in the other places also popularly known. Whereas the ones which are given in the red, is mostly consumed in the Andaman Nicobar Islands only, like Champariana, Manilana, then this Chakrumani. This Chakrumani is all through the islands. It is available in the wild. It is not even cultivated by anybody, but it is available elsewhere in the islands, and it is being used by the tribes and the local population. And the Piper sarmentosum, that is actually it is the leaves are used as a very good vegetable. And the Nymphea species, Eryngium foetidum, is both used as a spice and vegetable. And the Carcorus capsularis, that is pot bhaji. And the coming slides, I'll be showing the photographs. Next. So these are all some of the ethnic vegetables grown in the islands. Next. You can see the fruit vegetables, leafy vegetables, and other parts used as vegetables. Next. Flowers. Next. Next. So in the recent explorations conducted in the different islands in Nicobar group, also we have identified the wide array of chili being used by the Nicobari tribes. You can see the diversity, and also the primitive brinjal types and primitive tomato types are also available in those places, which are used as vegetable there. And the wild, the ash gourd, and then the edible ferns. Those are all the ethnic vegetables there. Next. The islands have rich diversity of this Amaranthus species also. The earlier presenter also mentioned, and Dr. Suma also mentioned several species. So here, within the species itself, so a lot of diversity is available in these islands. So some of the material we have collected and conserved, and it is being evaluated. The open pollinated progenies are being evaluated to make selections. Next. So this is one of the very important ethnic vegetable in Nicobar group of islands used by the Nicobari tribes. It is Cissus repens. The leaves are very sour in taste, and it is used in several preparations in fish curries and other tuber preparations. And this was collected and conserved, and it is a vine crop, and it can be grown on the houses or the pandals, or it can be grown on the trees also. So it gives throughout the year, the leaves could be harvested. This is Nicobari Katta Bhaji, it is called. This is Cissus. Next. And these are some of the other indigenous leafy vegetables. You can see the hibiscus acetosella, then hibiscus subtharifa also. It is although it is grown in mainland also. And then this pot bhaji, which is given in the bottom, that is Carcorus capsularis. And the Mita bhaji, Champaria manilana, this is exclusively cultivated or grown in the gardens and plantations inside the coconut plantations in Andaman Nicobar Islands. This is called Mita bhaji. The bottommost second picture, and this is a perennial leafy vegetable which can be grown as a shrub, and it can go on. You can prune the thing, and only the tender leaves with 3 or 4 leaves, like tea leaves, what we harvest 2 leaf and a bud. Here it is 4 leaf and a bud, like that. It can be harvested and used, and it is a very delicious vegetable. It can be propagated by seeds. You can see the seeds, fruits, and it can be propagated through seeds. And a lot of diversity available in the colocasia, which are used for vegetable, like the leaf petiole or the leaf itself. Next. And this is another edible fern, interesting thing, that Drainaria quercifolia. You can see in the mainland, also in the hilly regions, on the trees, trunks and the rocks, you can see. This is also one of the wonderful vegetable being used by the tribal population. And this is considered to be a good source for healing the bones. When the bone is fractured, and this stem is used to prepare soups and taken to heal the bones in a very quick manner. And it is also used in Ayurveda and other medicinal systems also, and it is used by the tribes. So we have collected, conserved, and also analyzed its properties, the biochemical properties. Next. So this is the plant and the harvested stem, and you can see the cross section of the stem, the train area, quercifolia. Next. And this is a very interesting thing that water lily, that Nymphaea nochali. This purple flowered type is mainly used as a vegetable by the settler communities in the island, Andaman Islands. And it is grown in both natural ponds as well as in the artificial water bodies in the farm ponds. And the flower stalk along with the flower is harvested and used as a vegetable. And it gives about 60 to 120 flowers per meter square in an area of 50 square meter pond. And this is a highly preferred vegetable in the local markets. Next. And this is another vegetable, that sword bean. 3-4 different types are available in the sword bean with very distinct difference in the seed color. And we found this white seeded type is a very better yielding type with less fiber and higher yield of pods. And this can be grown as a perennial vegetable, and it is very hardy, and it is being preferred in the remotest places in the island. Next. And this is the tree bendy. I think Dr. Suma also mentioned that here it is a different species, that is Abelmascus caeli. And this after planting, it comes to flowering in about 7 months after planting. Then afterwards it gives continuously fruits. Up to 42 fruits could be harvested from one single plant. And after the season, it can be pruned to the bottom level, and again it will produce the branches and continue to give the fruits. So these fruits are slightly different from the regular bendy because this has more mucilage, and the seeds, the matured seeds also can be used as a vegetable and to make soups and other preparations. So make curry and all. So this is a wonderful vegetable because it has no yellow vein mosaic diseases, are very few occurrences of borer and other sucking pests when compared to the regular bendy. So this is also preferred ethnic vegetable grown in most of the home gardens and used. Next. And this ethnic vegetable is also most popular among the Malayali community in the Andaman Nicobar Islands. Probably it would have been introduced from mainland. And it is grown in all the fences and the trees all over the gardens. And it gives a very good vegetable to make fry the vegetables and curries. So the clove bean, Ipomia muricata. Next. The breadfruit is another important fruit, and it is here the Altilis, Camensi, and Marianensis. All the 3 species are available here in the islands, especially in the Nicobar. And it is a multi-purpose tree actually. When at the young stage, it is used as a vegetable, and at the mature stage, it is used for making the rotis and the other preparations. And it is a highly preferred one among the Nicobaris. So it is sometimes it is called the Nicobar katal. That is like that it is called. So it has multiple uses. Even the gum is used to repair the boats of Nicobaris. Next. So here, this particular breadfruit thing we have collected, conserved, and also we have multiplied through root cuttings as well as the air layerings, and it is being promoted as a local ethnic vegetable. Next. Next. Coming to other, the great thing is the greater yam from the Nicobar Islands. So this is a widely preferred ethnic vegetable even in the Nicobar, among the Nicobari tribe. So we have about 32 different collections, and all of them are conserved, characterized, and it is also some of them are even put for multi-location trials across the country. It gives very good ensure the nutritional security among the tribal community in the Nicobar. Next. You can see the wide diversity here for the tuber size, shape, and the anthocyanin content of the tubers. Next. So here what we did for the conservation, actually about 30% of the produce has to be stored for planting. So we developed a small technology using the aerial tubers produced from the greater yam. And this is multiplied, you can see on the tray itself, it is grown. So about 30% of the yield is saved here because from the rapid multiplication technique we developed for multiplying this greater yam. Next. The other Dioscorea species, like whatever I have listed here, the Pantophila, Glabra, Vexens, and the Rotundata, Piscatorum, all these Appositifolia, all these species are widely used as a vegetable in the Nicobar communities as well as in the northern middle Andaman. Next. So this is some of the thing you can see on the right side that with the spines, no, this is the Dioscorea piscatorum. Even in the Nicobari community, they grow pigs in their garden. So the other varieties, other tubers, everything will be sometimes eaten by the pigs. Whereas this one, since it is with a very strong spine, the pigs cannot eat directly. So only when they peel it and give, they can eat. So that way, this particular thing can be easily grown in the Nicobar community, even in the hardest situations. And it is a very interesting thing that this is not present elsewhere in the country. Next. This is the Amorphophilus diversity available in Andaman Nicobar Islands. Most of them are used for medicinal purpose as well as vegetable purpose. Next. This is also a very interesting thing that Taka species, it is also grown in Nicobar Islands, especially in the Nankori group of islands on the coastal belt. It is used as a vegetable propagated by seeds. Next. And this is another ethnic vegetable found mostly grown in all over the forest everywhere in the northern middle Andaman, as well as in some parts of the south Andaman and in Little Andaman also. The Wongi tribe in Little Andaman, they prefer to use as a medicinal plant to get rid of body pains and other ailments. And the rhizomes are used as a baby food also. Next. So the conservation of traditional vegetables and promotion of their use is promoted, especially the Andaman Nicobar. Now it is being open for trade with the Southeast Asian nations in the coming years because to promote tourism. So if these ethnic vegetables are promoted as a intercropping or mixed cropping in the home gardens as well as in the container garden, all the roof garden and all, yeah, this has a tremendous potential for to meet the demand of the tourism industry, and also some research is required to promote the productivity improvement, the post-harvest technology, and to develop the market chain. And these underutilized vegetables, most of these underutilized vegetables, what is available in the islands, mostly they are not available in the mainland and other places. So it may get good price, or it can be promoted as a unique vegetables from the islands. Next. Thank you. So any queries?
Thank you, sir, for your excellent presentation. I think we were taken to Andaman Nicobar Islands, wherein we find very rich. I mean, germplasm of all these ethnic vegetables, and we could able to see many new types of ethnic vegetables there. I think it is best, resourceful place.
Yes, sir.
I
Yes,
think
sir, definitely.
Yes,
because only whatever I have shown, it's only glimpse of the material. But otherwise,
yes.
It is, every species we have plenty of diversity there.
Yes, yes, sir. I think we can make use of them in our regular diet so that it can add more of medicinal value apart from the nutrients what we have here in our country. Thank you, sir, for your excellent presentation.
Thank you.
And
Thank you for the
if there are any questions from the participant side, I think one or two questions. Okay, if there are no questions, I think
Thank you, sir.
on behalf of Dr. YSR Horticulture University, we extend our heartfelt thanks for your gracious presence and presenting very wonderful topic on ethnic vegetables. Thank you very much, sir.
Thank you, sir. Thank you for the opportunity.
Thank you. I think we go to the next oral presentation. Dr. Shivananda Honga, he is a senior scientist and head from University of Horticulture Sciences, Bagalkot, Karnataka. He'll be presenting on the topic breeding spine gourd, that is Momodica dioica for yield and fruit. Are you ready, Dr. Shivanand?
Yes, sir. Ready, sir. My slides are visible, sir?
Yes, yes.
Okay, they are moving also, I think. Okay, good afternoon and namaskaram to all the delegates and the participants. I'm here to give my oral presentation. Breeding spine gourd for yield and fruit quality traits. And this specialty ethnic spine gourd is the most admired underexploited perennial dioecious vegetative propagated cucurbitaceous vegetable, having tremendous medicinal, nutritional, as well as economic values. In Karnataka, we call it as a Mada Agla, and also some people, they call it as a Malanada Bonno, which means the golden vegetable of Western Ghats. And in other regions, it is known as in different language like kakurol, kaksa, and bitterless, bitter cucumber. And it is of native to Western Ghats of southern India, because where we can find the huge diversity of this particular the vegetable. And as of now, this vegetable is consumed mainly by the tribal groups who are living in and around the natural forest areas, especially at the higher altitudes, where these native folks, they consume it as a daily vegetable. In South India, majority of the market from the wild collections by the native people, and which gets a very premium prices in the market. They sell it for...
So pardon, sorry for interruption. I think, yes, now it is moving. Okay. Please proceed.
It's not moving, sir,
please,
now?
Sir.
Yes,
sir.
Moving now?
Yes.
Yes.
It is now moving.
Okay, sir. In South India, most of this the produce will come from the market from wild collection by the native people, and they sell it for a very higher prices, that around 250 to 350 kg, because it is highly seasonal, and also because of its scarcity and because of its medicinal properties, it is very expensive vegetable. And apart from its fruits, the roots of spine gourds are also being used for treatment of piles, urinary and bowel infections. And so far, a very limited work has been initiated in these crops. So keeping these facts in view, we have initiated a breeding work and have collected the germplasm from all across the Western Ghats of Karnataka. And they have been conserved at College of Horticulture, Sirsi. And the collected germplasms were evaluated for their performance with respect to the yield and quality traits. And we have also initiated studies on floral biology and crossability in the collected germplasms. And this is the experimental details. It was conducted at College of Horticulture, which comes under the Zone 9 of Karnataka, which is in the Western Ghat region. And these are the germplasms we have collected from different parts of Western Ghat region. And the result shows that all the germplasm, they show the significant differences for all the traits we have studied. And among the genotypes, maximum vine length, fruit weight, pericarp thickness, number of branches per vine, and fruit yield per plant were recorded in COHS 11, which was followed by COHS 12. Whereas the maximum number of fruits per plant were recorded in COHS 2, followed by COHS 9. And we have also estimated the fruit quality parameters and observed a significant variability for the same. Among the genotypes evaluated, the highest ascorbic acid content were reported in COHS 11, and maximum carotenoids were noticed in COHS 3, and protein content were maximum at COHS 7, and phenol content were highest in
Slides are not moving, sir. Yes, now it is okay.
Okay, sir.
Okay,
And
sir. Okay.
you all know that in breeding, the larger the variability, the greater will be the genetic potentiality and the more the chances of crop improvement. In our study, high heritability of more than 60% coupled with a high genetic advance were observed for almost all the traits we studied, like vine length and internodal length, number of branches, node at which first female appears, and the days to first harvest, fruit weight, pericarp thickness, number of fruits per vine, as well as the fruit yield per vine, which clearly indicates the predominance of additive components for all these traits. In addition to this, high GCV and PCV for many traits indicates the presence of sufficient variability in the germplasms, which offers a very good scope for crop improvement by a simple selection strategy. And we also analyzed the path coefficient, which gives a clear image of direct and indirect association of the different traits to the yield. In our study, the path coefficient analysis revealed that traits like fruit yield, fruit diameter, and days to first female flower appearance, fruit number per vine, internodal length, they have shown the direct effect on the fruit yield per vine. Hence, the direct selection of these traits is very, very effective for increasing the yield per vine. So we can conclude that the genotypes COHS 11, COHS 12, and COHS 10 were identified as the best genotypes with respect to the yield per plant. And floral biology as well as the crossability studies revealed that the peak anthesis was observed early in the morning between 5:30 to 6:30 a.m. with 69.4% anthesis rate. And the result of hand-assisted pollination were very encouraging. We could able to get 87.66% of the fruit set in assisted pollination against 18.3% in case of open pollinated vines, which means here the yield levels can be increased by involving the assisted pollination. Thank you, sir.
Okay, thank you, Dr. Shivanandi, for your nice presentation, breeding of spine guard for yield and quality fruit. If there are any questions from participant side? Okay, if there are no questions, I thank Dr. Shivanand for the nice presentation.
Thank you,
I
sir.
think we'll, thank you, sir. Thank you very much. Nice. Right. Next presenter will be Dr. Sangeeta, scientist from ICAR, IIHR, Bengaluru. She will be presenting on evaluation of pointed gourd germplasm against major diseases as well as fruit rates and yield. Dr. Sangeeta.
So good afternoon, sir. Dr. Sangeeta is on leave, sir. Actually, she's having some personal issue. So I am presenting on behalf of her, sir. I'm Dr. Naresh Ponnam.
Please.
I'm presenting on behalf
of please.
Okay, sir. So this is about pointed gourd germplasm. Pointed gourd is 1 minute. Sir, my slides are okay, sir. It's moving, right? Hello.
Yes, sir. Yes, sir.
Okay, sir. Pointed gourd Trichosanthus dioica, which is very important underutilized vegetable crop throughout India, and it's underutilized in other parts of India and overutilized in Odisha and West Bengal, because this is very much attached to the Odisha and West Bengal people, and it's a very rich vegetable without which their dinner, their food will not be full. So compulsory they'll use in their diet every day, sir. There are a lot of dishes being prepared from the pointed gourd. A lot of sweets are there. Sweets also being prepared in Odisha. So this is one of the best and ethnically associated crop for the Odisha and West Bengal and Jharkhand region, mainly for tribal that have their taste buds. So it's a semi-perennial crops, dioecious in nature, and Eastern India is having very wide variability in pointed gourd. So what we did is that same like we used methodology in Amaranthus, same thing we went for exploration and collection of germplasm has been carried out through on-site visit in the semi-wild and wild and even farmers collections were being made, and around 61 genotypes we could able to collect and then bring back to the CHES Bhubaneswar, Central Horticulture Experimentation Bhubaneswar. We established the field gene bank at this station with all the 61 accessions, and these accessions were screened against major diseases like leaf blight and fruit rot caused by Phytophthora melanis. This is a major disease occurring in the pointed gourd. Sometimes 100% yield losses we could see due to this disease when the rain coincides. And another disease reported is net blight caused by Sclerotium lawlsy. This is also another challenging, problem in the pointed gourd. So for the both diseases, we did screening, and then finally we did yield trials for the 2 years. So this is the pointed gourd germplasm diversity we collected and being maintained at Central Horticulture Experimentation Bhubaneswar. There is huge variability in case of fruit shape and fruit color and rind. So there are a lot of affinity towards its variation in the color among the farmers and even consumers, because these small types are morely preferred. Like they feel it's like a local type, and from the region to region within the Odisha, there is huge variability and huge consumer preference. So this is the field gene bank established at CHES Bhubaneswar. All the 61 accessions are being maintained at Bhubaneswar Center. And this is the over the years, 2 years, we did evaluation for the yield and fruit rates. And we could see good variability in case of fruit length, fruit weight, and the number of seeds per plant, fruit and fruit yield also. IHR, this HPG 24 accession is giving higher yield. But this is mainly due to number of seeds per fruit. But sometimes seeds are like preferred, sometimes seedlessness is preferred. Some sweet dishes preparation, seedlessness is more preferred, and some frying and all immature seeds, if it is having more, that gives different flavor. So these type of accessions we shortlisted for further evaluation. So this is the data for the 61 accessions for the different traits. And we could see, we have also studied heritability and GCV, PCV traits, and we could see good GCV and good PCV was observed for all the traits, and the heritability is high. So it shows that clonal selection is best, and we could able to, the selection breeding is best. Simple selection breeding is the best. So we did cluster diversity analysis also. We could able to see 5 clusters, and the 4th cluster and 5th clusters are very low yielders. And second cluster, that is 24 accession, it's having higher yield for around 11 to 12 kg per plant. That is mainly due to the number of seeds per fruit, and others are falling into the 1 cluster. So these accessions are being further studied for the 3rd year for the stability. Once it is done, some of the accessions with the local preference will be released or will be proposed for the variety. So coming to the Phytophthora melanis, this causes very huge losses, mainly causing leaf, vine rot, and even fruit rot. This is very, so we collected different isolates in the Odisha region, and then we morphologically characterized and molecularly characterized with the ITS and Cox primers. And then these have been deposited at NCBI database. Those isolates have been, and after that, those isolates pathogenicity test was proven, pathogenicity studies were conducted, and then we screened our germplasm for the resistance. So we could see 2 accessions, but that is IHRB pointed number 147 and number 30, showing good level of tolerance in case of leaf and vine rot. But in fruit, all the accessions were found susceptible. So it shows that there is a different genetic mechanism controlling or operating in leaf and fruit. So for fruit rot resistance, we need to screen more germplasm, or we need to induce through mutation. This is the only option, because all the 61 accessions succumb to or susceptible to the fruit rot caused by the Phytophthora melanis. And for Sclerotium lawlsy, another net blight disease, this is also huge, very big problem. And we screened all the accessions. All the accessions were found highly susceptible to the Sclerotium lawlsy. So there is only option, either we have to go for the future collections and screen, or induce through mutation. So with this conclusion, we can able to see good variability have been collected. Field gene bank is maintained at Bhubaneswar. There is a good variability among the fruit types, and we could identify 2 accessions tolerant to the Phytophthora melanis leaf and vine rot, but all the accessions were found to be susceptible to the fruit rot. And net blight disease caused by sclerosis also is all the accessions were susceptible. So there is a need for mutation breeding for inducing this resistance. Thank you very much.
Okay, thank you,
Naresh.
Dr. Naresh. Dr. Naresh, for your excellent presentation. I think we could able to see a lot of variation in the fruit size. I mean the external, color appearance, and also the stripes on the fruits. What is the maximum yield that was recorded among these accessions?
Sir, one accession.
You told about it.
Yes, 11 kg per plant we could record, sir, one accession. But that is due to seed, number of seed, and seed weight is more, sir, in that.
Because of more number of seeds and higher seed
weight, seed weight, sir. But that is not
seed
much
weight
different, sir. So an average around 3 to 4 kg, sir.
So our average is only 3 to 4 kgs.
Yes, sir. Because our soils are laterite acidic soil, sir. Bhubaneswar. pH is around 4.5. So we won't get good yields in that condition.
Okay. What is its main, the season of growing? You told in summer
and little rainy, sir. It will like February, like planting will be there, sir. So summer and it will go to rain. Nowadays, people are staggeredly they are doing, sir, to catch up throughout year. This one.
Yes, yes.
So during summer rain, one rain comes, those diseases are very problematic, sir.
Okay. Thank you, sir, Dr. Naresh, sir, for your nice presentation.
Thank you, sir. Thank you.
I think we'll move on to the next presentation. Dr. Madhumati. Dr. Madhumati, Principal Scientist, Horticulture and Head, Dr. YSRHU, Citrus Research Station, Petlur. She is going to present on evaluation of annual drumstick cultivars under southern zone of Andhra Pradesh. Dr. Madhumati.
Sir, good afternoon, sir. Is it visible, sir?
Yes, you can. Yes, you can start presenting.
Yes, sir. Good afternoon to the chairman and co-chairman and rapporteurs and moderator and also the participants of the session. To be part of this seminar, I have shared this research work done at HRS Anantaraspeta. So we know that moringa, also known as drumstick, which belongs to the family Moringaceae, which is an exceptional plant with wide-ranging applications in agriculture, medicine, and industry. It's the native of India, and because of its versatile uses, it was widely cultivated in tropical and subtropical worldwide. So and India being a prominent producer across the subcontinent. So in India, it's highly valued for its tender pods, leaves, and flowers. So with the pods being particularly popular in South Indian cuisine due to their inviting flavor. So the adaptability of moringa to our diverse ecosystems and farming systems, coupled with its fast growth and drought resistance, and it can be established. It's a vital component of the Indian vegetable industry. So traditionally, perennial types of moringa have been cultivated for a considerable period, but they face various production constraints like long pre-fruit bearing periods, limited availability of plant materials, and dependence on ample rainfall in water scarce regions and susceptibility to pest and diseases. So recently, the annual varieties of moringa have gained popularity as commercial crops because of their adaptability to different soil and climatic conditions and ease of cultivation, and their free flowering nature and versatile utility. With this view, an experiment was conducted at Horticulture Research Station Anantaraspeta with an objective to evaluate the performance of these annual drumstick varieties and also to find out the best performing or best suitable variety for this region. So with the experiment methodology adopted is 3 drumstick varieties, PKM1, PKM2 and Bhagya. These were the PKM varieties were collected from HCRI Periakulam and the Bhagya from UHS Bagalkot. So the seedlings raised in polybags were planted in the field with a spacing of 2.5 and 2.5 and with a randomized block design with 7 replications and growth and characters were recorded. So among these 3 types, the Bhagya recorded the tallest plants. The height of the plants is high in Bhagya, whereas the PKM1 recorded short stature plants, and it was on par with PKM2 also. Regarding number of branches and plant spreads, there are no significant difference among the varieties. But the pod characters, the superior pod characters were recorded in PKM2 with pod length 102.57 centimeters and pod diameter 19.67 mm and pod weight 178.25 grams and number of seeds per pod also more in PKM2. It was followed by PKM1 and whereas least pod characters were recorded in Bhagya. So with regard to the yield attributes like number of pods per plant and yield per plant recorded were maximum in PKM1 with 136.65 pods per plant and yield per plant is 12.77 kgs. So with this findings, it can be we can recommend that PKM as one suitable variety for southern zone of Andhra Pradesh because of its high yields and productivity. Not only that, though pod characters of PKM2 is better, but there are the packing, there is damage or losses during transport. So whereas PKM1 is having optimum pod length of 74.31 centimeters, so it can be superior, it can be better for growing in these regions. So these are some of the photographs. PKM1, because of its short stature, it can be grown not only as a monocrop, it can also be grown in intercrops of in fruit orchards. So Bhagya, which is a tall stature and pod length and pod characters were very short. Then PKM1, PKM2. So because the drawback here is the longer pod size. So it is these are the pod characteristics of the 3 varieties, and so with this study, it can be recommended that PKM1 is suitable for cultivation in southern zone of Andhra Pradesh due to its high yields and desirable pod characters. Thank you for giving this opportunity. Thank you.
Thank you, Dr. Madhumati, for the nice presentation on the topic evaluation of annual drumstick cultivars under southern zone of Andhra Pradesh. Any questions on this presentation? Dr. Madhumati, how about the incidence of pests and diseases?
Sir, compared to the perennial types, it is having less incidence of pest and diseases, sir. But after pruning, we are getting the borers, sir. After third year, in the third year crop after ratooning, so we are getting more stem borers. Sir.
Okay, stem borer in which variety? More incidence?
So
in all the varieties?
In all varieties, all varieties.
Okay. Okay, right. I think if there are no questions, I think we'll move on to the next presenter. Thank you, Dr. Madhumati.
Thank you.
I think you can come in. Huh?
The next speaker is Dr. Lakshmi Devamma, Assistant Professor, UHS Campus, GKVK, Bangalore. Ma'am, are you ready? Dr. Lakshmi Devamma. Ma'am, are you ready? Ma'am, please unmute. Are you there?
Yeah, madam.
Yeah. You can proceed, ma'am.
Yeah. Yeah, very good afternoon. Very good afternoon to one and all. The topic for my oral presentation is characterization of diverse advanced vegetable amaranth genotypes for fresh green yield and nutritional parameters. We all know that under the present situations, the narrowing of food crops as well as the narrowing of crop varieties has placed our future food security at a risk. Especially the economic growth will be hindered, and this augmented with the environmental consequences of the present climate change. It makes us essential to concentrate on the potential crops, the hardy crops, the unexplored nutritionally important crops. So in this direction, vegetable amaranth, especially amaranth, which is called as the sustainable crop of 21st century, plays a major role and has been valued against malnutrition in developing countries. Vegetable amaranth. Amaranth is a very diverse crop with several species used for several purposes, from grain to its leaf. Of the leafy vegetable, as a leafy vegetable, it's a most popular leafy vegetable, mainly which has impressive source of vitamin A, vitamin C, protein, leaf protein content, dietary fiber, rich in calcium, potassium, as well as micronutrients like iron and zinc. It's considered as one of the top vegetable for enhanced antioxidant levels. Apart from this, the vegetable amaranth, it's being cultivated from centuries, and it has been inculcated into the culture and tradition of local people, adapted to local conditions with its impressive nutritional quality. It's also known for its adaptability, its fast growing ability with high yield potential in marginal areas. Even though its nutritional potentiality is well known, most of the breeding works, genetic improvement work is limited to yield improvement, and only few cultivars are available. Especially the breeding program to enhance the nutritional potentiality is required. So in this direction, in order to quantify the available variation and the creation of desirable genetic variation, the present study was carried out. In this study, about several vegetable amaranth accessions were collected from across India. Of these, 85 were evaluated for 2 seasons, evaluated for fresh green yield traits as well as nutritional parameters, and few 50 diverse lines were also characterized using SSR and ISSR markers, especially to quantify the genetic diversity. And of these promising accessions, a few promising accessions which are having distinct morphological triads as markers were used in crossing program, especially to combine yield and nutritional potentiality. Since crossing is very difficult here, contact method, especially hot water emasculation and contact method of crossing was followed. That's why distinct morphological marker triads were considered between the parents to identify true F1s as well as to get segregants. And based on perceived performance and percent improvement over F2 segregants, several desirable segregants were selected and forwarded. The initial germplasm included all these species: Amaranthus tricolor, dubious, blightum, and viridis. This is the flow chart of the experiments conducted.
these several crosses were attempted. Several segregants were isolated from these two crosses. Recombinational variability was assessed, and they were forwarded further. And the stabilized lines as well as few promising selections were evaluated during Kharif 21-22. The lines forwarded from these crosses as well as few promising selections were evaluated. These are the parents. One such cross where diverse parents were used for distinct morphological traits. The F2 generated. This is the another cross, the promising selections and segregants identified. And this is the quantification of segregational variability in F2 generation of these two crosses for yield and yield attributing triads. Wide variability was observed in F2 for other triads, yield attributing triads. In F2 populations of both the crosses was quantified. And it was evaluated during the stabilized lines were evaluated during Kharif 21-22. This is the performance of these lines, advanced breeding lines, as well as promising selections for fresh green yield parameters. Here, these lines VA7, 136-1 and C34B2, they have given promising performance with respect to yield parameters. And these lines were also characterized for approximate nutrient composition, especially for potassium, calcium, phosphorus, as well as nutrients like iron, zinc, boron. And here also different lines have given performance. You can see here VA7 and 136, they have given higher yield levels. Apart from that, they have also given better performance for, even though not high, better performance for iron, better performance for manganese. But the C34B2, which has given on-par yield with Arca subula, but it has shown better performance for nitrogen, that is protein content, calcium, magnesium, zinc, and iron. And these are valuable breeding lines which can be forwarded further. So these are the lines, top 5 lines for each of the nutrient parameter. Each of the nutrient parameter with top 5 lines which we can forward and stabilized in future generations. So these are the lines which have been identified, the promising lines for fresh green yield parameters, C34B2 for nitrogen, zinc, iron, phosphorus, and potassium, and C12-1 and VA7, C12-1 for calcium and magnesium, and VA7 for nitrogen, potassium, zinc, iron, and boron. And few of the segregants are in farm trial. Few of selections of this experiment are in farm trial, and a few are being stabilized now. And these are the most promising lines which can be further stabilized, evaluated across the locations, and forwarded further in breeding programs. Thank you, Ananda.
Thank you, Dr. Lakshmi Devamma. Any queries from the participants? Any questions from the participants? Ma'am?
Yeah, madam.
You have made a lot of crosses, no? Are all these species you used are self-pollinated, or you made the inbreds from cross-pollinated ones?
Yeah, madam. Tricolor, these two crosses which I showed, they're between tricolor, madam. Amaranthus tricolor. Dubious, I tried, madam, but I could not. Dubious, since it's a tetraploid. But few promising selections in dubious I have made, madam. Dubious and tricolor, mainly I have more germplasm.
Okay.
Yeah.
Because in F2, lot of variation. The segregants are very clear. Yes.
Especially
so I wanted to know.
Grain amaranth also I did, madam. There also we found so much variability. That also 120 lines we evaluated. There also we found so much variability, but that forwarding that variability is the difficult task.
Yes, ma'am. It's a very good number of germplasm
Yes.
to deal with.
Madam,
Thank you, ma'am.
Madam, one
Yeah,
question.
madam.
Yes.
Yeah, yeah.
Lakshmi madam, Naresh.
Yeah. Tell me, Naresh.
Madam, this F2, this is individual plants or you stabilize the lines, this?
F2 is individual plants.
Okay, from there you selected and
I
forwarded.
selected, I forwarded for 4 to 5 generations that I evaluated this season.
Okay, madam. Okay, thank you.
F2, I grew around 700, 800 plants.
From there you
I just selected. After 2 to 3 generations, I used bulk method, just bulk method. Based on morphological uniformity, I forwarded.
Okay, madam. Thank you, madam.
Yeah.
Ma'am, the yield you mentioned, is it a single harvest or
single harvest, madam? Single harvest, madam. Single.
Okay.
In this
Thank you very much,
generation,
ma'am.
single harvest. Thank you, madam.
Yes.
Thank you.
The next oral presentation is from Dr. Virupakshi Hairmata.
Hello, madam.
Are you there?
Yes, ma'am.
Yes. Proceed.
Could you please share the slides? I'm not getting any options to sharing option.
Yes.
Shall I?
Yes, sir. You can proceed.
Good afternoon to one and all. I'm Virupakshi Hairmata from Indian Institute of Horticulture Research, Bengaluru. India is achieved. Slides are not easy.
So 1 minute, sir.
Okay, ma'am.
Sir, you can continue.
Okay, madam. Thank you. India has achieved the self-sufficiency in food production with the record of high production of 305 million metric tons of food grains. However, with the 195, next slide, with 195 million undernourished children, malnutrition remains to be perceived health problems. India aims to ensure the food and nutrition security for the most vulnerable through increased production of fruits and vegetables. In addition to huge post-harvest losses, fruits and vegetables are the matter of grave concern to the Indian horticulture sector because of their high perishability. Extended the shelf life of fruits and vegetables is improving their nutritional value is the food and food need to movement of great challenge for the horticulture scientist. In India, with the rich biodiversity, less than 30 vegetables are cultivated and consumed on commercial scale. The underutilized vegetables crops, which are neither grown commercially on large scale or nor traded widely, have drawn less attention due to their poor agronomic performance. But there are good source of vitamins, minerals, trace elements, dietary fiber, and proteins, and serve to be as a great genetic resources for the multiple biotic and diabetic stresses. The Western Ghats of the India is the hotspot of the biodiversity for the both flora and fauna, and the highly diversified in many underutilized vegetables food crops. Underutilized cucurbits of the Western Ghats are rich source of nutritional and aesthetic values. In this cucumis, we have crossed the two different species of same family. The cucumis mellow, it is muskmelon, and the crossed with the Mangalore melon, it is a cucumis mellow agrestis acidulus. It is the muskmelon is the juicy, tasty, and delicious desert vegetable, popular for its nutritive and medicinal values. Most of the muskmelon varieties are climatic and have shelf-life 15 days at ambient conditions. Then opportunistically, the Mangalore melon, locally preferred as a Mangalore Saute or Sambar Saute, it is a non-desert melon with a long shelf life up to 1 year. Is a breeding treasure for the enhancing shelf life of the other melons. It is a low calorie vegetable comprising of 3.6 protein, 4% of fat, and 2.5% of carbohydrates. Are the rich source of phosphorus, potassium, iron, zinc, and ascorbic acids. Realizing the importance of the potential of this crop, we have crossed the two different. We have crossed 15 different melons with the muskmelon and Mangalore melon. In that, we selected 3 Aramadu, Maduras, and Arkasiri. And with the cross with the SS17, Sambar Saute 17, MS78, MS79. In that, we selected the Arkasiri and SS17 with the fruits. Next slide. With this, coming to next slide. Next slide. Next. Next. In this, we are crossed the Arkasiri into cross with the SS17. We got F1 and F2 and F3 populations. Previous section. Okay, in that we did phenotyping characters in Horticulture College of Sirsi and developed the F2 populations. Mapping populations were developed from the Arkasiri and SS17. The screening using the SSR markers. The genotyping of using the ICM mapping, the software constructed the linkage map and QTL mapping identified in the ICM mapping software. In that, we have used the 276 F2 populations and the 41 SSR markers, highly polymorphic markers are used. And then next. We have got 11 linkage groups mapped on 11 chromosome, 11 linkage groups are we got using the 41 markers. In that 6th chromosome having the highest number of markers, it's the number of 10 markers are mapped. In that average marker distance is 377.50 centimorgan. In that less number of markers is in the chromosome number 10 and 4. There is only one marker is mapped. Because of less number of markers, we could not get to fine mapping. Next. In that we did the QTL mapping using the ICM mapping software. In that we did for this 4 traits: shelf life, fruit yield per vine, TSS, and flesh thickness. We got 15 QTLs. QTLs. First one is self life having the QTL. It is a major QTL on the chromosome number 3 with a large value of 5.5. The additive value of 0.92 and 6.52. Dominance effect shows the 6.15 trait is transferred from the SS17. Is the self life is extended the self life from extended self life of muskmelon from the Mangalore melon. In the fruit yield per vine, we got 9 QTLs. In the TSS 4 QTLs and flesh thickness are 2 QTLs. We have extended the shelf life of muskmelon cross between 15 days to 128 days. Next. This figure represents the we are shown on the chromosome number 3. The highest number of first major QTL is identified green color. It shows it's the shelf life. Fruit yield per vine. There are 2 QTLs and 1 QTL for the shelf life, and the marker number is the CMMS 12-4. We identified the 6 QTLs in this for 4 different traits. Next. From this, we concluded muskmelon enhanced its self-life using the different Mangalore melon species. Newly developed varieties use their novel donors for the self-life and nutrition, enhance the genetic diversity of the different underutilized vegetables of Western Ghats. And this is used for the higher income for the farmers, expansion of the area of muskmelon production in all over India. It avoid the post-harvest losses and it overcome the malnutrition. Thank you.
Thank you, Virupakshi Haidmata. Any queries? Any clarifications? So, Dr. Virupakshi.
Yes, ma'am.
You have been tested for shelf life, no? Or all these vegetables are for fruit purpose?
For fruit purpose, ma'am.
Okay.
It's muskmelon
So you
only.
identified. Okay. Because I think acidulus is used as a vegetable, or is it is fruit?
We use cross between the muskmelon and Mangalore melon. We have to get the fruits like muskmelon only, ma'am. With the enhanced self-life, we got in the F3 population. It's a population under 5th generation. It's extended self-life 128 days with the TSS of 13.
So we are using it as a vegetable,
yes,
not as a fruit. Okay. Thank you. Any other queries from the participants? Thank you, Dr. Virupakshi.
Thank you, ma'am.
The next presentation is from Ms. Supriya Mandal.
Yes, ma'am. Can you share the screen?
ICRIARA. Yes. She is presenting on population structure and genetic diversity analysis based on agromorphological traits and SCOT markers in drumstick. One minute.
Okay, ma'am. Good afternoon, one and all. Myself, Supriya Mandal, and as Madam already introduced, that my oral presentation topic is population structure and genetic diversity analysis based on agromorphological trait and SCOT markers in drumstick Moringa oleifera. Next slide, please. Ma'am, slide is not visible to me.
Is it visible now?
Yes, ma'am. Second number slide. Why moringa comes under ethnic vegetable group. Here, our research is only concentrated on moringa leaf, not on the pot purpose, because moringa is normally known as a miracle tree, mother's best friend, horse radish tree, or the drumstick tree. But all the research mostly on the annual moringa pot production purpose or the pod related purpose. But our research is concentrated on the moringa leaf purpose, because the leaf is rich in high nutrition, and it is also called as the mother's best friend because it is rich in micronutrient, and it also capable to combat the hidden hunger and malnutrition. As the data says, over the 2 million population of the global people is suffering from the hidden hunger and micronutrient deficiency, and half of them is lives in India. So moringa leaf capable for introduction in the culinary purpose and also pharmaceutical industry to combat the malnutrition purpose, and also it is high in nutrition density score, and in economic purpose also it is rich in export purpose. Like export worth of the moringa leaf is 2.5 crore in January-February of the 2018 as per the data of the APEDA. So based on this regard, we are governing on research on genetic diversity of the leaf field purpose based on the agromorphological and molecular characterization. So we can go for the specific trait breeding gene along with the transcriptive segregant obtained, and which will give a genotype, or later it will propose as a variety for the high leaf field purpose along with high nutrition and low oxalate. Next slide, please. Material method constitute that the research was conducted in block 2 experimental field vegetable block in IHR Bangalore, and our genotype constitute 52 genotypes coming from the 6 different state of the India, and which constitute of the only southern and western and eastern state like the Odisha of the India, and this state is the major growing and popular for the drumstick production in our India. So our design was constitute a randomized complete block design, whereas year it was governing in 2018 to 2020 in the 3 consecutive years. Agromorphological trait, here I am only giving 6 morphological trait which is related to the leaf field purpose, and molecular marker used is SCOT. Next slide, please. Here I am showing the phylogenetic tree of the 52 drumstick genotype based on the phenotype trait, and here we can see the whole 52 genotype. The peak is in 3, mean the whole 52 genotype is divided in the 3 different cluster group, where the blue mark is governing the 84.6% accession, where is the 44 accession is grouped, whereas the 13.4% of the all genotype is grouped in the black color, and where is the only one genotype, that is IHR D4, that is origin is the Tumkura region of the Karnataka, that is distinctly related to the other 2 cluster which is grouped as a yellow color. And in right side I am showing the heat map of the all accession obtained from the morphological characteristic, where the blue color is showing the high value for the correlation, like the stem girth is positively correlated, mean the blue, the intensity of the blue color is increasing, so the correlation part is also increasing. Like stem girth is positively correlated with the number of the shoot of the plant or the shoot length and thickness, whereas the whole leaf yield is strongly positively correlated with the edible leaf yield. Next, please. Next slide. Hello, ma'am. Ma'am, slide is not moving. Hello, ma'am.
Ma'am, yeah, you are audible.
Okay, ma'am. Where it was stuck, I don't know, ma'am. That last slide, it was audible, phylogenetic tree and heat map.
Yeah, it was audible.
Okay, ma'am.
Please
Now
continue.
the okay, thank you so much. For now, it is the molecular characterization based on the SCOT marker. SCOT is the start codon targeted polymorphism. This is the new marker, and it is the modification of the RAPD marker. So total number of the marker we have used 20, and the average band per primer we got 180.9 band per primer with the 60% polymorphism, which is the at par with the other marker used like AFLP or RFLP primer in earlier study like in drumstick. Also, it is more than our SCOT primer diversity in other vegetable like sweet potato, and also in other horticultural crop like rose. And this is the first time the SCOT primer is used for a designed genetic diversity program in the drumstick. So for SCOT primer in drumstick, there is no earlier review or literature is there. This is the first time. So here lower part, here we are giving some amplification profile pattern of the Scott 1 and the Scott 16 we have presented, and it is showing the fully polymorphism is there in all over the 52 genotype. So next slide is. Next slide. This is the dendrogram that in dendrogram we are seeing neighbor this is two analysis is there for the molecular analysis, like in right side we are showing neighbor joining cluster group the genotype into three major cluster, where is the three major cluster doing the in each cluster two subgroup is there, so total is the 6 cluster, and in sub cluster in main cluster 1 the 18 accession is there, where is the cluster 2 19 accession there, and in cluster 3 15 accession there, but the grouping of the cluster it is not showing any specific geographical identification. And also this neighbor joining cluster will help in the selection of the divergence parent for the trait specific breeding, like for the higher leaf field purpose along with the high nutritional purpose. Here I did not present all the data related to the leaf field because it is huge data set, so I am presenting only the analysis based on that data, and based on the result obtained from the structure analysis, the bar diagram is there in lower side, that bar plot there is the green and red bar is presented. So in two structure is there because the delta K value is the 2, so 2 group population is there, like cluster 1 or population 1 is consist of the red color bar, which is the 15 accession is there, where is the next population 2 that is the green bar diagram is there, that is constitute the 25 accession. So this 2 accession is continued the delta K score more than the 80%, or delta score value is more than the 0.8%, so it is a pure accession. Where is the in that pure accession where some 2 or 3 genotype is there which constitute the score value or delta K score value less than the 0.80, so that was constitute in the admixture group, and in admixture group normally IHRD 120 IHRD 185 or IHRD 80 is constitute. What is the in population 1 I have showed in the PPT also. In population 1 the 2 commercial variety of PKM1 PKM2 is constitute, and in the population 2 in the green bar diagram the Bhagya, which is obtaining from the CO Arvabi campus UHS Bangalore College, and another one genotype IHR-D28 that is also obtained from the Karnataka. These 2 accession is constitute in the population 2, and in population 1 the 2 commercial variety. The next slide please. In left side, I'm showing the pie chart depend on the AMOVA, that molecular variance depend on the molecular data. That pie chart for the AMOVA showed lower genetic divergence among the population, like 17% for the among the population divergence, where is the higher genetic variation within the population. Within the population the variation is more, that is depicted as a reddish or brown color, like 83%. And being cross-pollinated crop, it is also justified because this pattern is goes well for the cross-pollinated crop, because cross-pollinated crop low gene value among the population, as well as long distance seed dispersal mechanism also exists, and the low dispersal of the pollen mechanism also exists. So for the cross-pollinated crop, it is also this pattern of the variation also goes well. In the right side, the principal component analysis of the 52 drumstick accession was showing, that is the in principal component analysis depend on the morphological data we are seeing. In the genotypical data also, the genotype is divided in the 3 different type of the group, and here also no geographical identification or no clear geographical isolation is there. Depend on this principal component analysis, we can see the as the annual moringa planting material is seed, and there is no restriction between the state to state for the seed dispersal or the planting material transportation, so there is no clear geographical isolation is presented. Next slide. here comes the conclusion, and in conclusion we got different type of the 5 to 7 genotype like IHD 20, IHD 120, IHD 181, and along with one base genotype we got like IHD 28 that had the superior leaf yielding capability more than the 2.5 times than commercial variety, as IHD 28 shows the 9 kg edible yield per hectare in a season, whereas the PKM1, our the best commercial variety, shows the 5 kg edible yield per hectare. So our research, our one research material like IHD 28, it can also overcome or outperform our commercial PKM1 plant as a leaf purpose. We are not telling as a pod yield, it is only for the leaf yield purpose. So also for the genetic divergence analysis, the subcluster 3 also contain higher leaf yielding purpose. So if the breeder will go for the trait specific breeding, for the hybridization also we can select the distant genotype from the distant cluster, and we can go for the trait specific breeding. And also in blue color sentence I am mentioning that no distinct relationship between the geographical origin is there, as the adjacent state there is a no regulation depending on the transport material of the planting material, as it is seed propagated basis. And also what is our way forward, or what is our future aspect? Further we can go for the evaluation of the same genotype for the high density planting, like we can reduce the plant density, plant distance from the 60 centimeter to 1 meter or 1 to 2 meter. And also the outperform genotype we can go for the released as a leafy purpose variety, because for the leafy purpose we
It exceeds the time limit.
okay madam, last and already in
Conclude.
2000 last madam, already in 2021 ICR, the official tweet account of the ICR tweeted our one genotype IHD 28 for its outperformance on their official website. And this is a variability studies picture. What is the this is showing the foliage density and also different color of the leaf powder, which is good importance in the pharmaceutical industry. In right side I am showing the different type of the leaf petal shape like oval and ovulate, and also in lower side I am showing the leaf sprout color varies from the green to purple. Thank you. This is our research plot system view overview. Thank you for the kind attention. Next slide. Already I am completed madam. Next slide, that is the thank you slide.
Okay. Thank you, Miss Supriya. How old are the trees?
Ma'am, this is the after normally the trees is 2 years old, and this picture depicted the 2 month after the pruning, madam. As our researchers only on the leaf, we are doing several pruning, and after the 2 month of the pruning, we are taking the data, madam. That new sprouted leaf.
Okay. Okay. Thank you. Any queries from the participants? If no queries, thank you. The next
Thank you,
presentation is from Miss G. Indrajan. Are you there?
Yes, ma'am.
Yeah. Please proceed.
Slides are visible, ma'am. Slides are visible, ma'am.
Yes, yes.
Good afternoon, one and all. My name is Indraja. I'm going to present on molecular characterization and single marker analysis for rust resistant in French bean. French bean is one of the most important leguminous vegetable cultivated throughout the world for its green tender pods as well as dry bean. The consumption of French bean is increasing because it is a rich source of vitamins and minerals. However, the successful cultivation of this crop is hindered due to the various biotic stresses. Among them, rust is one of the most important serious disease, which is caused by the fungi Euromyces fascioli. And this disease leads to the yield loss to the tune of up to 78%. To the control of rust disease, several fungicides are used. However, the usage of these fungicides lead to ecotoxicological concern. So, host plant resistant is the ideal way for the control of rust disease. Hence, there is a need to develop varieties that are resistant to rust. However, in French bean, varieties resistant to rust were limited. So, the ideal way for developing rust-resistant varieties is identification of rust-resistant genes and incorporation of these genes into varieties and further varieties were developed. So we carried out an experiment in ICAR IIHR Bengaluru during 2019 to 20 with the objective of identification of scar markers linked to rust-resistant in French bean varieties and incorporation of rust-resistant genes into pole-type French bean variety, Arca succumal, and evaluation of F2 generation. For this experiment, we used 10 scar markers in 10 French bean varieties. These are the list of scar markers that were used in the present study. This is the amplification profile of 10 scar markers in 10 French bean varieties. Out of these 10 scar markers, only 3 markers were able to distinguish between resistant and susceptible varieties. Those markers are SA14, SAE19, and SBA8. This is the general view of the amplification profile of the scar marker in 10 French bean varieties. In this experiment, we used SAE19, which is carrying UR11 gene. So we want to introduce this gene UR11 into pole-type French bean variety Arca succumal. This is the schematic representation of the development of F1 hybrid and F2 population. For this experiment, we crossed Arca succumal pole type with the bush type IIHR31 during 2020-21. In this F1 population, again screened for carrying UR11 gene in F1 population. This is the representation of the gene UR11 in F1 population, which is amplified by the primer SAE19. After this, all F1 plants were subjected to cell and we developed the F2 population. We developed nearly 192 F2 population, and in this F2 population, we studied the inheritance pattern of the gene. And this is the amplification profile of the primer SAE19, which is carrying UR11 gene in F2 population. After that, we studied the gene inheritance pattern. For that, we studied the chi-square estimates between Arca succumal and IIHR31 in F2 population. Out of 192 F2 population, 153 plants were showed resistant and 39 plants were showed susceptible. In this F2 generation, the gene was segregated in the ratio of 3:1. Apart from the gene inheritance studies, we studied the single marker analysis. In this, the marker SAE19, which is carrying UR11 gene, showing phenotypic variance of 72% in F2 population. So it is considered as a major marker for validation of rust in F2 population. Finally, we concluded that in this study, the line IIHR31 is carrying all the resistant gene, which is amplified by all the 10 scar primers that were used in the present study. Hence, in further studies, it can be used as a donor parent for rust resistant in marker assisted breeding program. And in F2 generation, here the gene which is used in the present study, UR11, is segregated in the ratio of 3:1. So it is concluded that the gene is governed by a dominant in nature. Thank you.
Thank you, Indiraja.
Thank you, ma'am.
Any clarifications from the participants? If no, we switch on to the next presentation. Thank you, Indiraja.
Thank you, ma'am.
Now, Mr. R. Subhash.
Yes, madam.
Are you there?
Yes, madam. Yes, madam.
Yes. Yes, please proceed.
Yes, madam.
అమ్మాయి చెప్తాను.
Very good afternoon to respected dignitaries over here. Here my topic, myself, Ramadgu Subhash, pursuing PhD in Department of Vegetable Science, Dr. YSRH, College of Horticulture, Anantarajpeta. Here my topic is genetic variable studies in advanced breeding populations of chili for yield and yield attributes in capsicum annum. So generally, chili contains lot of variability. However, we have developed a advanced breeding population.
Subhash,
Yes, madam.
Subhash, please share your screen.
Yes, madam.
We are not able to visible.
No, it is not visible on the screen.
Please check and once again you share your PPT.
Wait, madam. Wait. Now it is visible, madam.
Yeah, now it is visible. Please proceed.
Good afternoon to respected dignitaries over here. Myself, Ramadgu Subhash, pursuing PhD in Department of Vegetable Science, Dr. YSRHU, College of Horticulture, Anandrajpeta. My topic is on genetic variability studies in advanced breeding populations of chili for yield attributing traits. Here, why this work has been done by me and my co-workers. Generally, chili contains a lot of variability. However, we have developed a advanced breeding lines for the bacterial wilt resistance, but special attention is needed for not only special attention is needed for yield also for developing a line or variety. So in this point, we have studied a variability in the yield and its traits in the advanced breeding population. Here, my objectives are evaluation of Anugraha cross for yield and its variability of F4 families of IHR B HP-130 cross CM334 population for yield and its yield attributing traits. Different methods.
Mr. Subhash,
yes, madam.
the slides are not moving.
Now, madam. Madam, is now it's moved, I think so.
No, the slides are not moving.
Again, I will share. Madam, now it is okay, madam.
Yes.
Hello. So coming to the material methods, evaluation. Okay, madam. Evaluation of Anugraha cross CM334
It is
derived
showing
from
the first slide only.
Yes, madam.
It is showing the first slide.
Now
it is showing the first slide only.
Oh, okay.
We have started sharing slides and please explain one of the slides.
So we share your slides. You please explain.
Okay.
Okay, proceed.
Wait. Stop share. Share. You can share, madam. Hello, madam. Can I start, madam?
Yeah, proceed, Subhash.
Objectives. Here comes the topic is genetic. Here the material methods are evaluation of Anugraha cross CM334 derived from selected recombinant inbred lines and F4 family, and one more population is F4 families of IHR B HP 130 cross CM334. Both population were studied for yield and its attributes. For Anugraha cross CM334, we followed the RCBD design with 2 replication to control the error, and one more is F4 families. One IHR BHP 130 cross CM334 is evaluated in the augmented block design. Here we have the large population with the total 182 families, which were divided into 7 blocks. In each block, 22 families were accommodated along with the checks. The checks were IHR BHP 130 and CM334. Both parents are used as a checks. Next, coming to the next slide. Next, the observations were recorded, number of primary branches, how the from the main branch, number of primary branches arise, we have counted, and plant height from the top to bottom, we have measured, stem width, fruit length, fruit weight, petal length with measured with the help of the vernier calipers, average fruit weight, number of fruits, yield per plant, we have calculated. Next slide. Coming to the results, it is a cross of Anugraha cross CM334 of advanced recombinant inbred lines for yield and its attribute traits. The nature and magnitude of variability was clearly observed in the 9 different qualitative characters, which is total 22 real populations were there. In that, mean performance is also good, with the high yield per plant was also recorded in the AC reel 58 with 1631 grams, followed by AC reel 31 1267 grams. And next is variability. Coming to the variability, PCV is greater than the GCV was observed in the almost all the characters. Next one is the high GCV, high heritability, high genetic advance as percent of mean was observed for most of the traits, which says that additive gene action, which is a simple selection, can be followed. Next slide. Here the table indicates the GCV PCV. PCV is higher in the almost all the nine traits when compared with the GCV. This indicates the environmental influence is more in the almost all the 9 characters in this cross. Coming to the heritability, almost all the parameters contains more than 80% of heritability, except the stem gait, which contains 63.44. Coming to the genetic advance, it is also good in almost all the parameters. Coming to the individual trait, yield per plant contains a high amount of GCV, PCV, heritability, and genetic advance, and genetic advance as percent of mean. Next slide. Next, it is one more population, which is F4 families. It is a cross between IHR BHP 130 cross CM334 for yield traits. So it's there is a significant variation is found in the plant height, stem width, and fruit length and yield per plant, whereas other traits didn't show significant variation. And coming to the next variation, PCV is greater than GCV in almost all traits. It also indicates that the environmental influence is more. Next, high GCV and high heritability, high genetic advance is indicating that it contains indicate that it contains additive following the additive gene action. Next slide. Here is the photo indicates that the F4 families contain variability in the fruit traits of the fruits. Next slide. Here we can see that the same pattern following in the as followed in the previous cross. PCV is higher in the almost all the in all the 9 parameters when compared with the GCV, and heritability is also showing a lot of variation from 1 to 9 1.06 to 94.07, which indicates that there is a lot of variation in the trait heritability, and genetic advance is also observing that a lot of variation among the all. Next slide. Coming to the conclusion, PCV is greater than GCV were observed in the almost all the characters in the both population. It indicates that environmental influence is more in addition to the genetic expression of all the characters. High level of heritability, which is greater than 80%, were observed in the all characters of Anugraha cross CM334. Whereas in case of F4 families, wide range of variability, heritability from 1.06 to 94.7%. Coming to the last point, characters with high GCV, high heritability, high genetic advance as percent of mean, showing that our plant height followed by number of primary branches, number of fruits per plant, fruit length is selected in selected reels of Anugraha cross CM334 showed. And coming to the F4 families, plant height, stem width, average fruit weight, yield per plant, showing that governed by the additive gene action, which can be improved through the symbol selection itself. Next slide. Thank you. Thank you.
Any clarifications from the participants? If no, thank you, Subhash.
Yes, ma'am. Thank
The
you.
next presentation is from Mr. J.P. Datta Reddy. Are you ready? Mr. Datta Reddy.
Yes, ma'am. Yes, ma'am. I am sharing my screen. Am I
Yeah.
audible, ma'am?
Yes, yes.
Is my screen is visible, ma'am?
Yes, you proceed.
Is my slides are moving, ma'am?
Yes, please. Yes, please.
One minute, ma'am. I am facing difficulty here. Yes. Good evening. Good evening, ma'am. Myself, Datta Reddy, working as a scientist, horticulture in Banana Research Station, Pulivendula. Today, I am presenting presenting on topic marker-assisted backcross integration of CMPH gene from native Indian melon into cultivar variety that is Arcasiri to improve the fruit acidity. As we all of know, melon has an important commercial desert cucurbitaceous crop which is grown in tropical and subtropical region, and also India has a very harbor for the genetic diversity of the muskmelon, which is having the harboring the many quality traits. There are three main types of non-sweet melons were cultivated in India as a land races. That are the Cucumis species agrestis, that is acidulus, and Cucumis species agrestis agrestis, that is Konoman, and third one is Cucumis species agrestis momodesia. And another one that is sweet melon, that is Cucumis melo species melo. Here we have the many market segments, that is Canariello, Gallia, Honeydew, Chansians, and Cantaloupes, and Madras, and Kacharis. These are the horticulture types and market segments which is very famous in muskmelons. Here, our present study is to identify the gene which is responsible for the fruit acidity, and we have to transfer the integrate this CMPH gene into the cultivated melon to induce the sugar acid blend into the muskmelon. Here, fruit acidity, which is important quality parameter due to the presence of the organic acids, that is citric acid and malic acid. Normally, these melons are exhibiting the low level of organic acids, but subspecies like some species like Konoman and Chinensis and Makwa and Memodesia is having the exhibiting the high level of organic acids. Scientist Cohen et al. In year Cohen and his co-workers in year 2014 earlier reported the candidate gene which is named as CMPH in population derived from the cross between the high pH variety and low pH Indian snap melon, that is Memodesia group. They observed that the 12 base pair of duplication in the gene which is responsible for the loss of acidity in the melons across the different species. Here, source of different Indian melons, that is the Indian melons which is having melon diversity which is having the CMPH gene. In this regard, we published one paper, that is the design and validation of the codominant molecular marker for the fruit acidity in muskmelon. That is, we designed one marker named duplication 12. Here, a primer set, we designed one primer set that is planting this duplication event of 12 base pair. Here, we have the sequence results also. And next, we used this marker, this duplication 12 marker for the marker assisted background selection. It is a schematic schematic view of the total marker assisted background selection program. Here, Arkasiri we used as a recurrent parent, and IHR 625, which is Konomon type, used as a donor parent. Here, foreground as a foreground matter, we used duplication 12 and 19 sets of SSR markers were used for the background markers. Here we performed 4 generations of crossing, that is in case of BC1 F1 and BC2 F1 and BC2 F2, along with F2 population also we growed. Here, the segregation of duplication 12 as a foreground marker showed a goodness of it with the expected ratio of 1:1 and 1:1 and 1:2:1 in BC1 F1 and BC2 F1 and BC2 F2 generations respectively. And the background analysis that is revealed that the recurrent parent genome recovery recorded from 73.86 to 84.21% in BC1 F1 and 78.94 to 94.73% in BC2 F1 and 89.47% to 100% of RPG in BC2 F2 generations respectively. Here we have we identify out of the 92 accessions, we identified 32 accessions were native types, which is having the posting the acidity, and this diagnostic marker which is developed, the duplication 12 were diagnostic for the acidity in melon, and third one is we developed EDV, essential derived variety of Arkasiri, which is posting the acidity. And next, further, we need to conduct the multi-location trials for these releasing EDV of Arkasiri, and this EDV of Arkasiri may also utilized for the breeding program to produce the F1 hybrid, posting the high sugar and acid blend, and also to identify the interface lines which do not have the deleterious effects on the fruit shape. Because we have much food deleterious effects on the fruit shape. And the last one is this developed marker can also use the transfer of the acidity of different market segments like canary melons, imported one. So thank you, madam.
Thank you, Mr. Datta Reddy.
Yes, ma'am.
Any questions from the participants? Then we switch on to the next presentation by Ms. A. Reshma.
Yes, ma'am.
Reshma, are you there?
Yes, ma'am.
Yeah, please
Hello.
proceed.
Ma'am, will you please screen share my PPT, ma'am? Good afternoon to one and all. Myself, A. Reshma, pursuing PhD in College of Horticulture, Anantarajpeta from the Department of Vegetable Science. Today, I'm here to deliver my presentation on genetic diversity studies in open pollinated seedling progenies of elephant foot yam using SSR markers. Next slide, please. The main objective of this study is to assess the genetic diversity in open pollinated seedling progenies of elephant foot yam using SSR markers. And this experiment was carried out in HRS Kobur in augmented block design, and number of accessions are 24 along with the 2 checks, and spacing followed is 60 by 60 centimeters. And high quality DNA has been isolated from the 26 accessions of elephant foot yam using the CTAB protocol by following the standard procedure for DNA isolation. And next slide, please. allele frequency, allele heterozygosity, and polymorphic information content have been assessed from these SSR markers, and 19 SSR markers have been used. Among them, high allele frequency has been observed with the markers AMPA234, whereas lowest allele frequency was observed with the marker AMPA9. Regarding allele heterozygosity, highest allele heterozygosity was observed with the marker AMPA9, whereas lowest was observed with AMPA19, and polymorphic information content was high with the marker AMPA9, whereas it was low with the marker AMPA4. No polymorphism was observed. That means the primers which produce monomorphic bands were AMPA2, 3, and AMPA14. Next slide, please. And these are the gel profiles of 26 accessions of elephant foot yam using different primers, that is AMPA 1 and 6, showing polymorphism, which indicates the presence of genetic diversity. Next slide, please. And this is another gel profile of 26 elephant foot yam accessions with another primers. Next. And same gel profile of 26 accessions of elephant foot yam using AMPA 11 and 15 primer. Next slide, please. And the Jaccard similarity coefficient was assessed to establish the genetic relationship between the accessions. Genetic similarity based on Jaccard similarity coefficient revealed considerable level of diversity among the accessions under study. And the accessions having the low similarity index, they are considered to be more diverse. Here, the accession AP by 1420 with OP by 14.2, they has recorded the least similar coefficient, which indicates the presence of more diversity when compared to other land races, whereas high similarity index was observed with the accession OP by 1444 and OP by 1436, which indicates that they are less diverse. And next slide, please. And based on UPGA dendrogram, the accessions have been grouped into different clusters based on SSR analysis. And UPGA dendrogram revealed two main clusters, cluster 1 and cluster 2. And cluster 1 is again subdivided into different subclusters. And subcluster 1B has more number of accessions, followed by the cluster number 1A. And the accessions which comes under one clusters, they are genetically similar. And next slide, please. And this is a UPGA dendrogram showing the different clusters and its main subclusters. Next slide. And finally, from this study, it was concluded that at molecular level, OP by 14.2 and OP by 14.20, they were found to be more diverse when compared to the other land races. Though OP by 14.20 is having more diversity with more yield, it has high oxalate content, which is not desirable character in case of elephant foot yam, especially for cooking quality and export purpose. The present study in using of SSR markers reveals that polymorphism was found to be efficient to distinguish some important accessions, and it certainly it will be useful for certification of varieties and development of high yielding coupled with low oxalate content varieties. Thank you.
Any questions from participants? Reshma, what is the plant population?
Madam, 24 accessions along with 2 checks we have used, ma'am. The Jendra and the Sri Padma.
Okay. Thank you, Reshma.
Thank you, ma'am.
The next presentation is from Dr. K. Lakshmi Kala. Are you there? Dr. Lakshmi Kala.
Hello, madam.
Yeah. Please proceed with your presentation.
Madam, can you share the PPT?
Yes. Please start.
A warm good afternoon to everyone. Myself, Dr. K. Lakshmi Kala. Today I am here to discuss a short brief notes on underexploited melons, a source for shelf life improvement in melons. We all know the cucurbits and most of the melons are very highly perishable in nature. And also, next slide, sir. Next slide, please. Next slide, please, sir. We all know the post-harvest decay of fruits and vegetables nowadays is a major challenge in the present areas. Now, for post-harvest decay, the main two factors are the fruit ripening and this softening, and these two are the major responsible which contribute to the perishability of the fruits and vegetables. Even though fruit ripening is delayed, they can be delayed to several external procedures like development of hybrids from shelf life resistant varieties, and also by conventional methods or by using genetic conventional method or by using non-conventional methods like gene silencing and etc. Next slide, sir. We all know that muskmelon is a typical climatic fruit which exhibit a heavy high rise in ethylene production and respiration rate during summer. This leads to very less shelf life of the melon, and some of the melons are classified as climatic fruits, causing huge losses within a short period between harvest and also consumption. Poor keeping quality limits wide commercial acceptance, and thus long shelf life has become an indispensable character in modern cultivars of melon. Nowadays, the main focus is on developing the shelf life resistant more days of shelf life for the melons. In this component, this Cucumis melo is this is the most diverse species of the genus Cucumis, and in other countries we generally according to Munger and Robinson classification, we have only 7 classes, and in other countries they will this muskmelon is named in different names like netted muskmelon, salmon flesh cantaloupe, smooth skinned and green flesh honeydew, winkle skinned cassava, which is a kind of inodorous species, and also long shelf life hammy melon, and small and thin pericarp makua, and also non-sweet pickling, and also cooking oriental melon. Next slide. Generally, there are 3 components for selection of the varieties, which belongs to the first component. It is mainly related to variation, growth duration, and days from pollination to harvest, seed size, fruit weight, and shelf life. And based on this, according to this, the varieties Saccharines and Inodorous, Makua, and Acidulas, these with high relatively long growth period and days from pollination to harvest, large test weight of seed, and also fresh fruit weight, good shelf life. The Saccharines and Inodorous species are examples for the first component, and the second component is mainly depends on flesh juiciness, fruit shape, stem hair, flesh color, abscission of peduncle, rapid yellowing of epidermis at maturity stage. These cantaloupensis and reticulators, which we generally both two come under Cucumis melo variety, cantaloupensis. This variety comes under the second component, and the third final component is the variation of fruit characters such as fruit length and Brix value, and epidermal basal color change at maturity stage, fruit weight, and also ring coloration. Under this variety reticulators, a part of variety cantaloupensis, these fruits have short fruit length and also have high Brix value, and these are green and monocolored epidermis. Whereas variety Saccharines and some of the varieties of Acidulas, these have long fruit length and also bicolored epidermis nature. Accessions with a good shelf life, these are generally characterized by crisp flesh, non-slippered peduncle, long development period of plant and fruit, no rapid yellowing of epidermis at maturity, and these are mostly seen in variety Saccharinus. Next slide, please. And again, shelf life was mainly divided into 4 categories according to the abscission of peduncle, firmness of flesh tissue, the yellowing of epidermis, and other changes of appearance at maturity like crisp flesh, non-slippered peduncle, long development period of plant and fruit, and no rapid yellowing of epidermis at maturity. And the best example for having more shelf life is the hammy melon, which belongs to the variety Saccharinus, and it is a morphological and geographically diverse material. It has nearly half a year shelf life, and it is when compared to other species, it is a species with having high shelf life. And we know that two cantaloupe melons, that is European cantaloupes and American cantaloupes, in both these, the fruit development and ripening undergo vigorous climatic changes as a part of ripening process, and this results in fruit softening and abscissed and senescence within a short period. Whereas for inodorous and honeydew species, they did not develop abscission layer until commercially overripe, and the potential shelf life of these inodorous and honeydew melons are nearly 4 weeks. And cassava type of inodorous, they also show very slowly. They also show very slow ripening process during softening. And next slide, sir. This is one innovation, that is MAC10. That is a new breeding line which was derived from a collection of integration lines developed from cross between cultivars belong to Cucumis mellow variety Makua and also Cucumis mellow variety Cantaloupensis of Cherentia type. This MAC10, this has a delayed ripening process and lack of abscission layer and also external aroma. The changes in ripening provides fruits which have delayed flesh softening and a higher sugar content both while during attached to a plant and also after harvesting. And also a gene, CMA-CO1 gene was also silenced from this integration line, which is used for modification of ripening process in Cantaloupensis. And in this, the delayed processing was due to the presence of two genes, that is a Mellow 3 C01239 and Mellow 03 C Mellow 3C032, which are present on chromosome number 10. And from this, they said that MAC10, this can be an interesting source of genetic variability, and this can be used to develop new cultivars with improved post-harvest shelf life. In this way, they in most some of the underexploited melons, we have useful genes which can be used for improvement of shelf life in the Cantaloupensis as well as reticulated species. We also conducted an experiment, intraspecific hybridization in muskmelon. In this also, we proved that the cross with Cantaloupensis and inodorous, we got a highest shelf life of 21 days. Thank you, ma'am. Thank you for giving this opportunity.
Thank you, Dr. Lakshmi Kalam. Any questions from the participants? Yes. The next participants, please check your time. Most of you are exceeding the time limits. Yes. The next presentation is from Dr. P. Pradeep Kumar. Are you there, sir?
Yes, madam. Just allow me to share screen.
Yes, sir.
Very good and participants. Today I am going to deliver my topic on morphological characterization of wild relatives of tomato. Tomato is one of the most important vegetable crop grown throughout the world. It is also known as a hello. Is it audible, madam?
Yes, sir. Be louder, a little bit louder.
Tomato is one of the most important vegetable crops grown throughout the world. It is also known as a protective vegetable due to its nutritional value. It protects the home from several elements. Most of the present-day hybrids and cultivars are highly susceptible to pests and diseases,
That slides
and
are
as
not
well as
moving.
poor nutritional.
Slides are not moving.
Madam, the introduction, then I will skip now. Mostly hybrids and yielding to pests and diseases, poor in nutritional and processing products. Nowadays,
చెప్పండి మేడం స్లైడ్స్ స్లైడ్స్
అయిపోయిందా సార్ మీది? అయిపోయిందా మీది? ఇంకా కరెక్షన్ ఏం లేవుగా? ఇంకేం సార్ నిన్నటి నుంచి Dr. Pradeep, please check your connection, internet connection. Dr. Pradeep. We continue with the next presentation. Miss Katta Srivandana, are you there? Katta Srivandana. Miss Sikha Manoharan. Sikha Manoharan. Are you there?
is it audible, madam?
Pradeep?
Madam. Yes, madam.
Yes. Are you comfortable?
Yes, madam. Yes, madam.
Please present. Please present.
Wild species that are more or less genetically similar to their host species not yet been domesticated. So far, globally,
Share your
they
screen.
identified 13 wild related.
Share your screen.
Just wait, madam.
Please share your screen.
See.
షేర్ చేస్తుంటే
Madam, no. Madam, no. Madam,
Yes.
no.
Yes.
Wild species that are
If you have a
genetically similar to the crop species not yet domesticated so far. So far, 13 wild relatives of tomatoes identified globally, along with the cultivated portion of tomato. Solanum pimpellifolia, Solanum chimilis, Solanum hirsutum, Solanum pennilli, Solanum cerasiformis, Solanum mirati, Solanum chis, Solanum peruvianum, Solanum galapagos, Solanum lycopersicoides. These are the cultivated portion of Solanum lycopersica the Solanum lycopersicum variety cerciforme, that is the ancestor of the cultivated tomato. These are some of the old Solanum hirsutum, Solanum pluvianum. Here, Solanum pluvianum, the ecological character is bipartite inflorescence. First of all, monopatite observed. In case of Solanum folium,
Dr. Pradeep, I think you are facing the internet connection problem.
yes, madam. Now, okay, madam.
Okay.
Hello. The cultivated portion of tomato extensively utilized in the crop improvement program. There is no scope for the further improvement of the cultivated portion. It was not provided the answer for especially in terms of biotic and abiotic resistance as well as a nutritional importance. Intervarietal and interspecific diversity almost been exhausted in the cultivated portion. Now, crop relatives often special against antibiotic and diabetic stresses, which causes the severe problems in the cultivation of the domesticated species. Some of the crop wild relatives are containing characters that are economic in commercial seed production, such as accepted stigma is mostly identified in the some of the wild relatives. For easy hybridization program, this is very, very useful. The present recent study, 17 ecological characters of the wild relatives have been determined. Among the growth habit, growth habit. Visible in if identified in stem and twig, not in fruit. Rest of other solanaceous visible fruit itself have anthocyanin content. In case of tomato, fruit itself doesn't having anthocyanin content. In wild relatives also, it will not observe that particular character. The style position was inserted in Solanum pimpernifolium and Solanum lycopersicum variety cerciforme and the Solanum. These are the two species mostly identified. The style position is inserted. Rest of other species are accepted stigma. This accepted stigma is useful for the hybrid seed production. Hybrid seed production. Now coming to ecological characters, the plant mainly observed in Solanum is the lowest. Solanum lycopersicum varieties the particular cultivated for the ancestors of the cultivated tomato is having plant height 190 centimeters. At the same time, the tendency number of cluster plant is high in the Solanum variety cerciforme. Solanum pluvianum days for storing and fruits per cluster, fruits per cluster, high in Solanum pluvianum. Then fruit weight is 4.73 grams compared to other Solanum wild relatives. Having that significantly less, even the weight of the fruit is little bit higher. Then equatorial diameter also and polar diameter also Solanum chilense having higher. Number of locules, most of the wild relatives similar locules. And pericarp thickness also Solanum lycopersicum variety cerciforme having highest. Number of seeds per fruit. Solanum chilense having highest number of seeds per fruit. The test weight also very similar. not only these wild relatives, pests and disease resistance, but also some nutritional aspects also very, very important. Solanum pimpinellifolium having the highest and total leaf chlorophyll highest in Solanum peruviana. Acid mostly identified in Solanum pimpinellifolium species. Next, total sugars highest in Solanum pimpinellifolium observed, and acidity also observed in highest in Solanum pimpinellifolium. Solanum like pimpinellifolium having a highest amount of lycopene.
Okay. So we switch on to the next presentation. Miss Katta Srivandana, are you there?
Madam,
Srivandana.
we are in remote, madam. That's why, madam.
It's okay. It's okay.
Madam, we are
Dr.
in
Pradeep.
remote area, madam. That's why, madam. We are remote area, madam.
Understand.
That's why signal is problematic.
Yeah, we understand, Dr. Pradeep.
Madam, all the wild relatives of tomato are very small fruited, but very high in appearing species. Coming to the conclusion, indeterminate growth habit was a characteristic feature of all the wild relatives. The wild species was characterized by the high fruitfulness, and fruit character can be utilized in the tomato breeding program. Solanum can be utilized in the breeding program for improving the ascorbic acid, total sugars, and lycopene content in cultivated portion. See the Solanum jointless pedicel is jointed when the fruit is harvested. Along the pedicel, it can harvest. While transporting, this pedicel is twist with another fruit. This is a drastic problematic transportation. Solanum is having the jointless pedicel. Separate the joint by harvesting. Pedicel attached to the fruit, it causes the damage other fruits while transportation. Imports the flavor during the processing. It is not suitable for the mechanical harvesting. Now, concluding all these, wild relatives mostly are undetermined growth habit, mostly fit for the protected structure. All wild species characteristic feature is the number of fruits and very high fruitfulness, and the character can be utilized.
Dr. Pradeep, it's okay. We understand your problem. It's okay. We proceed with the next presentation. Ms. Shika Manoharan, are you there? Otherwise, the oral presentations are over. Now we switch on to the poster presentation. All the participants, please restrict to your time limit. The presentation is for 3 minutes and 2 minutes is for discussion. If no further discussions are there, we switch on to the next poster presentation. The first poster presentation is from Dr. Lakshmi Devamma, Assistant Professor. Ma'am, are you there?
Yeah, madam. Madam, shall I share the poster, madam? Poster only or PPT? It's PPT.
Poster is better, ma'am. We have given the instructions in such a way.
Yeah, I'll just.
Yes, ma'am. Proceed, ma'am.
Madam, it's visible?
Yes, visible, ma'am.
Yeah. Yeah,
It
very
is
good
visible.
afternoon. Yeah, very good afternoon to one and all. The topic for my poster presentation for this national conference is character association and path analysis in vegetable amaranth. Vegetable amaranth. Coming to it's a part of the studies which I presented earlier. The associations, correlation coefficient analysis and path coefficient analysis was carried out considering the 2-season evaluation data of Kharif and summer. Coming to the brief introduction of vegetable amaranth, we know the importance of this crop, nutritional importance, as well as the breeding initiation and the breeding improvements we need to do in this crop in an attempt to quantify the variation in vegetable amaranth. The variability, diversity, and association studies were carried out. We know the importance of association because most of quantitative triads, including the triads of vegetable amaranth, they are highly quantitative and direct selection will not be effective. So in order to dissect the nature of association between yield and other associated characteristics, this analysis was carried out. That's what understanding the inter-triad correlation is essential for deciding the triad combinations, which group of triads we need to consider while selecting the genotypes. Association, in addition to path analysis. Path analysis is more accurate in dissecting the associations between yield and associated triads. So here, 85 vegetable amaranthus accessions, which were evaluated during Kharif and summer. Individually, they were analyzed for all the parameters here in this association parameters. And pooled during Kharif, both yield and nutritional triads were analyzed, and during summer, only yield triads were analyzed for associations and path effects. And pooled data was also analyzed in order to see the trend, how the trend of association. In addition, the 2 F2 populations which were studied in vegetable amaranth, in F2 population also the nature of association was analyzed. All these have been compared here. So the correlation coefficient analysis, as indicated in this table, it showed a significant association of fresh green yield, especially with fresh green yield per plant, leaf weight, leaf area, leaf length. It showed during Kharif, it showed positive association with majority of the considered yield triads. Similar association was also observed in pooled analysis of summer and Kharif. Among the nutritional triads, only calcium content showed association, only significant association with yield, which indicates that yield as well as nutritional traits in this set of germplasm can be improved. Coming to path analysis, high positive direct effect was shown by fresh green yield per plant, leaf area, and plant height on plant fresh green yield per hectare. The leaf weight, which had high association, correlation coefficients, but direct effect was found to be negative here. Direct effect was found to be negative here, which can be attributed to the association, indirect effect to other triads. These triads which showed high association and how high direct effect can be considered by selecting for yield. This is a graphical representation of the nature of association of yield attributing traits with fresh green yield in 3. First one is the summer, Kharif, and pooled data. So same trend has been observed with respect to all the traits, and this is the trend which has been observed in F2 population. F2 population, the trend with respect to leaf weight we can see here, and stem weight and the leaf to stem ratio also depicted the same pattern actually. From here, leaf weight to stem ratio, same pattern can be observed in both germplasm evaluation as well as F2 evaluation. So with this, I would like to say that this is the table depicting the nature of association of germplasm as well as the F2 populations. High direct effect is observed with respect to fresh green yield per plant as well as leaf area. But you can see here, the leaf weight has shown high. It's a negative direct effect, but the positive association here, positive association, which can be attributed to the indirect effects through leaf area and per plant yield. So I'd like to conclude that these in all the estimates, the one which have given strong association can be considered as inherent association, inherently associated with yield, which can be considered for selection of yield in all the breeding programs in different generations. Thank you, madam. Thank you.
Thank you, ma'am. Any queries from the participants? Thank you, ma'am.
Yeah, ma'am.
The next poster presentation is from Dr. Majjiga Komala. Are you there? Komala. Please present. Request from the organizing committee, you please restrict to the time limit.
Hello.
Please start your presentation.
Okay, ma'am, shall I start, ma'am?
Yes.
Yes. Shall I proceed, ma'am?
Yeah, present.
Okay. Thank you,
Proceed.
ma'am. Yeah. Okay. Thank you, ma'am. Good evening to all. This is Komla. I'm working as an assistant professor in the Department of Genetics and Plant Breeding at College of Horticulture, Chinalatrapi, Dr. YSR Horticultural University. Welcome to my poster presentation on chili crop improvement by recent molecular breeding approaches. Chili capsicum annum is one of the major commercial vegetable crops cultivated worldwide as a for fruit yield. Current research on crop improvement of chili is majorly focused on developing new molecular markers as well as their application in marker aster selection in order to develop quickly advanced chili varieties with biotic abiotic resistancy as well as with improved fruit yield and quality. In recent study, the marker aster selection was employed for interspecific integration of leaf curl virus resistancy gene. Gene for this resistance gene was incorporated introgression from hot pepper to heat tolerance bell pepper lines. Here we can see the PCR amplified begomovirus coat protein gene after inoculation with the virus, which helps in artificially screening in resistant and susceptible genotypes. Later, the resistant leaf curl virus donor parent was crossed with 6 susceptible genotypes with the desired trait of heat tolerance bell pepper lines. Then the F1 was obtained. So then with the F1 backcrossed with respective 6 susceptible genotypes. So eventually, 6 improved heat tolerance bell pepper lines were obtained with resistant to leaf curl virus disease resistance with their marker assisted selection. In addition to marker assisted selection, acquiring the knowledge on a genetic diversity of chili is paramount in developing new varieties. Therefore, in China, a recent study was focused on chili genetic diversity between 94 local land races and 84 breeding lines, with evaluating 24 qualitative traits and 13 quantitative traits with the 27 molecular markers. They found that the mean values of gene diversity index and polymorphism information content of land races were higher than breeding lines. So in conclusion, the marker assisted selection can be employed for interspecific crosses between land races and breeding lines for enable genetic background of breeding lines to develop improved chili cultivars. Thank you, ma'am, for your kind attention.
Thank you, Komala.
Okay, thank you, ma'am.
Any questions from the participants?
Hello, madam, one
If no
question,
questions?
please.
Yes, ma'am.
Madam, resistance source from hot pepper, which resistance source used, madam? Line or interspecific it is?
Source of hot pepper is yes 349 line, ma'am.
343.
Yes, ma'am.
What was the inheritance, madam? How the fruit and all inheritance? How inheritance study could you able to do?
Inheritance studies, ma'am, both qualitative and quantitative traits, ma'am.
Qualitative, madam.
Yes,
Qualitative.
yes. So mainly focused on yield and quality.
Okay. Like in F1, could you able to get, madam? No.
Yes, ma'am. F1 is there.
No, madam. Resistance. What is the inheritance of resistance, madam?
Resistance.
Yeah.
Thus, PAU SM2 has expressed a higher resistance, ma'am, among 6 genotypes.
Okay. Thank you.
Any percentage? Any percentage?
So
Heritability.
This one, ma'am,
I think ma'am
70%.
is asking.
Resistance, how it's like now they say quantitative, no, madam?
Yes,
so
ma'am.
Initially, okay, madam, thank you.
Thank you, Komala.
Okay, thank you, ma'am.
The next presentation is from Dr. V. Hairmata. Are you there? Miss Y. Shravani?
Yes, ma'am.
Yes. You start your presentation.
Madam, I am unable to share my presentation. Could ma'am?
The slide is not visible. You share your slide.
Ma'am, I'm unable to share. Could you share my poster, ma'am?
Okay, ma'am.
Ma'am, shall I start, ma'am?
You start.
Good afternoon, everyone. Myself, Vaishravani, pursuing PhD in the Department of Vegetable Science, Dr. YSR Horticulture University, Venkataramanagudam. Today, I'm here to present my poster on the topic Preserving the Past, Nourishing the Future, Utilizing the Genetic Diversity in Ethnic Vegetables. Vegetables that are commonly used in traditional dishes from specific cultural or ethnic groups is generally referred to as these ethnic vegetables. Some of the ethnic vegetables in India include brinjal, okra, bitter gourd, bottle gourd, drumstick, colocasia, ridge gourd, fenugreek, ivy gourd, and many more. India is known for its diverse cuisine, which includes Arbi Patta, Shahjahan, and many more cuisine, which incorporates a wide variety of vegetables. These nutrient-dense indigenous vegetables has a significant role in addressing malnutrition, which possess carbohydrates, proteins, and are rich in many antioxidants, phytochemicals, and other micronutrients. Globally, around 1 billion people use these wild edible vegetables daily as a source of food, as these are easily available and freely accessible from their natural habitats. Many ethnic people gain knowledge on how to gather these wild edible vegetables. These ethnic vegetables are rich source of genetic diversity due to their adaptation to local environmental conditions, cultural practices, and historical events. Hence, preserving the diversity of these ethnic vegetables is crucial for the long-term sustainability of agriculture and conservation of our cultural heritage, which can be achieved through the establishment of seed banks or gene banks and the promotion of traditional farming practices and the development of new varieties using modern breeding techniques. There are some factors that contribute to the genetic diversity of ethnic vegetables, which include seed exchange, traditional farming practices, geographical isolation, cultural practices, and human migration. Hence, it is essential to conserve these diversity in ethnic vegetables for preserving our cultural heritage, maintaining biodiversity, enhancing food security, and promoting long-term sustainable agriculture, and supporting the local economies by enhancing the demand to these local vegetables. So there are certain ways to conserve these ethnic vegetables like seed saving by the establishment of seed banks or gene banks, and promotion of traditional farming practices, and education and awareness by conducting workshops, seminars, etc., and promotion of local cuisine, and conservation of genetic resources, and research and development. So around 400 kinds of vegetable crops are thought to exist worldwide, with roughly 80 major and minor vegetable species having their origin in India. These locally consumed indigenous and minor vegetables can be produced commercially in both rural and urban settings, making them the best candidates for increasing utilization of biodiversity in horticulture. So here I would like to sum up my topic that nutrient-dense vegetables which play a significant role in human nutrition and rich in genetic diversity need to be conserved, and these genetic traits should be utilized for crop improvement, for development of new varieties and sustainable agriculture. Thank you for providing me this opportunity.
Very good, Shravani. You completed in the time.
Thank you.
The next presentation is from Miss N. Vaishnavi.
Yes, ma'am.
Are you there? Please
Yes,
start
ma'am.
your presentation.
Okay, ma'am. Ma'am, it visible, ma'am?
No. Not visible.
Ma'am, is it visible, ma'am?
Yes, now it is visible. You start.
Okay, ma'am. Good evening, everyone. I am Vaishnavi, pursuing Masters from College of Horticulture, Rajendra Nagar. Today, I am here to present my poster on genetic variability, diversity, and association studies of indeterminate tomato accessions in polyhouse, with the major advisory of Dr. S. Malesh, Srimati K. Nirosha, Dr. P. Saidaya, and Dr. N. Sivaraj, in collaboration with NBPGR Regional Research Station, Hyderabad. As we all know that tomato varieties, most of they are developed for productivity purpose, but these varieties are lacking of qualitative characters which are suitable for particular purpose. So we are in our investigation, we are majorly focused on to identify particular breeding population which are suitable for polyhouse conditions and which have maximum nutritional quality for those breeding population. And today, the main objective of this poster is to determine the nature and extent of genetic variability in tomato for qualitative traits under polyhouse condition. And we have collected the germplasm from NBPGR New Delhi. Total, we have collected 30 accessions, which are exotic collections, which are imported from Israel, which are already identified as indeterminate types and which are also suitable for polyhouse conditions. All these lines are shown under naturally ventilated polyhouse condition in College of Horticulture, Rajendra Nagar. We have recorded both qualitative characters and quantitative characters, but majorly we are focused on qualitative characters and also the characters which are suitable for polyhouse conditions. These characters we have subjected to statistical analysis. Coming to the results and discussion, here I have mentioned most major qualitative characters which are showing highest variability within the lines. And these images here we can show total 30 lines which have its own expression on number of locules and mature fruit color, seed shape, and seed color. Apart from these characters, we have also assessed some of the other qualitative characters like stem pubescence, leaf type, and leaf color, stem pigmentation. We have also assessed quantitative characters like plant height and number of primary branches, fruit yield. And from this experiment, we have concluded that all these lines showing maximum variability for all the qualitative characters which we have assessed in this experiment. And here we can conclude that most of these conferring huge scope for improvement of such qualitative characters for polyhouse cultivation. Thank you, ma'am.
Thank you, Vaishnavi. The next presentation is by Javadi Lakshmi Chandana.
Yes, ma'am.
Are you there?
Yes, ma'am.
Please present your poster. Lakshmi Chandana.
Madam,
You start, Chandana.
good afternoon, everyone. My name is Lakshmi Chandana. I am pursuing PhD first year in Department of Vegetable Science in Dr. Vaisar Horticulture University, Anantarajpeta. I am going to present my poster on tissue culture approaches in vegetable crop improvement. Tissue culture is the growing of plant organs or tissue cells in vessels using artificial media. In some cases, conventional breeding methods are supplemented with in vitro techniques to achieve an objective which is not possible through conventional breeding. In tomato and cucumber, culture techniques like anther culture, ovule culture, pollen culture are utilized for production of haploid plants that have they are homozygous lines. They have potential in vegetable breeding programs, and also various techniques in tissue culture. If species are cross incompatible, then we can take somatic cells and can be used protoplast fusion, somatic embryogenesis. If species are cross compatible, then we go for reproductive cells and used pollen culture, anther culture, and embryo culture. They are used for production of haploid plants. If reproductive barriers are present, then we follow in vitro pollination, in vitro fertilization, and embryo rescue method. For multiplication of virus-free plants, meristems are used in culturing of plants. And research work done through different tissue culture techniques are in Benki and his co-workers. They, by using meristem culture, they developed virus-free plants in garlic. Stelmach and his co-workers worked on parsnip accessions by using somatic embryogenesis. And Tiwari and his co-workers developed late blight resistance in potato by using protoplast fusion of Solanum tuberosum and Solanum cardiophyllum. And Rahman and his co-workers developed haploid plants by using microspore culture in Brassica napus. And Eboshama and his co-workers developed haploid plants by using anther culture in Santhera cultivar of potato. And Sontip and his co-workers worked on cucumber to develop haploid plants through ovary culture. Sharma and his co-workers developed interspecific hybrids in cauliflower, variety Pusa Sharad, and Ethiopian mustard, that is NPC9, by using embryo rescue method. And conclusion is that based on the objective, proper tissue culture technique is needed to be selected for crop improvement, and also production of multiplication of virus-free planting material, and also production of double haploid plants. That's all. Madam.
There's any queries from the participants? Yes. Thank you, Chandana. The next presentation is from Mr. Durga Hemant Kumar. Are you there? Durga Hemant Kumar. Mr. B. Srinivaslu. Mr. B. Srinivaslu. Dr. A. Radhika Ramya.
Yes, ma'am. Madam, please share my poster.
Yes, ma'am. Please start your presentation now.
Okay, ma'am. Good evening, all. Myself, Radhika Ramya. My topic is on the breeding strategies for chili leaf cull virus resistance. As we know, chili is one of the major vegetable and spice crop grown throughout the world, wherein India is one of the main contributor in terms of chili production and export. But chili is more prone to diseases and pests, where chili leaf cull viral disease is one of the major constraints, which may cause severe economic losses even up to 100%. And this disease is caused by the virus, belongs to genus Begomovirus of the family Geminiviridae, and it includes about 445 species. And this disease is exclusively transmitted by whitefly. And for the first time in India, chili leaf cull disease was observed during 1940s by Vasudeva. And this disease is mostly distributed across the equatorial regions of the Australia, Asia, Africa, Europe, and America. And the erratic climatic conditions like sudden rise in temperature, rainfall, relative humidity, intensification of the cropping systems and presence of alternate hosts favor chili leaf curl viral disease incidence. The best approach for management of the chili leaf curl viral disease is improvement of chili leaf curl disease resistance, which can be achieved by various methods like phenotyping and selection, marker assisted selection, modern biotechnological approaches like expression profiling, high throughput sequencing, RNA interference, and genome editing methods like CRISPR-Cas. The major objective of this study is to identify leaf curl virus resistant sources and develop leaf curl virus resistant and high yielding varieties. Here in this study, we have screened 76 germplasm lines that were collected over the years, where the source of inoculum is naturally existing strains in the locality. Here we have measured symptom severity based on the disease scale given by Kumar et al. In 2019 at 30, 60, and 90 days after transplanting. And as part of chili leaf curl viral disease resistance program, three varieties, LCA 657, LCA 680, and LCA 684 were approved by SVRC for release in the year 2022 from Dr. YSR Horticulture University. And here in this study, all the germplasm lines recorded 77 to 100% of disease risk index after flowering, and none of the germplasm lines were found to be immune or resistant. So this study inferred that the major limitation in chili leaf curl disease resistance is a lack of sufficient resistant germplasm and disease resistance breakdown. So there is a need to standardize robust screening techniques for evaluation of the resistant sources and inheritance patterns, and also use of advanced molecular breeding tools and coordinated effort from entomologists, pathologists, and breeders is required. As the major constraint is resistance breakdown, continuous resistance breeding is required. Thank you, ma'am.
Thank you, Dr. Radhika Ramya.
Thank you.
Any questions from the participants? The next is Miss Aroshika Swain.
Yes, ma'am.
Yeah, please present. Are you sharing or you want us to share?
Yes, ma'am, I'm sharing.
Okay.
Ma'am, my screen is visible. Hello, ma'am.
It's not visible. It's not visible. Not at Aroshika.
Ma'am, it's visible.
Not at Ma.
Ma'am, can you share my screen?
Yes, please. About you. It's about now.
Ma'am, can I start?
Yes, please, Aroshika. Yes, start.
I'm Aroshika Swain, PhD research scholar from the Department of Vegetable Science from Odisha University of Agriculture and Technology.
Yes, please.
Summer squash, botanically known as Cucurbita pepo, having the chromosome number 2n equal to 40, belongs to family Cucurbitaceae. It has high medicinal and nutritive value as compared to other crops. Although the agroclimatic condition of the Odisha is suitable for the cultivation of summer squash, but very less research work has been carried out till date. Summer squash is mostly popular as well as accepted in northern India condition, but it is so the experiment is conducted. So the experiment is conducted to find out the best cultivar for the southern Odisha region. The experiment was conducted at Horticulture Research Farm Rana Devi at Odisha University at Centurion University of Technology and Management, Parla Khemundi. We followed the randomized block design having 3 replication and 16 treatments. The phenotypic coefficient of variation was higher in fruit yield per plot, followed by fruit yield per plant. The traits like node at which first female flower appears, fruit length, fruit girth, number of fruit per plant, number of female flower and male flowers, number of harvest, plant height, average fruit weight exhibited moderate value, and the characters like the days to flash flowering, day to 50% flowering shows the lower value. High heritability as well as high genetic advance was shown for the node at which first female flower appears, plant height, fruit length, fruit girth, average fruit weight, nodes of fruit, number of fruit per plant, number of female flower, number of male flower, fruit yield per plant, and fruit yield per plot. At the end, we conclude that high magnitude of phenotypic and genotypic variation was found in the phenotypic variance was greater than the genotypic variance. Heritability is due to the additive gene action, and the selection is effective for all the trade towards the improvement of the fruit yield in summer squash. Thank you, ma'am.
Thank you, Ms. Arushika. The next is from Ms. Jyoti M. Are you there?
Yes, ma'am.
Jyoti?
Yes, ma'am.
Please present your poster.
Ma'am, is it visible?
Yes, it is visible. You start your explanation.
Good afternoon, everyone. I am Dr. Jyoti. I have completed my doctoral degree from VNMKV Parbhani under the guidance of Professor Dr. T.B. Tambe sir. This is my PhD research work. Response of selected varieties of brinjal varieties grafted on solar and torum for salt stress is done. It is done with the collaboration of National Higher Education Project AFSRDA VNMKV Parbhani. Hello.
Jyoti,
I'm audible.
Be a little bit louder. Yeah. Be louder.
As we know, salinity is a major problem among abiotic stress. It affecting the world vegetable production. This salinity affected soils are increasing drastically due to varied abnormal environmental and defective agronomic practices. To overcome these problems, we have some strategies like agronomic approach, modern breeding, and biotechnological approach. But all these are having the limited success because salt tolerance is a complex quantitative character controlled by the many genes. So there is one method. It is a grafting. Grafting nothing but the joining of cyan and rootstock of two different genotypes with the desired traits. It is one of the easy and alternative way to breeding and biotechnological approaches to the salt tolerance. With this background, we have formulated these objectives. Those are to assess the compatibility and salt tolerance limit and response of rootstock for growth, yield, quality, physiological and physiochemical attributes, and quantification of EVI and NDVI with smart digital cameras, and also to compare manual and robotic grafting in brinjal. To achieve these objectives, we used different materials and methods. The seeds of Solanum torvum used as a rootstock, and these commercial brinjal varieties, the commercial brinjal varieties Pule, Arjun, Pule, Harit, Krishna, Manjarigota used as a science. These science grafted on Solanum torvum by adopting the cleft method. After completion of healing and hardening process, we have used these grafts for conducting the salt stress experiments with different salinity levels. After inducing this salt stress, we have recorded different growth, yield, quality, physiological and physiochemical parameters. Further, we have also recorded some vegetable indices like EVI, NDVI with the help of advanced smart digital cameras like spectroradiometer and multispectral cameras, which were used first time in India for vegetable crops. The other independent experiment was also conducted to compare manual and semi-automatic robotic grafting, which is imported from South Korea. In this experiment, we assessed different grafting and early growth parameters, and whatever the data collected from the collected was subjected to the statistical analysis to draw the valid conclusions. Hello. Coming to the results and discussion.
Yes,
coming to the results.
Conclude, Ms. Jyoti.
Among the different varieties grafted on Solanum torvum, Pule Harith was shown significantly superior performance for most of the characters, including the yield. Similarly, in vegetation indices, NDVI and EVI also shown maximum performance with the Pule Harith at 3 and 4, 5 decisiman. Coming to the another experiment where we have compared manual and semi-automatic robotic grafting method, in which we found that reduction in the time and more grafting success as well as the good sealing vigor in case of semi-automatic robotic grafting. Coming to the overall conclusion, all the graft combinations were performed better even at a high salt concentration by using the Solanum torvum as a rootstock. But Pule Harith combination was reported significantly better for majority of the parameters, including the yield. Coming to the vegetation indices, the data captured with the advanced digital cameras was
Jyoti, please conclude.
We have standardized and found that this semi-automatic grafting machine was best as compared with the manual grafting, which is now using for supplying the grafts to the farmers commercially at VNMKV per month. Thank you.
Very good, ma'am. Thank you. So, I once again call the missed out participants. Dr. Virupakshi Hairmata for poster presentation. Mr. B. Srinivasulu. Mr. Durga Hemant Kumar. Yes, please. Are you there?
Madam, second caller. Second call,
Yes,
third call.
So with this, the listed out participants presentation is over. A formal vote of thanks from the moderator, Dr. M. Jayaprada.
Then can continue. Yes.
Yes. I express my heartfelt thanks to all the participants, the invited speakers, the chairman and co-chairman of the theme, the conservation, diversity, genetic diversity, and crop improvement of ethnic vegetables, the rapporteurs, and the students who helped us, the supporters, the IT staff here in the college for their support to make this session a very successful one. I would like to thank the chairman of the session, Dr. B. Srinivasalu, Registrar, Dr. YSR Horticulture University, Co-Chairman, Dr. M. Madhavi, Associate Dean from College of Horticulture, Venkatramana Gudem. Our rapporteurs, Dr. B. Harivara Prasad, Associate Professor, Dr. G. Lakshmi Devi, Assistant Professor, and the PG and PhD students, Miss Bhargavi, Miss Himabindu, Miss Reshma, and the Code Bhargavi, and all the supporting staff. My sincere thanks for making this team very successful. And my heartfelt thanks to all the participants for your contributions to the session and the thought-provoking interactions that was made in this session. The research findings and the conclusions, the important points of the session will be discussed in the valedictory program. Please join the valedictory program tomorrow by 12 o'clock. The Zoom link will be provided in the group as well as in the program schedule. Thank you. Now I invite the chairman of this session to talk few words about this. Sir, welcome you, sir.
Thank you, Dr. Jayaprada. I think my compliments to all the speakers for their nice presentation on various topics they have given during this first session. I think all the participants have done exceedingly well with their nice presentations. I think their presentations have enriched the knowledge of all the participants on this ethnic vegetable crops. On behalf of Honorable Vice Chancellor, Dr. YSR Horticulture University, and all the university officers and on my own behalf, I extend my heartfelt thanks to one and all for their nice presentation in the technical session one. Thank you very much.
Madam, session closed. I think the session closed this. అది స్టాప్ చేయాలి కదా అమ్మాయి స్టాప్ చేయకూడదు.
With this, the session is closed.
అమ్మాయి క్లోజ్ చేయమన్నా జ్యోతి అమ్మాయి స్టాప్ చేయమన్నా మనం ఒకసారి ఎండ్ అయ్యి మళ్ళీ అవ్వాలన్నా లేదు ఎండ్ అవుద్దా?
Thank you.
ఎండ్ అవంటే అవ్వద్దు మేడం, ఎండ్ అవ్వద్దు.
Miss Arushika, please close your sharing. Miss Jyoti. Thank you. Thank you, one and all. Karnasri madam already join అయి ఉన్నారు ఇక్కడ.
డైరెక్ట్ షేర్ చేస్తాను
మేడం ఇక్కడ జాయిన్ అయి ఉన్నారు ఈ లింక్ తో.
అదే ఉంటాను.
ఓకే. గుడ్ ఈవినింగ్ మ్యామ్. స్టార్ట్ చేసుకోండి.
మనం బ్రేక్ ఉందా? బ్రేక్ లేదు. చేంజ్ రాసిన ఒకసారి ఒక 5 minutes ఇదే ఉంది. పవన్ Good evening, all the participants. So welcome to the technical session 5. I hope all the participants are joined. So this technical session 5 with the theme recent advances in horticulture crops. So myself, Dr. P. Shamsundar Reddy, Associate Professor, College of Horticulture, Anantarajpeta. So I'm the moderator for this session. And along with, so for this session, so we have a chairman and co-chairman. Chairman is Dr. A.S. Padmavathamma, Dean of Horticulture, Dr. YSR Horticulture University, Venkatramanagodam. And co-chairman is Dr. S.S. Vijay Padma, Associate Dean, College of Horticulture, Chinala. So we have 3 rapporteurs from our college. Dr. T. Vinod Kumar, Assistant Professor, Horticulture from our College of Horticulture, Anantarajpet. Dr. G. Chandramohan Reddy, Assistant Professor, Horticulture, College of Horticulture, Yarpet. And Dr. P. Avani, Assistant Professor, Horticulture, College of Horticulture, Anantarajpet. So we have some supporting PG student staff also with us. So I'm going to introduce the chairman of this session, and I'm going to read the biodata of our chairman, Dr. A.S. Padmavathamma garu. Yes. Dr. A.S. Padmavathamma, Dean of Horticulture, presently in Dr. YSR Horticulture University. She did her MSc and PhD, and with a 36 years of service, with 25 years of research, 8 years of teaching, and she is an administrative job for last 3 years. And she has a popular articles around 45, research articles and 36. She received the ICR Senior Research Fellowship to pursue her PhD and Junior Research Fellowship for MSc. Received University Gold Medal during the PhD studies for highest OGPA from University of Agricultural Sciences, Dharwad, Karnataka. She is involved in activities teaching in from 2011 and served as a professor, associate dean, and then presently she is the university level officer at Dean of Horticulture at College of, at Dr. YSR Horticulture University. She is recognized as a member and chairman of UG and PG Faculty Board of Dr. YSRHU, and presently member of Academic Council and member of Board of Management, Dr. YSRHU. So she is involved in research activities pertaining to the crops like coconut, citrus, some vegetables, fruits, post-harvest technology of horticultural crops. So she is also involved in delivering the TV programs, around 25 radio programs also she is present. She is also nominated as observer for conducting All India Pre-Medical and Dental Tests, then NEET. So worked as Associate Dean, College of Horticulture, Rajendra Nagar, Hyderabad for 1 year, and as a Control of Examination, Dr. YSRHU for 2 years, and presently Dean of Horticulture. Along with the Dean of Horticulture, she is also acting as a nodal officer for ICR, as a then nominated as a member of Assistant Professor Recruitment Committee, as a Dean of Horticulture, involved in accreditation of university for, and 4 constituent colleges of Dr. YSRHU got accredited with the A grade by ICR for the period of 21 and 26. So with this introduction, I'm welcoming the chairman of today's session, Dr. A.S. Padmavathamma garu. And we have another co-chairman, Dr. S.S. Vijay Padma garu, Associate Dean, College of Horticulture, Chinala. She did her MSc from Agriculture College, Tirupati, PhD from College of Agriculture, Rajendra Nagar, Hyderabad. She has worked for 8.5 years in research and 15.5 years in teaching, with a total service of 24 years. She worked as a horticulture at Horticulture Station, Pandirmamidi, then Cashew Research Station, Palmyra, rubber, minor fruit products, medicinal plants, and minor fruit crop research. And she has worked in associate professor and professor cadres at various colleges, worked in College of Agriculture, Rajendra Nagar, College of Horticulture, Mojerla, College of Horticulture, Rajendra Nagar, and College of Horticulture, Parvatipur. Presently, she is the Associate Dean of College of Horticulture, Chinala. She has guided 12 PG and PhD students in vegetable science, plantations, spice, medicinal and aromatic crops. And she's the member for life member for 5 national journals, around 25 research publications to her credit. Worked as HOD for Department of Plantation and Spices, and attended 4 training programs on developing curriculum and management development at NAM, Hyderabad. And she also selection committee member for technical staff recruitment at CSIR, and presently she is the member board of management, Dr. YSRHU. So with this biodatas and introductions, I'm also inviting and welcoming Dr. S.S. Vijay Padmagar as a co-chairman for this session. So along with this, so we have 3 rapporteurs, and so the session will starts with 2 invited lectures. So we have one invitation lecture from Dr. E. Karunasri Garu, Director of Extension, Dr. YSR Horticulture University, and we have another invited lecture for today's session is Dr. Padma Nimmakayala is a professor plant breeding genetics from West Virginia State University. Perhaps she will join tomorrow, and we'll have one invited lecture for today. So after the invitation lecture, so I will read out the instructions for the oral presentations and poster presentations. Now I welcome today's first invited lecture, Dr. E. Karunasri Garu, Director of Extension, Dr. YSRHU. So he is presenting her topic on extension strategies for promoting the cultivation of ethnic vegetables to inculcate diversity for sustainable agriculture. Madam, please, you can start your presentation, madam. I welcome Dr. Karunasri Garu.
Thank you, Samsung. Let me share my screen.
Yes, ma'am.
So is it visible?
Yes, madam. Visible and audible.
Yeah, thank you very much. So respected chairperson of today's theme 5.
Sound.
Today's National Conference on Ethnic Vegetables, prestigiously organized by Dr. YSR Horticulture University, College of Horticulture, Anantaraj Peta. And I'm very happy to be part of this, presenting the few of extension strategies for promoting the cultivation of ethnic vegetables to inculcate the diversity for sustainable agriculture. Being closely worked for the past 10 years in the agency areas of coastal districts, especially seeing the food and the agricultural and the cultural habits of tribal farmers, I am presenting my experiences and some of the strategies for strengthening of this ethnic vegetable cultivation. So we know that since morning we are all hearing about the speciality of these ethnic vegetables, in how they are special and a rich array of crops that have the cultural significance and the culinary diversity, we can say, in agency areas and the remote rural areas. Often the farmers feel that the cultivation of these ethnic vegetables as a risk mitigation option. Usually in hot summer or the diverse weather conditions prevailing in the poor resource conditions pertaining to the agriculture, like the soil or the water, the other resources, they are considered as a very risk mitigant options for the of these ethnic vegetables. The concept of these vegetables is explored due to the rising importance in the context of the present context of increasing the consumer preference, we can say. The promotion of ethnic vegetables is an important aspect of sustainable agriculture practices. When we see about the previous points, what I have said regarding the cultivation of these vegetables in remote areas, now the promotion of these ethnic vegetables has an important aspect of sustainable agriculture practices. That is especially the cultivation of the crops like that are more preferable to the consumer taste in present day situation, I can say. Extension strategies, we know that they are very much required, though which are very important. Ethnic vegetables be communicated with the different stakeholders and different areas of cultivation and different methods of cultivation, we can say. We know the significance of these ethnic vegetables. The wide range of crops that are deeply rooted in the culture and tradition of the culinary practices. We just know if we see the situation of these, the marketing strategies, marketing avenues that are available to these ethnic vegetables cultivated by the tribal agency areas or the remote rural areas, they are usually marketed through the local shandies due to the quantity that is produced as well as the perishability and the not available to the regular markets. The Girijan cooperative societies, which provide marketing to about 49 minor non-timber forest produce, but in these the vegetables are not included. So that is the significance how now in recent years the vegetable ethnic vegetables, they are gaining more importance due to their very peculiar methods of preparations and the use in different dishes and the culinary preparations. Apart from this distinctive taste, the ethnic vegetables, we know the nutritional benefits and the abundant, dense nutrients, we can say the minerals, vitamins, and the antioxidants that can be added by these ethnic vegetables. So, moreover, the cultivation of these ethnic vegetables can mitigate the risk of farmers by diversifying the crop portfolio, providing the food and nutrition security to resolve the poor and adverse weather conditions, and also dependency on the conventional foods, we can say. So we know the most of the important ethnic vegetables grown across the world, as well as in India also. We know some of the bitter gourd varieties, the taro or the tuber crops, the drumstick, the traditional drumstick varieties, the Indian eggplant, we can say that even we have seen some of the specific diversity in brinjal, especially in tribal areas, where they prefer their varieties and the taste is often very delicious, and their cultivation practices are different, as well as the pest and disease resistance to these type of crops is also well noticed. So these are some of the Indian perspective. We see some of the ethnic vegetables, the gourds, the tuber crops, the drumstick, and the vegetables, snake gourd, bottle gourd. These are all some of the ethnic varieties that are grown by the. We know, I just wanted to throw some light on the delicious food items that are becoming popular in today's YouTubers or maybe the online platforms. That is the preparation of this ice apple bhaji, that is the tati munjalu, we call it as, or the garika, we know it as a making the pickle or the chutney with the garika, or the bamboo shoot pickle, or we know that the brinjal speciality mulla, we make it as a pachipulsu in and we use as an, and again this ramamulaga, we know it is a cherry tomato, we call it as, it is a rasam, which has a medicinal value when the people suffering from fevers and the convalescence periods. Then the nalleru is another thing we use as a pickle. So these are all gaining importance in present day situation, and the many of times now the present day consumers are daily in search of these kind of culinary preparations by using this type of ethnic vegetables. And now coming to the extension strategies, we can say for promoting these important ethnic vegetables, we know there are the extension system which is striving hard for the past more than 50 years to inculcate the sustainable production, protection, and the processing technologies in terms of many field as well as the horticultural crops. It is the same scenario we can say for the ethnic vegetables also, but here we have to just link that the production technologies required for the ethnic vegetables, the seed collection, the preservation of the seed, the mainly the method of cultivation, the storage, the processing, the transportation, and the marketing. These are all different, and where different kind of strategies has to be evolved for promoting these ethnic vegetables, we can say. Here I have given a 7-point formula for promoting these kind of ethnic vegetables in remote areas, and linking these important ethnic vegetables through a regular marketing system to the consumers who are far away from these remote areas where the ethnic vegetables are being produced. So coming to the first strategy, I can say the training and capacity building programs for the farmers. We know always we do conduct so many training programs, but the trainings we are proposed, we have they really need some kind of skill improvement from the trainer point of view also. That is, who have trained the cultivation. Can I continue?
Mute చేయలేదు మేడం చేసేది
Okay. Can I continue, ma'am? Okay. So the trainer has to
yes.
Yeah, thank you. The trainer has to really know about the importance of these cultivation practices of these ethnic vegetables, we can say. The extension agents has to design the training courses, not only the designing, but the collection of seed, the processing, the nursery management, and pest and disease management. This is a specialty kind of capacity building has to be given to the trainer themselves before taking up such kind of training and capacity building programs for promoting the cultivation of ethnic vegetables. The second, these are some of the skill training programs we have conducted in convergence with one NGO who is now a successful FPO running in West Godavari district dealing with the specialty vegetables, that is with the support of the NABARD. So then conducting the farmers field schools or the Totabadi programs and the frontline demonstrations. We know the cultivation of, usually we conduct the frontline demonstrations to showcase the research proven technologies to the microclimate of the farmer situation. When we see the ethnic vegetables in the context of ethnic vegetable cultivation, we know the requirements, the land preparation, because mostly they are cultivated interior, undulating slopes will be there, and the less kind of irrigation will be there. There, by conducting this field, the farmers field schools or Totabadi programs throughout the crop period, we can say from the sowing to the harvest, we can regularly provide the technical support by way of providing critical inputs as well as the technical information required for cultivation of such ethnic vegetables. That is through farmers field schools or the Totabadi programs or the frontline demonstrations. This is one kind of such programs we have initiated in West Godavari for cultivation of some of the vegetables, the local varieties of vegetables and the brinjal. What I was saying that some of the Dommeru local or the Jatlu, the typical brinjal variety grown in tribal areas of West Godavari district. Then coming to the awareness campaigns for the consumers. Here we know that as I have already shown about some of the importance that is being created for these kinds of ethnic vegetables in present day situation, we have to conduct some awareness campaigns for the consumers by way of organizing exhibitions of these such kind of ethnic vegetables during the seasons, and also we have to explore the linking these ethnic vegetable producers to the consumers by way of creating some bridge, like maybe the NGOs or maybe the young. Now the team who are ready to market create online platform for marketing of these kind of ethnic vegetables. Then collaborating with the retailers and the food service providers. We know nowadays the food service providers, we have every Raitu Kuragayala Radam, we can say some of the novel programs, they are funded by different organizations like NABARD, maybe the other sources also to the NGOs, to create market to the fresh vegetables by way of cold operated vans, refrigerated vans, we can say. This is the kind of linkage that we can create to the producers to the final consumers. Then the digital marketing and the online platforms, as I already said, this is the era of digital connectivity. We are getting even the fresh and the fruits and the vegetables also through online marketing. And here I can say some of the ethnic vegetables which have a good shelf life, like the black turmeric, which is being cultivated as a medicinal properties, which is having anti-cancerian properties, the white turmeric, even the ants, or maybe the other type of herbs which are dried and powdered, even the moringa leaf which is dried and powdered and consumed in a large way by way of taking tea, moringa tea or moringa rasam. These have a great online platforms for creating market to the these type of ethnic vegetables being grown in remote areas with the minimal processing. Then coming to the collaboration with the food processing industries, here we have we can intervene with the small kind of processing equipment like maybe the sorting of these vegetables, maybe the peeling and the slicing, dehydrating and pulverizing to make it into a consumer preferable product. This way, the collaboration with the food processing industries or maybe the establishing small scale processing units at the village level itself can promote such kind of marketing facilities to these ethnic vegetables. Then finally, coming to the formation of FPOs, the central and the state government are now focusing on the promotion of farmers producer organizations. Not only through the regular field or horticultural crops, but also to these ethnic, the interior tribal or the remote rural farmers also by way of forming the farmers producer organizations who are cultivating these ethnic vegetables. We can promote farmers producers organization. This is a small success story I just wanted to mention here. The SAD, Society for Agriculture and Rural Development in West Godavari district, it started in 2013 by promoting B2C marketing, that is started with connecting the agent between the consumer and the farmer and connected about 300 consumers to farmers interest groups. This started with the collection of the vegetables that are grown in the organically grown and the remote, the ethnic vegetables and the specialty vegetables that are preferred by the consumers, and they have linked to the urban areas by way of promoting the regular, by way of providing vehicles for regular marketing of these products. Every day the vehicle will go to the urban areas like flats, apartments and where the gated communities to market these kind of products. Now they have reached to an extent that they are now dealing with 21 mandal level FPOs for collection of all kinds of agriculture as well as the horticulture products. This is, and further the women of these FPOs, the women members of these FPOs are being trained in value addition of these kind of vegetables and preparation of various products. This is another success story by way of FPO Adivasi Cashew Farmers Producers Organization Jilugumilli, which received a YSR Lifetime Achievement Award during the AP Formation Day on 1st November 2022 for promoting the marketing of the cashew directly by collecting from the tribal farmers, and about 15 tons of cashew has been marketed. And I'm happy to share that this year they are into the marketing of this specialty vegetables, that is especially the chili, the local varieties that are mostly preferred chili varieties grown in Jangareddygudem area. These FPO is looking into the marketing of these kind of collection and marketing of this kind of chili as well as the chili powder also. So we know the sustainability, we know the ethnic vegetables by way of preservation of biodiversity, the climate resilience, reduced carbon footprint, water conservation, cultural heritage preservation, nutritional benefits, empowering the economic empowerment, community engagement, and food sovereignty. With all these, we can definitely say that the cultivation of promoting the cultivation aspects and the marketing channels for these ethnic vegetables definitely will have sustainability. And some few slogans I just wanted to give. If we want to promote the ethnic vegetables, these are the 7 slogans I have given, and our plate should be always, we have to concentrate on not the quantity we take, but the nutrition per plate is the present day scenario, and how we take what little we take, but it should be colorful, and all the colors should be added to our daily meal. This is the only possible by involving or including the some of the ethnic vegetables into the regular diet of the our regular diet. With these few words, I thank the organizers for giving me this opportunity to put forth some of the extension strategies for promoting the ethnic vegetables in tribal and rural areas. as a diversity as well as the sustainability. Thank you very much.
Thank you, Dr. Karuna, for elaborative information on the strategies for popularization of ethnic vegetables through different extension strategies. Thank you very much. And the next lead lecture, it will be given tomorrow because of the time problem, because she doesn't want to give it early in the morning. Tomorrow, it is evening for them. So tomorrow, recent advance in major cucurbits by Dr. Padma Nimakaila, it will be given in tomorrow morning, Indian time. Thank you. And I welcome all the presenters for this oral presentation for this session, technical session 5, recent advances in horticulture crops. You all must be knowing that there are, of course, this session is little out of box of the conference, but still these recent advances of different horticulture crops help in adopting the same thing in the ethnic vegetables also, thinking positively that we can popularize in a faster way these ethnic vegetables in the coming days. And this horticulture sector is moving fast pace, owing to immense potential for improved nutrition and well-being, raising from income generation, employment opportunities, and earning foreign exchange. And some of the recent technologies, such as recent development, production of seed and planting material, urban and peri-urban horticulture, horticulture-based farming systems, management of biotic and abiotic stresses, climate-smart horticulture, horticulture for food, pharmaceuticals, and cosmetic industry, new initiatives and developing for minimizing post-harvest losses, artificial intelligence in horticulture are some of the things considered for advancement of horticulture industry. So for the last few years, horticulture has made remarkable progress in vegetables, especially vegetables and flowers, through half-season vegetable production and through protected cultivation also. So there has been a tremendous increase, tremendous success in large-scale production of different vegetables, both in open field and also in protected conditions. So horticulture sector has immense potential for generating employment in cultivation and by developing the horticulture-based agro-processing units. So this is about the brief introduction about this session 5, the recent advances. Now we'll switch over to the oral presentations. There are totally 7 oral presentations and 16 poster presentations. The first one is impact of integrated nutrient management on floral parameters of pomegranate by Ms. Santosh Kumari, Department of Horticulture, College of Horticulture, Maharana Pratap College, Horticulture University, Karnal, Haryana. So, yeah, actually the time given for this presentation is only 5 minutes. After that, presentation is 3 minutes and discussion is 2 minutes. So please maintain the time because there are prizes for the best presentation. Even if you give best presentation, if you exceed the time, you will not be considered. So keeping this in view, you have to precisely present the topic. And now I request Santosh Kumari to give her presentation.
Thank you, ma'am. Good evening. Good evening, ma'am. Topic of my presentation is impact of integrated nutrient management on floral parameter of pomegranate. Pomegranate is a member of the monogeneric Punicaceae family and native of Iran. Total area under pomegranate in India is 2.88 lakh hectare and total production is 32.71 lakh ton with a productivity of 11.40 ton per hectare. Pomegranate production is very low in Haryana with an area of just 0.04 thousand hectare. Bagwa, Dolka, Kabul, Alandi, G137, Ganesh, Kandhari, Mridula, Jyoti are important cultivar grown in India. Edible portion of pomegranate is rich in sugar, ascorbic acid, pantothenic folate, vitamin A and vitamin A, E, K. Pomegranate are hardy fruit plant that can grow successfully in soil that are low in fertility. Application of manure and fertilizer greatly increase its productivity. Consequently, an integrated nutrient supply system improves soil fertility and nutrient availability to a level needed to sustain productivity. Nowadays, consumer is more conscious about health and ready to pay more for quality fruit. Therefore, the interest of grower in production of high quality fruit is increasing. Hence, the present study is focused and planned with the objective to evaluate the impact of integrated nutrient management on floral parameters of pomegranate. Materials and methods. Present study was carried out on the experimental orchards of Department of Horticulture CCS HAU Hisar during 2021 and 22. Days to flowering. Days to flowering is calculated by the first appearance of flower on any branch of a flower was considered as the date of start of flowering. Flowering duration is calculated the number of days taken from the date of first flower opening to the last flower opening. Number of flowers per shoot. Number of flowers per shoot is calculated. Number of flower is calculated on the 3 tag branches were counted, then average taken. Percentage of male flower hermaphrodite intermediate flower was counted. 5 flower taken from each direction and center of tree. These are the flower development stage of pomegranate. And there are 3 types of flowers in pomegranate. First one is hermaphrodite, second is male, and third is intermediate flower. In hermaphrodite flower, male and female flowers are both well developed, and in male flowers, female part is absent, and in intermediate flower, disshaped or rudimentary female part is present. Effect of different fertilizer on flowering, on days to flowering, flowering duration, and number of flowers per shoot. There were 22 treatments, and there were 22 treatments. Treatment 21, that is RDF 100% plus FYM plus Azotobacter plus PSB is best treatment because of biofertilizers application and FYM applications. And days to flowering, maximum days to flowering taken in RDF taken in treatment T21, that is 135 days, and minimum in control. Treatment T13 and T20 was at par with treatment T21. And flowering duration, maximum flowering duration is observed in treatment T21 and minimum in control, and treatment 13, 14 or 16, 17, 18, 19 was at par with treatment T21. And number of flowers per shoot is maximum observed in treatment 21 and minimum in control, that is 51 flowers per shoot, and treatment 14 was followed to treatment T21. And effect of different fertilizer on male flower, hermaphrodite flower, and intermediate flower. Maximum male flower is observed in treatment T21, that is 41 flower, and minimum in control treatment, and treatment T14 was followed with treatment T21. And maximum hermaphrodite flower was observed in treatment T21 and minimum in control, and T14 treatment was at par with treatment T21. And intermediate flower is observed minimum in best treatment T3.29% and maximum in control, and T14 was followed. T14 was followed to treatment T21. Conclusion. Days to flowering, flowering duration, number of flowers per shoot, male flower, intermediate flower, hermaphrodite flower were found to be significantly enhanced by soil application of RDF 100% plus FYM plus Azotobacter plus PSB. However, trees supplied with 75% RDF, FYM plus Azotobacter plus PSB were found to be statistically at par with apex treatment for all the parameters. Thank you.
Thank you, Santosh Kumari. I have a question. How did you calculate days to flowering in pomegranate?
Days to flowering, ma'am. Mainly in Haryana, flowering starts from March, and Mrig Bahar season, only flowering occurs in Haryana, not a well done fruiting. So then I take October, I take from October, November, December, January, February.
No, you have given it as 110 days and 120 days. From which date you have calculated? Which time you have calculated the days to flowering?
Last of
Annuals you will calculate from the seeding or planting. But what about pomegranate? How did you calculate days to flowering?
days to flowering before dormancy mainly start from November.
Okay. Okay. Okay, thank you.
Thank you, ma'am.
So, any more questions? Thank you. Next presentation is quality and sensory evaluation of sweet orange based RTS blends with carrot and beetroot juice by Ms. G. Divyashri, College of Horticulture, Anantarajpet. Divyashri?
Yes, ma'am.
Are you ready?
Yes, ma'am.
Start it.
Ma'am, slides. Ma'am, slides not visible.
Right, sharing మనం చేస్తాం.
Okay. Sharing will be done from our side.
Good evening to everyone. Myself, Divyashri. Oral presentation on quality and sensory evaluation of sweet orange based RTS blends with carrot and beetroot juice. Coming to introduction, vegetables are the important supplement to the human diet. India is the second largest vegetable next to the China. But huge amounts of the food are lost every year worldwide due to ineffective post-harvest management practices. So low-cost, underutilized vegetable processing and value addition is very much important to minimize huge post-harvest losses. Ma'am, please, not moving slides. Introduction.
Slides are not moving, please. And
Yes,
don't give
ma'am.
too much introduction about vegetables. Directly you go for based on the title of the project,
Okay.
title of the presentation.
Presently, value addition in vegetable sector is 2.2%. So, for handling of effective vegetables, to produce cost-effective and value-added processed products, carrot and beetroots are the very rich in nutrients, minerals, and color flavonoids. So, these are very rich in beta carotene. It is precursor to vitamin A and improves the eyesight. By both carrot and beetroot juices best enjoyed with the fresh, but it can be lost for up to 3 days in the fridge. So it is processed and make it into value added product. We can improve the shelf life and health benefits of the product. So food processing industry, it is a large growth in RTS beverages. The main objective of this work is to develop the good color, flavor, and acceptable product of the acceptable product. For this work, this work is carried out at the College of Horticulture, Anantarajpet, in the year 2018. Mainly for this work, we used sweet orange fruits, beetroot, and carrot for the preparation of the juice preparation. And for the syrup preparation, good grade sugar is used, and for sodium benzoate is used for the preservative. These are the materials and equipment. Juicer, crown cutting machine, and glass bottles are used. Treatment details. Work is done in design factorial CRD, and it is 3 replications and 10 treatments. In this, 10% sugar and 15% sugar used, and 2% beetroot and 5% beetroot, 2% carrot and 5% carrot is used. These are the treatment details. 10 treatments are done. This is the experimental setup of sweet orange RTS beverage blended with beetroot and carrot. Preparation of this juice is extraction of juice from sweet orange and the carrot beetroot. So the juice is straining the juice and blending as per the treatments. Preparation of the sugar syrup separately, and it is blended with juice blends to get RTS blends as per the treatments. Mixed the sugar syrup and fruit juice as per the treatments, and sodium benzoate is used for preservative, that is used 0.1%. This RTS is filled in sterilized glass bottles. Later, capping the bottles and heat processing the bottles at 65 degrees Celsius for 30 minutes. And these are cooled and stored at 7 degrees Celsius. Bottles are stored at 7 degrees Celsius. Coming to experimental results, treatment 10 got a high score, that is 8.7 in mainly color, taste, flavor. In all the aspect, treatment 10 got high score. Based on a hedonic scale, overall acceptability taken. And next slide. Effect of sugar levels and juice blends on overall acceptability of RTS beverage. In sugar levels, 15% sugar level got high score in all the treatments. In juice blends, 5% carrot got high score, that is 8.2. Interaction effect in sugar levels and juice blends on overall acceptability. In this also, 5% carrot, RTS prepared with 5% carrot got high score, that is 8.8. Later, 2% beetroot got 8.4. No blend got 7.3 score. These are the 3 treatments got best score in, that is RTS prepared with 5% carrot and RTS prepared with 2% beetroot. Later, this is control treatment. Conclusion: sweet orange RTS prepared with 5% carrot got a high score, and that is found best in, that is most acceptable in during the storage period. Later, RTS prepared with 2%
Divya,
beetroot.
your time is over.
Okay, madam. The sweet orange RTS blend is acceptable even after the 3 months
You
of the
conclude it.
storage at refrigeration conditions.
You
Uh,
conclude
so
and tell
we-
which is the best treatment. Which is the best
10th
treatment in
madam.
terms of acceptability,
RTS prepared with
consumer acceptability.
5% carrot and 2% beetroot. These are the best treatments. Thank you. Thank you.
Okay, thank you. Next presentation. Organic farming in coconut-based cropping systems by A. Kirti from HRS Ambazipeta. Kiriti from HRS Ambazipeta. Kiriti.
Hello, am I audible, ma'am?
Yes.
Good evening to one and all. Good evening to chairman and co-chairman, ma'am. Myself, A. Kiriti, scientist horticulture working at Horticulture Research Station, Ambajipeta. Right now, I am presenting organic farming in coconut-based cropping systems. We are all well known about that consumption of tender coconut water has improved a lot after pandemic COVID-19 situation. And after that, the area of coconut is also improving in Andhra Pradesh. So organic farming is gaining some popularity in farming community as organic produce are having a fetching more price. In that scenario, we conducted organic farming practices in coconut based cropping systems to develop organic farming package of practices in coconut. We have conducted with 5 treatments, that is in situ organic recycling plus PGPR consortia and in situ green manuring plus husk burial and 25 kg of cow dung and 50% of K2O in the form of sulfate of potash in the RBD model. So these are the applications of different treatments. We have done a husk burial treatment and chopping of green leaf manure glycine and application of PGPR consortia. Coming to results, influence of organic farming on growth and yield parameters of coconut. The treatment T4 has increased the palm height, that is 12.44 meters in organic treatment with 50% of K2O in the form of SOP, whereas palm girth was recorded maximum in chemical treatment, ma'am. Whereas other functional leaves and number of inflorescence was recorded as non-significant, whereas the number of nuts harvested per palm was recorded maximum in T4, that is organic treatment in situ organic matter recycling plus PGPR consortia and 25 kg of cow dung and 50% of K2 in the form of sulfate of potash. Whereas other treatments are also on par with these treatments. Chemical treatment is also on par with this treatment. Whereas copra yield was also recorded maximum in chemical treatment, that is 12.26 kg per palm per year, ma'am. Whereas influence of different years yield in the coconut in organic treatment, over a period the yield was decreased due to some rugose spiraling whitefly attack after 2019. But anyway, the yield of the coconut was compared to chemical, organic treatment also maintained at par only. So influence of vegetative and yield characters of cocoa, the yield and vegetative characters was not affected by the organic farming treatments, whereas yield was increased in T4 treatment, that is 0.86 kg dry yield per palm per year. Coming to the soil nutrient status with the application of organic organic treatments, at the soil nutrient status prior to experiment initiation was non-significant in nitrogen, phosphorus, and potassium. After the application of treatments for over a period of 5 years, T5 treatment has improved the nitrogen content and phosphorus content and potassium content, whereas nitrogen, phosphorus, and content was maintained by application of organic treatments, whereas potassium content was depleted by 50% in organic treatments, that is T4 and T1 to T4. organic carbon content was improved a lot in the T4 treatment compared to year of initiation. So the graph showing that the soil nutrient status of nitrogen was maintained in all the T1, T2 to T4 treatments, whereas the soil phosphorus content was bit lesser compared to year of initiation, whereas potassium content was depleted a lot in the all the treatments. So leaf nutrient status of coconut and cocoa in organic and chemical treatments, whereas the T4 was recorded somewhat significant results with T5, that is 2.10 and 2.34% of nitrogen, whereas potassium content was a bit lesser with 1.25% and 1.08%. The effect of organic treatments on microbial population has showed that the T5 treatment has decreased the earthworm population and bacterial and trichoderma population compared to the initiation year. T4 has improved the bacterial and trichoderma population, which are beneficial for improving the uptake of nutrients. So the economics of the organic treatments, that cost benefit ratio was more in T5 treatment, but T4 treatment is also best with 1 rupee of investment, 2.16 rupees of benefit will be fetching by using organic treatments. So conclusion is the mean coconut yield was improved by using the organic treatment, which and cocoa dry bean yield was also maximum in T4 treatment. The cost benefit ratio was 2.06. So we can recommend in situ green manuring recycling plus PGPR consortia and 25 kg of cow dung plus 50% of recommended K2O for the application in the coconut areas.
Thank you.
Thank you.
Thank you, Dr. Kiriti. Any queries regarding
hello.
this presentation?
Hello, Kirti sir.
Yes.
This is Vani. Sir, if you used cow dung for this coconut organic farming, if you faced any the rhinoceros beetle issues, or you didn't face?
Rhinoceros beetle will be breeded only when we accumulate the store the FIM for a period of 10 to 15 days or 25 days. Actually, we are applying as when we received the FIM, so we have not yet that rhinoceros incidents.
So you didn't face. Okay, thank you. Thank you.
So if there are no questions, we'll move to next presentation. Yes. Effect of different growing media on seed generation, seedling growth of papaya by Dr. Sridhar, Senior Scientist, HRS Anantara Hospital.
Good evening, madam. Myself, Dr. D. Sridhar, madam. Vinod, are you there? Can you please share my slides?
Sridhar, you can start.
So, respected Madam, respected Dean of Horticulture Padmatam Madam Garu and Vijay Padma Madam Garu, College of Horticulture Chinlatapi, and respected all dignitaries, senior scientists, myself Dr. D. Sridhar, working as senior scientist horticulture at Horticulture Registration Mahanandi Anantarajpeta. Here I am going to present different potting mixtures, the effect of different potting mixtures on growth of papaya seedlings. Actually, why I have selected this topic means majorly papaya nowadays the cost of the seed, as many of the growing are red lady seed. So the cost of that red lady seed varies from 6 rupees to 7 rupees each seed. The 10 grams packet which contains 500 to 600 seeds, the cost of that seed itself is around 3000. I mean 10 grams packet is 3500 to 3700. So in order to increase its germination percentage, I have taken up especially these treatments. Is my slide sharing, madam?
Okay, directly tell which is the best medium and how it is best. Economics.
Okay. 1 minute.
If you have any table, you can try.
Yeah. Yes, madam. Madam, actually the treatments are soil plus vermicompost, with 2 centimeter cocopeat at the top, and the third treatment is soil plus vermicompost and vermiclite, and the fourth is soil vermicompost and vermiclite in the ratio of 1:1:1 with 2 centimeters cocopeat at the top, and T5 treatment is soil plus vermicompost and perlite, T6 treatment is soil plus vermicompost plus perlite, and T7 is soil plus FIM, T8 is soil plus FIM with a 2 centimeter cocopeat at the top, and T9 is the control. It's a RBD design, and actually the seeds are treated with gibberellic acid at the rate of 2 ppm for 24 hours, madam. Among all the treatments, we have found that the germination percent was found highest with T4 treatment, that is soil vermicompost plus vermiclite, which was on par with all the treatments, madam. Whereas at the 45 days of planting, plant height, number of leaves, stem girth was found highest with the T3 treatment, that is soil plus vermicompost plus vermiclite, as well as at the time of 60 days after planting also, plant height, number of leaves and stem girth was found highest at the same treatment, that is soil vermicompost with vermiclite in the ratio of 1:1:1, where the at the same time total fresh weight of the plant, shoot fresh weight, root fresh weight, total dry weight of the plant, shoot to dry weight, root to dry weight, total dry weight percentage was found highest with the same treatment, that is soil plus vermiclite and vermicompost, madam, in the ratio of 1:1:1. And if slides are not opening, you can if it opens, you can see some of the photographs, clear cut photographs about how the influence was there. Actually, we have found that the vermiculite was found, it is a soilless media, it is used in soilless media, and at the same time it is used in seed germination, madam, and it has this good root anchorage, as well as this vermiculite is having good cation exchange capacity, so that the water absorption capacity is also more when we use the vermiculite as a one of the soil medium, madam, and nutrient retention capacity is also more, so that it is encouraging the calcium, magnesium and ammonium ions, so that the nutrient capacity will be more, so that the nutrient availability will be there, even if the plants which are having some of the nutrient deficiency, especially in potted plants, if we apply this vermiculite mixture, that will automatically supply these nutrients, so that the growth will be much more compared to the normal plants which we are using only soil and vermicompost like that. So apart from that, the vermiculite is acting as a soil conditioner, madam, so that even in heavy soils also, it provides air channels and make the soil breathe. So that if we mix in heavy soils also, the growth will be more. Even in sandy soils also, because of its capacity of water retention, the water retention capacity, so that the sandy soils also, they are not going to dry up. Suppose in big plants also, if we apply this vermiculite or perlite, so that the more moisture retention capacity, so that more growth will be observed, madam. This is the perlite is one of the mica derivative, madam, mica byproduct. These are all my observations, madam. And the conclusion is, as a soil mixture in papaya, soil with vermicompost and vermiculite in the ratio of 1:1:1. If you use this, the germination percentage as well as total fresh weight and all the growth parameters are high, madam. Thank you, madam.
Dr. Sridhar, you show the table once.
Actually, that I have given to them, madam, to share.
Yeah. See. 96.67 to 32 soil plus vermicompost 1:1 with 2 centimeters coco peat at top. Whereas you are telling which treatment is better, you are telling vermiculite?
T3 vermiculite, madam.
Vermiculite.
Yes, madam.
You are considering all the growth parameters.
Yes, madam. Yes, madam. Actually, the germination percentage, madam.
That's okay, but what about the economics? Vermiculite cost?
Cost of vermiculite is 30 rupees per kg, madam. Actually, it's a mica byproduct, madam. Yes, madam. Mica byproduct, madam. It is, and the growth is if you see the photos, madam, there's a lot of growth difference observed, madam. Even at the time of 60 days, especially for that particular treatment. If I say even the plant height around it is 29 centimeters, madam, compared to others. Others is around 22, 23. Even for control, it is very less, madam. 7.5, 7.8 like that. Whereas this one is 23, 24, madam. The growth is very high, madam. In especially vermiculite when we have used.
Except for the plant height, remaining all are non-significant.
No, madam. Only the germination percentage was non-significant, whereas number of leaves was non-significant. Plant height, stem girth.
No, you just no. I'm telling about the remaining parameters other than germination percentage. What I feel from this, if you use only vermiculite, vermicompost, soil, and coco peat, it would not be good. I meant to say P2.
Yeah. Yes, madam. That is not good because maybe we have used coco peat only for 2 centimeters at the top, madam. For having for good germination, I have seen some of the. Suppose if we are going to keep the seeds in coco peat, the germination percent will be more like that. I have seen some of the references, so that I have used in coco peat in all the parameters also, all the treatments also. But the germination percent was found non-significant. Whereas the total of fresh weight, you observe, madam, fresh weight, total fresh weight, shoot fresh, second table, madam, root fresh weight, total dry weight, everything is good in T3 treatment, madam. That vermiculite treatment.
Okay, thank you.
Okay, madam, thank you.
So, any more questions? So, there are no questions. We'll switch over to next presentation by Dr. Lalita Kadri. Introduction and standardization of agrotechnics for Nulkol in Andhra Pradesh for higher yield and profitability. College of Horticulture, Anantaraspet.
Good evening, madam. Am I audible, madam? Is my screen visible?
Yes.
Yes, ma'am. Good evening to one and all. Today, I'm going to present my topic on introduction and standardization of agrotechnics for Nulkol in Andhra Pradesh for higher yield and profitability. This Nulkol is a non-traditional crop in Andhra Pradesh. It is a cool season crop. It is gaining popularity due to its hyper anti-hyperglycemic, anti-carcinogenic properties because of rich antioxidant activity, because of presence of rich antioxidants like ascorbic acid, carotenoids, phenolic contents, etc. And also it is a good source of vitamin A, carbohydrates, fiber, minerals, phosphorus, minerals like phosphorus, calcium, iron, etc. Besides, it also contains sulforaphanes and other isothiocyanates, which are believed to stimulate the production of protective enzymes in the body. This Nulcol is a very short duration crop, which can come up in just 80 to 90 days in case of Rabi. So this can be introduced in this Andhra Pradesh. So with this, we have conducted observational trials at HRS Anantarajupeta, where we witnessed the scope of introduction of this crop. So that's why we thought of standardizing agrotechnics for this crop. With that objective, I have done this work as a part of my PhD work, and the design I adopted was split consecutively, then spacings like 13 to 15, 13 to 30, 45 into 15, then graded levels of nitrogen from 0 to 125 kg nitrogen. Only graded levels of nitrogen was applied variably, whereas other primary nutrients, that is P2O5 and K2O, were applied uniformly to all the treatments. This is the layout plan of my experimental field. And coming to the knob yield of Nulcol as influenced by varied time of planting, spacing, and nitrogen doses. So these three factors, that is time of planting, spacing, nitrogen doses, significantly influence the knob yield of Nulcol during both the years, that is during 2014-15 and 15-16, with same trend, unaltered trend. If you see the knob yield differences among 3 times of planting, late planting during December, first fortnight of December resulted in higher yield when compared to earlier plantings of first and second fortnight respectively, because when it is planted early, it coincides with monsoons. Here, in case of the southern agroclimatic zone, especially in case of Chittoor and Nellore districts, we receive bimodal distribution of rainfall. Apart from southwest, we receive northeast monsoon also. So we receive considerable amount of rainfall in short period of time, leading to waterlogging stress. So that's why this time of planting is taken as one of the factors. And then among the different spacings, wider spacing resulted in higher yield compared to closer spacing resulted in higher yield when compared to wider spacings. Among nitrogen doses tested, in graded levels of nitrogen, with increase in nitrogen doses, knob yield also increased correspondingly. So the reduction in case of yield due to later plantings was more in case of second year of experimentation when compared to first year of experimentation, because during second year of experimentation, during seedling stage, a heavy rainfall of 942 mm was received in just 20 rainy days, which resulted in high waterlogging stress, leading to deleterious effect on the growth and final yield of Nulcol. Whereas only 106.1 mm was received in case of 8 rainy days in case of first year. That's why yield was more during first year when compared to second year. Coming to interaction effect of these 3 factors, among only interaction between spacing and nitrogen doses alone was significant. So higher knob yield was obtained with closer spacing coupled with higher nitrogen level, that is 36.3 S1 N5, whereas lowest yield was noticed with wider spacing and lowest level of nitrogen tried. Then coming to economics of Nulcol cultivation as influenced by varied time of planting, spacing, and nitrogen doses. So whenever introduction of new crop is to be taken up, this economics will be the basic thing upon which its dissemination is depends. So if you see the economics of Nulcol cultivation, the gross returns and net returns of Nulcol as influenced by different times of planting, spacing, and nitrogen doses followed same trend with that of yield. Whereas in case of BC ratio, It was more in case of wider spacings, because in case of wider spacings, amount of input needed is less, thereby cost of cultivation reduced. Because of reduction cost of cultivation, BC ratio was slightly more. But if you see the amount of increment, only the closer spacings were remunerative. So in conclusion, in case of southern agroclimatic zone of Andhra Pradesh, because of nowadays climate change, we are seeing lot of extremities in climate, like complete drought or untimely rains, because of which flowering of important crops, for example, in this region, flowering of mango is often affected. So depending upon only one crop, monocropping sometimes leads to total loss because of these climatic extremities. So in order to improve the profitability and productivity of land, we need to go for multiple cropping. So introduction of this short duration crop is very much feasible in case of monocrops that are cultivated in this region, like banana, papaya, etc., because of wider spacing between the rows. So in this region, among the 3 planting times tested, planting the null-call during first fortnight of December with a closer spacing of 30 into 15, with the highest level of nitrogen, that is 150 kg nitrogen per hectare, will result in highest yield and higher economic returns. So these are all some of the photographs of my research work. Nursery, then progressive growth of null-call seedlings in nursery, overall view of the experimental plot during 2 years, that is during 2014, 15, 15, 16. We can see that clearly the variation in growth because of different factors, transplanting and harvesting, variation in null-call growth due to varied times of planting, spacing, and nitrogen doses. This plate depicts variation in knob size due to varied spacings, nitrogen doses, and the best performed planting time, that is first fortnight of December. So I thank the organizers for giving me this opportunity.
Thank you, Dr. Lalita, for the nice presentation. And if there are any questions from the audience, please, it is open for discussion. If there are no questions, we'll go to next topic.
Hi, ma'am. Lalita, ma'am, this is Vani. Ma'am, flower. What about flower setting? It is very feasible, or it is economically viable, or is there any season particularly for southern part of Andhra Pradesh?
No, here temperatures will be high. Flowers will not set here. We grow this null-call only for the knob.
Okay,
So,
up to
to knob only. So this the higher temperatures in this region are not suitable for flowering in this area.
Thank you, ma'am.
Thank you.
So wherever cabbage and cauliflower seed production is done, there only will get flowering. Okay. Thank you, Dr. Lalita.
Thank you, madam.
Next presentation. Production and quality of strawberry as affected by fertilizer, nitrogen rate, and biofertilizers inoculation under greenhouse conditions. Hey, Dr. G. Chandrasekhar Reddy, Assistant Professor, Dr. YSRH, College of Horticulture, Anantaraspet. Yes, you can start.
Thank you, madam.
Oral.
Madam, my sheet is visible, madam?
Yes.
Thank you, Madam. Respected Chairman and Co-Chairman and Rapporteurs and other presenters, a warm good evening one and all. Myself, Dr. Chandramohan Reddy, working as Assistant Professor, Department of Horticulture, Dr. YSRH, College of Horticulture, Kandarajpet. So today here I am presenting a topic on production and quality of strawberry affected by different nitrogen rates and biofertilizer under greenhouse conditions. Coming to the brief introduction about strawberry, strawberry is one of the important popular food crop because it is 98% of the food is edible portion and also rich source of nutrients, minerals and vitamins and also antioxidant properties. That's why people are consuming this strawberry as a raw and different processed products. So in India, it is cultivating especially in the generally hilly areas like West Bengal, Darjeeling areas, Kalimpong areas and Mahabaleshwar area of the Maharashtra and Tamil Nadu, especially in Ooty, Kodaikanal, Kunar, different regions. However, introduction of different day-neutral cultivars and other important cultivars, especially in northeastern states as well as North India. So now strawberry cultivating maximum in North Indian plains. So nowadays Haryana is the #1 in both area and production. When it comes to the Andhra Pradesh, so it's cultivating especially in the ANC area of Visakhapatnam district, especially Lammasingh area, Chintapalli and Pader area because highly suitable of climatic conditions. And also not only for Chintapalli area, and also some parts of Anantapur district, especially adjoining area of Karnataka, Hindupuram, Madaksira, Penukonda, some Kanekal areas. So farmers are cultivating strawberry for commercial purpose. So coming to the brief objective of this topic, to study the effect of different rates of nitrogen and biofertilizers on performance of strawberry. As we know, strawberry is a shallow-rooted crop required for the frequent nutrition for a proper growth and development. However, farmers are adopting only for 3 times application of the nutrients, one at basal dose, one at flowering and fruiting stage. So here we are going for the nitrogen application at weekly intervals after planting of the 1 week. So biofertilizer also applying for the along with the nitrogen to see the performance of the strawberry. So coming to the materials methods. So this experiment conducted Precision Farming Development Center, Chaudhary Saran Singh, Haryana, Agricultural University, Isar, Haryana. So we are taking for the variety Winter Dawn. This is a new variety because nowadays North Indian people are cultivating this variety. It is high yielding and also resistant for the Botrys diplodia and also for the verticillium wilt. So the planting was done at October 1st week and 2 years, that is 18, 19, 19, 20 years. So that is the best time for the planting of a strawberry in North India, October 1st and 2nd week. So we are adapting for the 2 factorial CRD. One factor is a biofertilizer and one factor is a nitrogen. So biofertilizers, one is control and Azotobacter application, azosphere application. Whereas levels of nitrogen, we have 4 levels of nitrogen application, one at 0, 80%, 100% and 120% recommended of nitrogen. So here biofertilizer applied in the liquid form after 20 days after planting, 20 ml for each plant, we are pouring for this liquid biofertilizer root periphery 20 days and 40 days after transplanting. Whereas for nitrogen, we are giving for the water soluble fertilizer form through fertigation. So after 1 week after planting. So we are taking for observations on growth parameters like plant height, plant spread, and yield parameters and quality parameters. And we are taking for data and analyzing for the using of the OP-STAT software technologies. So coming to the result and discussion. So here we see maximum plant height, plant spread, number of leaves per plant, and crown diameter and the emergence of first flower. Application of the different nitrogen levels shown the significant results. However, plant height was a maximum observed in 120% of recommended of nitrogen fertilizers, that is 18.52 centimeters and 19.66 centimeters. However, plant spread number of leaves are shown in the 100% recommended of nitrogen fertilizers. Here we see, so plant height measured at 150 days after transplanting. So initially applying for the every week high dose of nitrogen showing for the plant height is maximum, but the plant spread it will be there for the runner production, sucker production. So plant spread the number of leaves shown for the higher in the 100% recommended of fertilizers. So whereas concerned for the biofertilizers, so both biofertilizers, Azotobacter and Azotobacter application showing for the significant results compared with the control. Here we see emergence of first flower seen in less number of days taken in 100% recommended of nitrogen fertilizer, that is 37.55 days and 38.45 days in both the years. It is at par with the 80% recommended of fertilizers. Here we see emergence of first flowers taken for the less days in 80% and 100%, but whereas for the 120% recommended of nitrogen fertilizer showing for the more days because it gives the more vegetative growth compared to the 80% and 100% recommended of the nitrogen fertilizers. So these are the plant development stages. This is the first one is the crown initiation stage and flowering stage. This is especially strawberry, we have the different flowering stages, that is primary, tertiary, and secondary different varieties. So here we see for that at a flowering and fruiting stage. So coming to the yield parameters affected by different levels of nitrogen and biofertilizer. Here we see number of fruits per plant is shown for the higher in the 120% recommended of pipeline, that is 20.92 and 21.65 fruits per plant. However, fruit weight, fruit length, fruit yield per plant is shown the maximum at 100% recommended of nitrogen fertilizers. We see for the different levels of fertilizers. So increasing the levels of fertilizers, it will decrease the yield. But however, see for the biofertilizer, it will increase the more number of fruits per plant, especially for interaction is also significant. So application of the 100% recommended of fertilizers along with Azurobacter giving for the maximum fruit per plant, that is 21.95 and 22.80 fruits per plant. Coming to the fruit yield per plant, here we see, so but whereas for the fruit, number of fruits is maximum at 120% of recommended fertilizers, but you see for the fruit yield, because it will be long, up to 70 days it will start the flowering fruiting, up to the 150 days. That's why we are fruit yield is maximum at 100% recommended of biofertilizer, that is 288.15 gram and 318.62 grams. So that's why it's showing that interaction also very significant. So maximum fruit yield for a plant were observed by Azurobacter application along with the 100% recommended of biofertilizers. Coming to the quality parameters affected by different levels of nitrogen biofertilizers. So maximum juice content, TSS, and also anthocyanate content is maximum at 120% recommended of biofertilizers. Because if you apply for the more nitrogen fertilizers, it will increase the content and soluble solids. So whereas for the acidity and ascorbic acid, so maximum shown for the 100% recommended of biofertilizer. So if you are increasing for the TSS, always it will negative effect on the acidity and ascorbic acid. It will improve for the more polyphenols. So this conclusion that applying for the nitrogen fertilizers at equal intervals up to the 100% only, it will increasing the plant growth and development. However, if it increase for the more than 100%, that is 120%, it will go for the negative effects, because it will increase the soil pH and also for the imbalance between the different macro and micronutrients. So that's why here is showing that application of the 100% biofertilizers along with the nitrogen give for the more number of fruits and more number of fruit yield per plant, that is 28.14 gram and 31.62 grams per plant. So here see for the Azurobacter application compared to the control, because this biofertilizer secretion for the more plant growth hormones, also for the fixing of the nitrogen. So why we are using for only this Azurobacter in northern plains, because these are the acidic soils. So this acidic and neutral soils, the Azurobacter only for the survive up to the 150 days after the crop cycle. So it is concluded that the application of the along with the nitrogen, phosphorus, potassium, 100% recommended as biofertilizers. So we can get the more number of fruits and plant growth, and also we are recording for the less disease incidence, especially in the strawberry. When we are given the irrigation, it will give for the border diploid rot. So here we conclude that application of the RDF will get the good yields along with the biofertilizers.
Okay, thank you, Dr. Chandravan. You have tried this. This is your PhD work, I think.
Yes, madam. This is one of the objective, madam. One of the experiment, madam.
Okay. Have you have any idea of trying the strawberry in our conditions? I mean, here in southern parts, in this region, under polyhouse conditions.
Yes, ma'am. Yeah, yes, it's possible, ma'am. But in winter season here, temperature almost 15 to 18 degree temperature, ma'am. So in polyhouses, we just to maintain for the temperature modulation, we can cultivate commercially, madam. So some farmers in Manapalli area also they are cultivating, madam, in polyhouses.
Okay. So any questions from the audience? Okay, if there are no questions, thank you, Dr. Chandravan. Nice presentation. Thank you very much.
Thank you, madam. Thank you for giving opportunity. Thank you, madam.
Thank you. So we I think among the presentation, I mean oral presentations, last one is physico-chemical and nutritional profiling of seed butter in Garcinia species.
Madam,
among the oral penetrations, the last one is physicochemical and nutritional profiling of seed butter in Garcinia species by Urati Mahesh, Department of PSMS, College of Horticulture, Anantara Aspect.
Good evening, teachers. Hope I am audible.
Yeah, you are audible.
Good evening, teachers. Myself, Urati Mahesh, here with research findings on physiochemical and nutritional profiling of seed butter in Garcinia species. Conventional edible oils are becoming very scarce, and there is need to establish alternate oil-bearing seeds as substitutes. There are hundreds of tree species which provide food for people in both the humid and semi-arid tropics, but they have received much less scientific attention from the community than the annual crops. Preliminary composition studies on the seeds of Garcinia species showed that they deserve to be investigated as a promising source of fats for possible use as food to bridge the gap of oil deficiency. Both Cambodia and Kokum are the indigenous perennial tree species which is native to the western Ghats of India. Cambodia is known as Garcinia gammigutta, whereas Kokum is called as Garcinia indica. Cambodia is grown as a homestead crop in Kerala, whereas Kokum is grown in the homestead crop of Konkan region of Maharashtra, Goa, coastal and southern parts of Karnataka. Dried fruit rind is the economic part of the both Cambodia and Kokum. Fruit rinds of Cambodia and Kokum are rich source of hydroxycitric acid, rich source of hydroxycitric acid, an important biological active plant metabolite used as an anti-obesity and anti-cholesterol drug. And there are plenty of seeds after fruit rind collection go as waste. Only some parts of the seeds are useful for the collection of for the seedling production, and remaining seeds are go as waste. In order to convert the waste produce into valid form, there is a systematic study needed to study on the properties of the seeds and seed butter. Coming to the materials and methods, seeds of both Cambodia and Kokum were collected from the identified elite accessions during the peak period of fruiting, and the seeds kernels were collected after removing the shell of the seeds, and these kernels are utilized as the study material. Here in Cambodia, I selected 3 accessions, whereas in Kokum, I selected 3 accessions. In Cambodia, 1 accession is selected from the Garcinia block, Department of Fruit Science, COA Vellanikara. 1 accession is each from Plantation Spice from and ICR, NBPGR, Regional Station Vellanikara. Whereas in Kokum, 1 accession is selected from the College Orchard, Department of Fruit Science, and 2 accessions are selected from the ICR, NBPGR, Regional Station, Vellanikara. Here, the Cambodia fruits were collected during the peak period of fruit, and these seeds were extracted, followed by the extraction of the Cambodia butter. In a similar fashion, Kokum fruits were collected during the peak period of fruiting. Kokum seeds were extracted, and following by the extraction of the Kokum butter. Here, procedure used for the extraction of butter from the seeds. Cambodia kernels were collected, and the kernels were dipped in the hot water to remove the impurities present on the top surface of the seed. And these kernels are roasted for 5 to 10 minutes to make the fats loose from the seeds. So the fats become loose from the seeds, and this roasted kernels were grind into fine powder. These fine powders used in the soft extraction operators to produce the Cambodia butter. In the similar way, Kokum butter is also prepared. The physiochemical and nutritional properties were estimated using standard analytical methods, and the results were discussed here. The moisture content was significantly recorded higher in case of Cambodia when compared to the Kokum. The moisture content was recorded low in both butters, which indicates the longevity and the purity of the butter. The refractive index was good in both case of Cambodia and Kokum butter. The melting point was significantly recorded higher in case of Cambodia butter when compared to the Kokum butter. The boiling point is greater than 300 degrees centigrade in both Cambodia and Kokum butter, which indicates the deep frying nature and the quality of the butter. Here, the melting point is 39.17. When compared to the cocoa butter, the melting point is 5 to 10 degrees higher in Cambodian Kokum butter. This indicates that these Cambodian Kokum butter were used as a substitute for preparation of chocolates. These chocolates were used in the hotter regions, so the melting of the chocolates will take place will take place slowly. Coming to the chemical parameters, the pH content for pH and acid value, there is no significant difference observed in both Cambodian and Kokum butter. Ash content was significantly recorded higher in case of Cambodia butter when compared to the Kokum butter. And the saponification value, iodine value, ester value were recorded significantly higher in case of Cambodia butter when compared to the Kokum butter. The saponification value was recorded good in both Cambodia and Kokum butter, which indicates that they are used for the preparation of the soaps and oils. Iodine value indicates the measure of unsaturation. The iodine value was good in both Cambodia and Kokum butter. The peroxide value was significantly higher in case of Kokum butter when compared to Cambodia butter. The lower the peroxide value indicates the lesser chances of oxidation and more the shelf life of the produce. Coming to the nutritional composition of the butter, the fat content was significantly recorded higher in case of kokum butter when compared to the Cambodge butter, and the calcium and iron content were recorded in good amounts in both the butters, and the potassium content were significantly recorded higher in case of Cambodge butter when compared to the kokum butter, and the sodium content was recorded significantly higher in the kokum butter when compared to the Cambodge butter. There's a good source of nutritional composition in the seed butter of both the Garcinia species. Coming to the conclusion, here we can conclude that effective use of the Cambodge and kokum seeds for the extraction of the butter on a commercial scale would encourage the small scale industries, and both the Garcinia species seeds yields butter of food grade. It can be comparable with the milk and cocoa butter in all the biochemical and nutritional characters. This method helps in the conversion of waste produce into value added forms by extracting the seed butter. Cambodge and kokum butter can be blended or substituted with many products, and in many butter can be used in the preparation of different food products. These are the products prepared by using kokum and Cambodge butter. This is burfi prepared using both the butters, and this is a cake prepared using both the butters. Organoleptic evaluation was done, and it is after milk butter. This kokum and Cambodge butter were given good recordings when compared to the cocoa butter. Thank you, teachers.
Thank you, Mahesh. Good presentation. Now, any questions from audience?
Hello, Mahesh.
Madam.
Hello.
Madam.
Mahesh.
Madam.
What is the use of this kokum and Cambodge rind?
Madam.
Do you know?
Madam, this kokum rind is used for the preparation of pleasant beverages, and the kokum rind is used for the extraction of the pigments also, madam. Whereas Cambodge is used as a souring condiment in the preparation of fish curries in Kerala region, madam. Just like a tamarind we use in the preparation of fish curries, they use the dried rind of the Cambodge as a souring condiment, madam, because this Cambodge rind is rich source of phytositric acid, madam. So they have anti-obesity and anti-cholesterol properties are also seen in that rind, madam.
Okay, Mahesh. Okay. Thank you.
Madam, it is not audible.
Okay, Mahesh. Thank you.
Okay, madam.
Hello.
Hello.
Mahesh.
Sir,
I am Kiriti, scientist horticulture.
Sir.
How we can compare this cocoa butter with Cambodge or kokum butter?
Sir, there are so many physiochemical and nutritional properties which are similar to the cocoa butter, sir. So there are so many. I have done, sir. I have prepared so many products from the cocoa butter, Cambodge butter, milk butter, and as well as kokum. Four products were prepared, sir. By using these, after milk butter, the Cambodge and kokum butter is far better than the cocoa butter, sir.
Okay. Actually, for what cocoa butter is used in chocolates? You have any idea?
Sir, cocoa butter is used to increase the hardness of the chocolate, sir. Why? Because kokum butter has a high melting point due to presence of the long chain fatty acids. So it can be used blended or substituted. About 15% of the kokum butter is used to increase the hardness of the chocolate, sir. Why? Because cocoa has a delicate flavor, whereas in kokum and Cambodge butter, there is no such flavor is observed in case of this butter, sir. That is why only 15 to 20% is added to the cocoa butter to increase the hardness of the chocolates. This is required in case of hotter regions for the blend of the chocolate, sir.
Yeah. Okay.
Thank you, sir.
Thank you, Mahesh.
Thank you, madam.
Thanks for the presentation.
Right.
Now there is a last presentation by Dr. M. Vijayalakshmi about the topic status of ethnic vegetables in Andhra Pradesh, a statistical analysis. Vijayalakshmi, are you ready?
Madam, ready, madam. Thank you, madam. Good evening, one and all.
Madam, please complete within the stipulated time.
Okay, madam. Thank you, madam. I'm presenting the topic on status of ethnic vegetables in Andhra Pradesh, a statistical analysis. I found out some, I introduced some of the points here. Horticulture is the fastest rising sector within the Indian agriculture. Ethnic vegetable production in Andhra Pradesh has shown great potential with respect to based on the state's horticultural industry. I here observe that about rounded 45 plus ethnic vegetables are in Andhra Pradesh area. Ethnic vegetables are which are traditionally grown in India. Ethnic vegetables are mostly available in tribal and rural areas. My objective studies in this ethnic vegetables in this paper, I identified the 6 ethnic vegetables are bottle gourd, brinjal, cucumber, elephant foot yam, and coriander, ginger. And then after I study the behavior of the ethnic vegetables based on its area and production, based on the in Andhra Pradesh area. And then after I examine the performance for the ethnic vegetables based on the ARIMA model. Here ARIMA model is the linear model, and it is the very traditional model. And then after I study the accuracy of the forecasting of this ARIMA model. Here I applied the mean error and mean percentile error and mean absolute error and the root mean square error and absolute mean square error. And then after performing the ARIMA model, I using the ACF and PACF values. Then after I study the next 10 years production rates in Andhra Pradesh of ethnic vegetables. Here I take the data from Andhra Pradesh horticulture website after the bifurcation of Andhra Pradesh. Here major crops I taken the ethnic vegetables are bottle gourd, brinjal, cucumber, elephant foot yam, coriander, ginger. 2014 to 20 data.
Vijayalakshmi,
Madam,
slides are not moving.
Madam, here the area using the classification in Andhra Pradesh, and also
your slide is stable. Your slides are not moving, Vijaya.
No, madam. Some technical problem, I think, madam.
Only first slide is being shown.
Can I share again, madam?
Please. You unshare it and share it again.
Okay, madam. Madam, is it visible, madam? Madam?
Yes.
Ethnic vegetables area classification in Andhra Pradesh. Here I classified and the production of the classification of Andhra Pradesh and ethnic vegetables. Then after I study the status of ethnic vegetables, here I mainly observe that brinjal is minimum area and taken the maximum production rate. And performance indicators and accuracy of the data can be found out using the AIC and BIC information criteria. Here AIC is the information criteria and BIC is the Bayesian information criteria. And then after I study the accuracy of data, find out these parameters.
Vijaya, your slides are not moving. See, because you are showing the statistics, but nothing is seen here. So ultimate purpose is a waste. Please change it. Otherwise, you tell the essence and finally conclude it.
Okay, madam. So here
it is already exceeding the time.
Madam. Here I concluded that when I study the best of 3 ethnic vegetables out of 6, brinjal stands in the first place and second place in the elephant foot yam, and third place is cucumber with respect to their less areas and high production in AP. And next I concluded that based on the previous data, observe that increase the cultivation of ethnic vegetables with less area for next 10 years in Andhra Pradesh. Thank you, madam.
Thank you, Vijaya.
Thank you, madam.
Thank you. With this, we have completed all the oral presentations, 8 oral presentations in the session 5 of recent advances in horticulture crops. Now we'll switch over to poster presentations. There are totally 16 poster presentations. First, we'll have the poster presentations of the scientists from out of state universities. First one is Significance of Proteomics in Vegetable Crops by Mahesha KN, PhD scholar, Department of Vegetable Science, Navsari Agriculture University, Navsari. Mahesha.
Mahesh.
Mr. Mahesh, are you available?
Naveen, check. Mahesh is online.
Next scientist, next topic, nano remediation strategy to remediate contaminated environment by using aromatic plants by D. Vani, PhD scholar, School of Agriculture Science, Department of Agriculture and Nanotechnology, Tiruchirappalli. Yes.
Vani is there. You close him. Close, yes.
Miss Vani.
Ma'am, I'm audible?
Yes, you are audible.
Yes. So I think my slide is visible. My poster is visible. Yes. Hello. Hello, ma'am.
Yes, it is visible. You
Yeah,
can
yeah.
go ahead.
Yes. So myself, Vani, research scholar of School of Agriculture Science, Dhanalakshmi Srinivasan University, as I mentioned in top. So my study is nanophytoremediation of contaminated environment, basically by using the aromatic plants. So the background, everybody, why this topic, why it is important. So yeah, nowadays everything is in pollution due to modern technologies or due to urbanizations or so many things. So we have to clean our environment. That is very important. So phytoremediation is, I mean, gaining more attention. I mean, past more than 10 years, but still it is in research only. But the main limitation in phytoremediation is the efficiency level. So that's why we are in lacking in commercial application part. So if it is combined with some other technology, so if it is combined with some other technology, means it will increase the efficiency of phytoremediations. So that's why nano phytoremediation gaining emerging attention towards cleaning the environment. In this, so many researchers are done by some authors, but if it is still, it is very limited plants tested in aromatic plant species. So in this phytoremediation process, it's having nano phyto volatilizations, nano phyto extractions, nano phyto stabilization, nano phyto rhizo degradations. So these are all the few process that is blended with plant-based remedies and nanomaterials, along with nanomaterials. So in research status, a few researchers done in aromatic plants. So these are all the researchers done in vetiver along with chelating HM binding proteins and ion nano zero violent ion particles, nanoparticles, along with uh, plant, aromatic plant, osmium plant. So these are all nowadays. So few things are tested to remediate the agrochemical residues, and also some heavy metals, and also some organic pollutants. So the main components involved, the plant, the choosing of plant species, and also environmental factors and type of contaminants, which type of contaminants we are going to remediate, and the which type of nanomaterials, because the property and characteristic of nanomaterial also important. The summary is, so nanotechnology combined with phytoremediation, it will, as I said earlier, it will increase the efficiency of phytoremediation process, and also it is a sustainable technology, and it's a plant-based solar-driven process. So the main thing is we have to the more research needed, or more aromatic plant should be explored under for remediating the polluted particles, and so many interdisciplinary research also need to remediate the soil pollutions, as well as air and water pollutions. So thank you, ma'am.
Hello?
Yes, hello.
Dr. Vani,
Yes, ma'am. Yes, ma'am.
you have mentioned different families where different aromatic plants are used. You have not
Yes.
given the list of plants you have used.
Yes. Because very few aromatic plants used, ma'am. Vetiver, lemongrass, they are used in for some few researchers, and osmium species, and along with lemon palm. These are all the plants they are used. Still, it is in exploration process only, ma'am.
So how did you test with these aromatic plants that the environment pollutants have been removed?
Ma'am, I didn't get, ma'am.
No, the pollutants you told these aromatic plants will remove the pollutants from the
Yes,
environment.
yes,
But
ma'am.
how did you test this?
So so what are that heavy metal, or what is the organic pollutant, or what is the agrochemical in those area is highly available in soil. We tested in the we have to test it in the plant biomass content, ma'am, in plant content.
Biomass. Okay. That have been okay. Thank you.
Thank you, ma'am. Thank you. Yeah.
Next,
Stop sharing.
next poster presentation, performance evaluation of Pseudomonas fluorescens biopriming in improving vigor and yield of transplanted gingerbread official by Ms. Anne Sneha Baby, PhD scholar, Department of Plantation Crops from Velliyani, Kerala Agriculture University. Please, only 3 minutes time for poster presentation, including the interaction.
15.
You have to restrict to that much time only. Sneha from Kerala Agriculture University, is she available? Sneha?
Share చేస్తున్నాం, but she's available or not. Not available.
So if she is not available, we'll go for the.
Okay, sir. Okay.
Next presentation, aromatherapy, a natural way of healing by plants, by Dr. Sangamitra. Sangamitra available? Swaraj ikkadame kada. 1 minute, then we'll finish on.
Good. Okay. Question. Oral only.
Oral antar, post antar repena.
వాళ్ళకి తెలియదు కదా.
స్వరాజ్ లక్ష్మి మేడంతో క్లోజ్ చేస్తాం. స్వరాజ్ లక్ష్మి మేడం ఉంది స్వరాజ్ లక్ష్మి
So will be the
లాస్ట్ మేడం.
Madam, good evening, madam.
Roll of now the poster presentation. Role of probiotics in bioprocessing of vegetables by Dr. K. Swaraj Lakshmi, Professor Horticulture, College of Horticulture, Anantara Hospital. Swaraj Lakshmi, you can start.
Madam, good evening, madam. Very good evening to all dignitaries and organizers of
క్లోజ్ చేయండి మేడం, షేర్ చేస్తున్నారు.
this poster presentation. My topic for presentation is role of probiotics in bioprocessing of vegetables. Probiotics are the live microorganisms that are present in the human body, in the intestine, that are helping us in digestion and as well as for maintaining the balance in the microbial balance in the intestine. Among the microbiota that are present in human gut, lactic acid bacteria is the natural and it is present in large quantities in the human gut and maintaining the health. These strains are available in food. They are in different sources. They are available in milk. They are available in natural fruits. They are available in vegetables also. They are available, and these they help in fermentation of vegetables and improves the flavor and taste, and as well as the microbial population. And these are isolated from the banana pseudostem. Banana pseudostem is also having inner core is having dietary fibers that are helpful for human health. So they are exploited for vegetable purpose. These different sources of among the different sources we tried in banana pseudostem and isolated this LAB and they are tested and confirmed by different tests. They are isolated by MRS medium, man, robust and starch medium. All lactic acid bacteria isolated are subjected for morphological biochemical characterization and confirm their identity. And after that, they are used 6 cultures were they are isolated. These are all the tests conducted. Catalase negative test, phenol, red phenol lactose test, all these are conducted and purified. DNA of lab is purified, and these cultures, these are 6 cultures, they are all identified, and these are used for fermentation purpose for bioprocessing of cabbage and banana pseudostem. Both are used after this fermentation process is conducted. Then they are tested for their viability test is also conducted, and when compared to control, these all 6 cultures, they have viability count in CFU per ml. It is high, 18 into 10 to the power of 8 CFU per ml, like that. BPS 1, BPS lab 1, BPS lab 1 in banana pseudostem also, it is 20 into 10 to the power of 8 PMU per ml was recorded. Even sensory evaluation conducted also resulted in they got high score. This can be used. These cultures can be isolated and they can be used for starter cultures for processing of different vegetables. This is the experiment that conducted by my student, and now I am presenting my students' work, and I have collected some more information regarding this work. Thank you, madam, for giving me this opportunity. There is lot of scope for identification of different cultures, as these different cultures are having different properties. And when we want to use for vegetable purpose, different species may be having high efficiency. That's the reason why it is this work is taken for research purpose. Thank you, madam. Thank you for giving me this opportunity.
Thank you, Dr. Swaraj Lakshmi. Thank you very much. Now we are completing the most presentations for today's today, and it will be continued tomorrow morning. Now I thank the co-chairman and moderator and reporters for assisting me in conducting this program. Tomorrow we'll continue.
Thank you.
Morning,
Thank you.
9:30.
tomorrow by 9:30, the session will start again. Thank you very much.
Thank you.
Thank you.
Madam. ఎంతమంది జాయిన్ అయినారు? Jam Tarito Tajimita Gita Takata Tajunta Gita Tajimita Gita Takata Tajunta Gita
అవన్నీ చూసుకోండి అవి
ఓకేమా ఓకే
ಪ್ರಾಜೆಕ್ಟ್ ಇರ್ದಿಂದ ಸರ್ అదే దీంట్లో వీడియో రావాలి
నేను ఏం చెప్తానంటే ఏందో బాబు నువ్వు అంతా నేను చెప్పేది ఇನ್ನು ఇನ್ನು వీడియో వచ్చి వచ్చేట్టుగా లే-
అంతే ఫ్లైట్ మోడ్ లో పెట్టి ఎవరైనా ఫోన్ మెసేజ్ వస్తుంది. ఇంకా ఉంది కదా. Okay, sir. Okay. Finger బాలయ్య మాట్లాడండి.
వాళ్ళు పెరగని మీ ప్రయత్నానికి హ్యాట్స్ ఆఫ్. సో ఆడియన్స్ రెస్పాన్స్ థ్యాంక్ యూ వెరీ మచ్ సార్. Now solo dance performance by Master Thakur. He is son of Mr. Ragraj, caretaker boys hostel. Please thank you. Thank you. Full of mark and energetic performance. Actually, few of the faculty members have recommended the name of this Sampath. Earlier, they have seen his performance, and we have recommended this boy. Thank you, Sampath, and thank you, Raj. And now I once again request Master Manaswini for her performance, dance performance. Again, thank you, Manaswini. Really, you have a great future ahead. On behalf of our University and College of Horticulture and Conservation, we wish you a great future. And also, one more thing I would like to express on this occasion. Mother is an acupuncturist, so Pushpalata. So, in spite of their busy schedules, she encouraged her daughter for performing this classical dance. Thank you very much, madam. Next performance is by Miss Gayatri, relative of Srimati Supanar Sama.
Well then, he's probably riding for me.
என்னவாமா காடத்துக்கு ஊரே ஆடுவேன் அதுக்கு ஒரு அடிய போட்டு விடுவோம் அப்படின்ற
Ms. Gayatri, with the permission of our dignitaries, we would like to present a small gift to our Manaswiti. They just want to leave, they have to go to Tirupati, sir. So as a token of love, we'll present a small gift to the girl. I request our associate dean, sir, Registrar sir and Dean of Horticulture, Padmatama Madam Garu, please come on to the dais so that we can. Manashwini, please come on to the stage. I also request Vijay Padma Madam, please come on to the dais.
Have a great future. You enjoyed your life.
Yeah, okay.
Thank you, sir. Thank you, madam. So the next performance will be by Meghna and group. The group can. PG student. So thank you, Meghna. The next performance is group dance by our first year student, Teja and Dhruv. Just one change. Now I request once again our two beautiful girls, Vedashri and Viniksha, to perform their dance. Thank you, Mark, baby. So we should really appreciate them, sir. They themselves have composed the song. And last time, the energetic performance by our first year boys, Teja and group. Actually, they are in summer vacation. Upon our request, they came only for performing. Thank you very much. And one more last performance, sir. Imaja and Meghana and Himaja, earlier when Tanuja madam requested them to come here to perform the dance, they said any reason, they came for one performance and they requested for two more performances.